understand this stuff on a higher level.
Stunning, thank you. I think we'll start with an open question. So like, we're here to talk about the Web3 skills gap. So how big is it currently? Like on both your open opinions, what are the current issues that we're facing with this right now?
I would say specifically if we're looking at onboarding Web2 folks, there is a skill gap that we must tackle. And it's not only, most of the cases, it's not only enough like to have these people prepared for the specific thing that they might be working on. Let's say, I don't know, a smart contract engineer only about smart contracts, but they need like rather a broad understanding about the ecosystem and how all the pieces are coming up together. So definitely there is these skills that needs to be addressed. I think there was a report from Electric Capital from 2023 that was saying that after 1 year, around 50% of developers are dropping out. So there is, I would say, definitely something we can do better as an ecosystem.
Yeah, I think it's multi-layered, right? Because there's a lot of blockchain protocols that are written in languages that may not be as common to find developers for, like Rust or Haskell. And then there's also a lot of specialized languages like Solidity, and there's a lot more languages that are cropping up now as the space matures. And getting people up to speed on something that they might not encounter in like a normal sort of software engineering course at all is, I think it's hard to do.
No, definitely. I think something we were going to talk about actually was the Polkadot Fellowship, and specifically about how we can retain developers. And this goes for all protocols and ecosystems, and trying to really ensure that we're compensating them well. And I say bringing that pool of knowledgeable devs large, increasing that size, really. So do you have any thoughts on that?
Yeah, so the Polkadot Fellowship is a great example of a way to compensate developers who are in the ecosystem and help them upskill. So for people who aren't familiar, it's an on-chain organization, a collective of Rust developers who are very familiar with the Polkadot protocol. And these developers can move up different levels depending on their familiarity, their contribution, and they are compensated on chain for their work. And I think this is a really good way to do it because it's all decentralized. It's really helping distribute the knowledge, and anyone can come in and start. And I think that's really important, is that anyone from GitHub can just be like, okay, I want to potentially join the fellowship. How do I get started? And there's people that can also help you. Like there's a guide, and you can just work your way up, like depending on how much work that you want to do. And I think that's a really good way to get into protocol development.
Yeah, I think it's a good opportunity, especially in this decentralized world that we're trying to push towards, to try and compensate devs fairly. Bianca, I actually want to talk about something similar. So the DevRel Uni. Could you give us a bit of information and background about what it's trying to accomplish?
Sure. So basically back in 2023, I realized that while for developers, there are a lot of avenues, like for people to skill up, there wasn't actually much for people who wanted to get into developer relations. There was like no clear path, no like boot camps, no courses, nothing like that over there. And I was like, okay, I'm doing developer relations. I have like a good network of people doing developer relations as well, and we can actually address this gap in skills and do something. So far we run 6 cohorts. With the 7th upcoming very soon. And yeah, we enable a lot of people to get from 0 to 1 and get into developer relations and further support the ecosystem and onboard at their turn more developers.
Stunning. There's actually something quite similar, I think. Maybe Erin, you could talk about this, which is the PBA. They're very, very similar initiatives, I would say, and very both trying to target those developers and upskill them and bring them into the Web3 world. And I guess you don't really even have to be a developer. There's founders tracks and all sorts of different things. So could you give us a bit of background on that?
Yeah, I mean, I think again, like there's multiple components here. Like obviously we need to have people that are willing to get the skills as a developer and get into blockchain development. But then we also need people to reach out to those developers. And if they're like very new developers, maybe they don't know how to get started, or they're budding developers and they just need help, or they, like retaining those developers once they start is really, really important. So it's kind of like this whole pipeline, right, of developer relations, developers, and it's like, a circle. But the PBA does help people, get completely off the ground with protocol development. And there's also, space for teaching people how to write dApps, regulation concerns, founders who may want to learn how to get started in the ecosystem. So I think you need like a really sort of multifaceted approach. Like you need to hit a lot of different types of personalities, because otherwise, you can't just like spearhead one and have one, because you can't have one without all the others.
Well, that sounds good. It kind of leads me to think that if considering we have to have these sort of like, DevRel Uni, PBA, are traditional colleges and universities doing enough? Like that is the open question here. Are they providing students who have got these degrees fresh out of university with actual knowledge to get into like a blockchain or the ecosystem and actually start developing?
I think it really depends on the universities and colleges. I can probably speak a bit about Europe and Germany since I'm based there. I know there are like several programs and universities who have been incorporating for a couple of years now already information and courses about blockchain. So I think that's definitely a good trajectory. But I think what is happening and is more effective, it's at the level of different clubs, different university clubs, and I've seen this quite a lot and quite in a global approach, if you want, where all these clubs are collaborating very closely with different protocols, different hackathons, and bringing new talent.
Yeah, I mean, my university experience was not preparatory for my job at all. And I think that a lot of these sort of like, especially in America, these older colleges, universities that have more classical computer science educations, like they may not even have much to do with software engineering as well, because it's more of a conceptual degree. I mean, obviously there's software engineering degrees as well, and electives and things like that. But I do remember one time I brought up IPFS to one of my professors as a possible research subject, because this was back maybe 10 years ago or so. And he was like, oh, well, no, we should do something with like AWS Lambda instead. And he's like a distributed computing professor, so I thought he would find it interesting. But I think there's a lot of progress to be made in academia to make academics more consider, at least starting to look at some of these new things as something interesting that they can actually look into in research, rather than just like, oh, well, it's new, so it's not been around for 50 years, so we're not interested in it, kind of thing.
How do we begin to do that? I think there's a few initiatives that people are trying to do, like, for example, the EZA guys, shout out to those guys, but they're trying to bridge that gap by also working with higher education initiatives. And same with like the Jam Tour that's currently going on. Do you want to talk about that a bit, or?
Yeah, so the Jam Tour is going around to different universities throughout the world in Asia right now. And it's, Gavin Wood is speaking about the new Jam protocol and the gray paper. And that's one way to get students interested in this sort of thing. But again, I think there needs to be more focus on the acceptance of these protocols into the research world, the academic world. We're seeing a bit more of it, and I think that's good. I think it just may take time. But definitely going around to different universities and just talking about your stuff, getting people interested in it, because I think a lot of people just don't even know what's out there.
100%. Bianca, is DevRel Uni working with any like third-party programs or initiatives with higher education initiatives as well?
Not specifically universities per se, but again with different clubs from universities so far and protocols. So yeah, that's been like the two avenues so far.
No, sounds good. Do you think there's a fear from universities trying to adopt blockchain culture in a way?
I mean, I think there's still a lot of PR to be done because people who may not know about the intricacies of it and what's actually happening here may have a bad perception of it or, you know, at best neutral perception, where they might not find it interesting, they might not consider it a field that they can go into. And I think getting people just that first step is possibly the most important because people may not even think about it. It's something that they could even do. Because, you know, people are like, oh, well, I want to grow up and be a software engineer and work at Amazon or whatever. But there's other paths you can take that are very interesting fields, and letting people know that as early as possible is probably the most important, I would say. But then obviously retaining developers as well. Like once they've taken that first step, we need to be kind to them and we need to support them along the way.
Bianca, do you have any?
I think we're actually a bit more flexible as an ecosystem when it comes to like formal certifications, and I think proof of work, if you want, like portfolios I'm referring to here, are way more important in our industry. And I've seen actually quite young talent that was able to advance their career and enter the ecosystem just by like building and showcasing basically what they're doing, building in public. And I've seen a couple of examples when people quite young, they were able to get into the ecosystem. So I think versus the traditional Web 2 path, we are a bit more flexible and we value more the skills themselves than some sort of paper or name on a piece of paper.
No, sounds good. Do you think it's possible to try and onboard the Web 2 developers in any sense? To try and bridge them over? How hard do you think it is to try and bring them into the Web 3 world?
I don't think it's hard once they want genuinely, like they want to onboard, because I think we have like different mechanisms. We have like a lot of hackathons, we have a lot of initiatives who support developers. But again, like as you were mentioning, people need to be aware about those initiatives. I remember back in the days when I was looking to onboard myself, but I mean, back then there weren't like as many as we have now. But I think for someone who's outside the ecosystem, it might be a bit more challenging to discover those opportunities.
Yeah, I think people just need to be handheld a little bit at the beginning. And it's hard to do this, right? Because you don't want a protocol going to an institution or, you know, doing outreach or whatever to look like a shill. You want it to look legitimate, like it's a legitimate, you know, route of, you know, a legitimate career route, which it is. And I think, like I said earlier, like people just may have this wrong perception or whatever. But it's hard, I think, to make Web 2 developers understand why going into Web 3 may be interesting for them. And the value proposition for them career-wise may not be evident or obvious. So I think, and because it's easy to stay with what you know, right? It's like this very comfortable paradigm. So I would argue that in order to do this, one of the best ways to do it is, you know, developer relations and also having really good tooling that is very familiar to them, that feels like Web 2 tooling, that they can pick up, they can experiment with, and they can just kind of take off, you know, because good developers all like learning on their own, I think, to some degree. And if you have interesting and engaging enough tooling that's easy to use, that can really draw people in.
100%. I think that ties quite heavily into DevX as well, and ensuring just generally when a developer comes to the ecosystem, the entire developer experience is as simple, especially with the users as well. UX and DevX go hand in hand. What would you guys say about that? specifically asking about how DevX, ties into the whole situation with DevRel and DevX working together.
Yeah, so if you're coming from the Web2 ecosystem, I think there is a bit of accommodation, let's say, that you need to get used to, and you need to learn, like, okay, what I should do, and to get over your fears. I think, especially for new people, they are like, okay, if I'm doing this wrong, like, it's all on me, and a lot of the times this fear of something might be going wrong might hold them back. So I think we can do better efforts into educating people on, okay, how to onboard properly, how to do it, how to test, what mechanisms are out there to kind of make sure that the step you're about to take won't have any bad consequences. And I think all this can be solved with better education.
Yeah, I think developer experience is kind of like user experience in Web3, right? It's hard. It's hard, and it's improving every year. And I mean, I've been in blockchain for a very long time now, and in the past 3 years, like, things have gotten much better. But we still have a long way to go to really make that development experience really good for people, especially with so many different players in the industry, and each one having their own separate tooling, and each might work slightly differently, each protocol having its own quirks or its account model or whatever you want to, anything. Like, it's like learning new paradigms a lot of the time. And I mean, this is why the EVM is so huge, right? Because it's everywhere. And so people usually start with the EVM because it's ubiquitous at this point. But like, with all of these, new chains and new VMs and stuff like that, I worry that the tooling may become more fragmented, and as a result, suffer, and developer experience will then suffer. So it would be nice to see some standards across the industry in terms of tooling and, like, how to work with developers, especially like Web2 developers that are new to Web3. But I know that's a very hard ask.
I think we have time for maybe one last quick question. So in both your opinions, what would be your both immediate next steps to try and curve that developer relations gap, or the Web3 skills gap?
I would say that we definitely need to get more of this stuff into curriculums, and I mean in maybe a generic way, and make it interesting for people. Like, make it obvious what is in it for them, and not just about monetary. There's a lot of very interesting research going on in the Web3 and blockchain fields, and obviously cryptography is a huge one. And there's all sorts of stuff happening all the time, and I think it's about getting these people excited, getting them engaged in the first place, and then having all of the stuff in place to keep them engaged, and make sure they know what the path is, because if the path is not clear, they won't take it.
I would say probably better continuity between different initiatives. Like, we have hackathon programs, we have grants, we have like different initiatives we've been discussing, kind of having better shaping this journey of taking developer from 0 to 1 and having a better continuation between all these initiatives to kind of retain the talent over time and to enable them to find the opportunity in the space.
Amazing.
That's as a founder or joining a protocol.
Stunning, thank you. I think we've got to end it here, but a huge thank you to our panelists, Aaron and Bianca, and thank you to the team for organizing. Yeah, I think this is it. Thank you, guys.
Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with for do with for do with do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than.
Hey, I'm Camila. I am Solutions Engineer at Unlimit. And today we are going to present to you how to build a global payouts platform using crypto via Unlimit. Let's start say that Unlimit has one of the largest proprietary payment infrastructure globally. So in terms of payment processing, global cards, acquiring, and APMs, also BaaS, the ultimate configurable BaaS API platform, accounts, multi-currency IBAN accounts and cards. We have more than 150 payment method different. And crypto on-ramp and off-ramp to easily onboard users. Now let's say that Unlimit different type methods of integration. We can start with SDK. The SDK provides libraries for and different type of languages, so you can pre-configure functions to simplify the process. And you can have also parameters, so you can build in terms of matching with your solution. API integration. This method is pretty famous, so you can manage every aspect of the integration, but it requires more coding, so you need to put more effort on that. And also HTML link integration. The HTML link integration is a quick, lightweight solution, so you can use link integration, so you can use the parameters to match with your solution. So for example, you want to skip the wallet screen or skip the exchange screen. You can do that with HTML link integration, and doesn't require any coding, so it's pretty simple to integrate that. Also, we have the white label integration, which we developed last year. What is the fully brand and customized user interface. So the white label integration requires more coding. So 100% is customizable. So in terms of UX, UI, you can use your white label integration to match with your use case. White label API, let's dive into to understand a little bit more about it. White label API, we have a collection of user account creation, KYC management, quote generation, and on-ramp and off-ramp transactions. So you can use our API of using creation to create a user in your solution. So you can link multiple bank accounts of the user in local currencies. Also, you can use cards, and you can also, for example, do onboarding user through the QAC. So you can create the user and pass them through the QAC just once. And you can collect and verify customer information and create and access customer profiles and update and submit QAC documents for compliance, which are some of our APIs that you can use to pass the user through the QAC. We also have the code generation. So the code generation, you can generate the codes for on-ramp and off-ramp transactions. And you can retrieve using a simple ID. And lastly, we have the on-ramp and off-ramp transactions. So you can initiate and track on transactions for converting fiat to crypto, or you can convert the crypto to fiat. So now that we understood what is the white label, let's see some advantages of the payout. Global scalability, simplify compliance, as we talked before, so you can pass the user from the user creation through the QIC once. Operational efficiency, full control over user experience and customization of payout experience. So you have the total control of the UI, the UX, and the process of the user. And tracking and advanced reporting, so you can use your own tools to monitoring, for example, which are the regions that requires more attention or more, for example, where you want to get more reporting. And also flexible monetization models. So we have many of models that you can use your off-ramp APIs, and security and data protection, which is a super important topic. Now let's explore some use cases. So individual off-ramp payouts. So for example, if the person receives the salary in crypto and wants to do the exchange, you can totally use that with our off-ramp API. So you can use your company to do this exchange. Cross-border crypto to fiat off-ramp. So for example, if the user is living in another country and receive the fiat in this another country, he can exchange the crypto to fiat and send to his card, for example. Crypto to fiat off-ramp for P2P transaction. So for example, you need to send some fiat money for your colleague into another country. You can do that with off-ramp API. It's pretty simple, and you can send them fiat money. So now we have a flow example. So now that we explain what are our white label APIs, we are going to show you an example of how is in the real life, for example. And this is the sign-in page. Let's say that this user doesn't have an account yet. So he wants to create an account and complete a transaction. You see that it is very simple to do that using our APIs. So the first page, the sign-up page, we grab some information of the user, for example, first name, last name, email, password, and we have those fields so you can use which are user account creation API to just create the user so he can start creating transactions. But now let's see that we also will pass them through the QIC, grabbing those fields, date of birth, phone number, nationality, and country of residence. So as you can see, we created the user and you pass them through the QIC level 1. And now we have the profile information of this user. So here we can also update the user information using our APIs. So let's say the user added a wrong last name and he wants to update it. You can do that using our APIs to update information of the user. Also to create and link bank details into the account. Now let's go back home and you can see a simple page where the user can add the amount to sell. So for example, we add a few amount here and the user wants to exchange the B2C to euro, for example. You can use that using our code API to show the user how much you receive. You will send him into an order summary page where you can, where he will know how much he will pay, how much he will get, and accept the terms and conditions. Once they click on Sell Now, it is our off-ramp transaction API. So he completed the process. So we created a user, passed them through the QAC. He could update all the information. Also, he could complete the transaction. Now, in all orders, we can call another API to show all orders from that customer information. So our white label APIs are pretty customizable and flexible, and this is a simple example that we show you, but we have many other examples that we could achieve using our white label API, and it matches perfectly with your business use case, so you don't need to use all of them. So you just need to match the APIs into your business use case to make sure that you are achieving what you would like to. And he could create another transactions here. And this is all. Thank you.
For the code reload, got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Blood eyes everywhere, match 3 bird phones, quantaries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing. You're just a rat with firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. To get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin. Air Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial up found. Old as speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test. A boodle. Oh, he jumps right. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Bend it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing. His firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Bubbles flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spin. Urging nodes dancing where the bottlenecks been. Professor Waze got the future on spin. Plug in tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age? Old as speak, young as each block mine down. Professor Waze got the future on spin. Urging nodes dancing where the bottlenecks been. Professor Waze got the future on spin. Plug in tomorrow with yesterday's RAM stains. Beta test for Boodle. Oh, he just got to oh, he just got to oh, he just got to oh, he just got just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and a hurt bubble, watch it crash. But we don't need your central banks. Regen biddlers stacking stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. Chains.
Okay. Hi, everyone. So thanks for coming today. I see it's mostly our weavers in the audience. But woo, indeed. Yeah, thank you all for making it. yeah, I wanted to talk today a little bit about the internet and trust. When we were building AO Core, which is the primitive that basically runs AO, the hyperparallel supercomputer we're building on top of Arweave, we had reason to spend a lot of time thinking about how you could say commerce on the internet, but also more broadly how the relationships of trust in cyberspace actually play out in real life, in the current internet, and how that could model or map onto more trustless systems, and how you'd actually make that work at scale. Because AO already looked quite a lot like the existing internet in architecture. But the blockchain-based consensus models of trustlessness don't really scale to that environment. So with a traditional blockchain, really with almost, I guess the only exception is rollups, but with every other type of blockchain that exists right now, there's this fundamental idea that you have many different validators of the different transactions that happen in the system. And I think you can model each of the transactions that happen as relationships of trust, right? So in the traditional internet, you would have this situation where a user speaks to their bank and they say, hey, please deposit some of my assets into an exchange. And then they would ask the exchange to swap them, and the exchange would then inform the other participants that were counterparties to that transaction about the state transformation of the system, essentially. But what doesn't happen in this model is that many people that were, you could say, tertiary, outside of the transaction itself, were even aware that it occurred. And that makes the internet extremely scalable. And it also makes blockchains, which do the opposite of this, extremely unscalable, generally, by default. So AO already had this sort of fundamental idea of, instead of having one global shared state, we should have many different interacting but independent processes in the system. So that sort of models the situation you have here. You have the users, and they can also be different agents in the system that are autonomous programs, and exchanges and banks. We have like liquidity pools and AMMs and on-chain order books, and also obviously token processes, which essentially fill those roles. And they all already act independently. But I think after spending a lot of time thinking about it, what we realized is that what we're trying to do is basically just add a trustlessness layer to the existing internet, rather than building something entirely new from the ground up. And I think this is inevitably where things will have to go if these technologies get adopted. And the problem itself is sufficiently large, I think, that it is definitely worth addressing. So even with a traditional blockchain-based system, and this is like really underappreciated, everyone thinks when they're interacting with Ethereum, yeah, my transaction is trustless, right? Well, actually, it's not really, because almost all the time, people aren't running their own validators. And when they're not running their own validators, they're having to rely on an RPC service to give them a state representation. And interestingly, that Bybit hack a few days ago, it turns out that actually that appears to have been an attack on the Gnosis safe infrastructure that was serving the web pages, that was specifically targeted. It only activated when the Bybit wallets connected to the front end, and then it swapped out the transactions that they were signing. And so you see, this models exactly this situation. So you have Ethereum, this sort of green zone here, where, yes, the interactions are actually trustless. Or, I mean, arguably, if you want to get like philosophical almost about it, you need to trust your own computer. So like, in what sense can anything truly be trustless? there's always trust somewhere in the system, right? Like your machine itself might not be trustworthy. And this becomes slightly more practical when you think about things like TEEs in CPUs, or RD-RAND, the instruction that Intel had that was supposed to generate truly random numbers, or at least pseudo-random but trustworthy numbers. And it turned out that actually the NSA had a backdoor in RD-RAND, so the numbers that they were producing were not, in fact, properly random. They had a backdoor. You even need to trust your own machine. With TEEs, you have to trust that AMD doesn't just sign to say, yeah, trust me, this key is inside a physical piece of hardware that we ship to people. That's a high level of trust. And there's a bunch of others. So yeah, the quest for true trustlessness, I think, is almost futile. There's no way to directly connect with a machine that will remove every single layer of trust. And even then, you have to trust the software. So the question is really about trust minimization rather than trust removal from the system. But when you use Ethereum, for example, so when the Bybit multi-sig participants were logging onto the website, they were trying to move their funds around, what they thought was a trustless system actually turned out not to be, because the edges of the protocol connect to the user via private, but not, would you say, state transformationally secure systems. And the cost of this in the real world is enormous. Like, people don't think about it because as far as I can tell, everyone is so used to having to trust the services that they work with that it's just like subconscious at this point. But I think a really easy way to see it in practice, or to gain some sort of sense of the cost of it in reality, is to look at the cost of storage in different cloud providers. So Amazon will charge you $24 per month per terabyte, which is, I mean, you can take $150 to the nearest Best Buy and you get like a 16 terabyte drive. So for 1 month, you're paying twice as much per terabyte as you're paying for the entire drive lifetime, just for the physical hardware. And yes, there's a lot more that goes into running the physical hardware, but it gives you a sense of the level of margin here. And there's also services like Backblaze, B2, which is actually like pretty well trusted. It's quite widely accepted as legitimate. And their cost is $6 per terabyte month, which is a fourth of the price. And yet, most of the business still goes to AWS. And then there's Arweave, which charges you about 78 cents per terabyte month. That's what the miners pay on a per month basis, or rather are paid on a per month basis. And then there's Chia that pays its miners 12 cents per terabyte month. So the markup from Chia, those miners, to AWS is 200x. It's like enormous. You could, in theory, if you can orchestrate the network correctly, offer storage at 99.5% less than the price that Amazon is willing to sell it to its customers. And those customers are willing to buy it at like en masse. If you could get this right. So the cost of trust is extremely, extremely high. That is really the only thing that Amazon has, that and distribution to existing clients, that Chia doesn't have. Although actually Chia doesn't let you store data, so it's slightly moot point. But if it was like Arweave and it allowed you to add data to it, then this would be the case. And certainly for Arweave even, it's going at like 26th of the price, something like that, relative to AWS. And I don't think it's just hardware provision or sort of compute fundamentals, you could say, like the things that you would otherwise buy from a cloud provider. It extends to everything you do on the internet. So every exchange, for example, they take a small fee. Every ETF, I think, is a really clear example, because the ETF is actually just algorithmic. Like when someone buys an S&P 500 tracking fund, they don't want anything else to happen other than the obvious basic algorithm, which is just maintain the weights correctly in the fund. That really isn't super difficult. But if you look at the amount of volume that goes through those systems and their fees, you see that actually, collectively, we're paying an enormous, enormous cost of that trust. So it seems like a worthy problem to solve. So AO is already a network with a similar architecture to the internet. It works by having many parallel executing processes with messages passed between them, rather than having a single consensus layer, which will fundamentally never scale. And you can see that it will never scale because you can how many validators multiplied by how many transactions do you want to have in the system, right? So for every interaction that happens in the system, if you were to scale that out to the size of the internet, you would have to have some multiple on top of that of people running validations of it. It works at small scale, maybe like 3 or 4 validations, something like this. But you can't get it to the scale that, say, Ethereum or Bitcoin is trying to right now, which is like 10,000 or 12,000, I think even up to different times, like 60,000 validators of every single interaction. So that's obviously not going to work. And I think the Ethereum community is also moving away from that model towards something that is closer to AO in some senses already. So we have all these parallel processes. And then it's also very clear that the trust that you want for moving $1 billion worth of Bitcoin is definitely not the trust that you need for a microtransaction when you're trying to stream a video on the internet, or really any like small transaction, like $5, $10, just doesn't need the same level of security, and you absolutely have to pay for that security. So like, it seems like a model that's not going to work. So instead what we do is we have a modular and flexible mechanism for adding security. We provide the primitives, and then on top of that, you can pick the security that works best for your use case, and then people can interact. Like, the important part is that you maintain the ability for people to interoperate between the different processes in the system. And we can do that with what we're calling AO Core, which is the primitive underneath AO, the supercomputer that we know and use today. So what we did when designing AO Core was not just to build out that specification I just described, but also then to embed it inside the existing internet infrastructure, such that if we were to gain wide adoption of it, there would be very little change required for the existing systems. So instead of building everything from the ground up and having sort of separate network, if you will, that exists on top of the internet, we embed it into the technologies that already exist. And then that makes adoption of it extremely, extremely simple, and subsequently much more likely to occur, we think. And all of this is based on this new internet standard called HTTP signed messages, RFC 9421, which basically described it's actually kind of interesting. Like, most people think that the internet is already secure, or because they have HTTPS, they have some kind of trusted relationship with the other server. And it's a bit in the weeds, but it's a curious point maybe for a developer audience. Actually, the way that HTTPS works, or TLS, which is the mechanism on which HTTPS is built, is that you use public key, private key pairs to authenticate and initialize a channel between two parties. But then you use symmetric encryption in order to actually pass the data between them. And this creates a problem, which is that the data that you get is non-repudiable. So both of the parties in that TLS channel could claim that the other party said whatever they wanted them to, because they have the symmetric key. There's no ongoing authentication. And so with HTTP signed messages, they were trying to fill that gap, basically, and create a more standardized way of actually doing what OAuth does, letting people authenticate themselves in a single HTTP request and validate with the server and get a trusted response back. And so when you use AO Core today, or actually any computation running inside Hyperbeam, so that includes AO processes, you get back a signed message. And it's not just a signed message on its own. you also get back a hash path, which is, it's like if HTTP paths, those things you put in the URL bar, were blockchains. And you get a reproducible, essentially reference to a position in the compute state space. So for any of the compute that you could perform, or any program that you might want to run, there is always a certain constrained set of different states that that program might be able to get into. Well, this allows you to address each of those in the same way that you address a HTTP resource on a web server. And then that's attached to the signature you get. So the signatures you get back are attestations of both the path that the server claims that it evaluated for you, and then also the content that is found at that path. And the net result of this is that you end up with a network that pushes the boundaries of the trustless space or trust minimized space, depending on which type of security model that you use, right the way to Alice and Bob at the edges. So not just, in fact, actually a good example would be this Bybit hack. Well, if the servers that Safe were using to serve that UI from were part of the system, you would have been able to validate that the data that was served back was not actually legitimate. All right, that's all we got time for, but we have an entire sort of program of events for our weavers later in the day. I think we start at 3 p.m., so I hope to see you all then. Thank you.
Just dreamers, on-chain truth, no middle schemers, working hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stacking stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffer corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes in.
Welcome, ETHDenver. We are Cadena, Layer 1 Proof of Work blockchain, and we want to talk to you about scaling EVM with parallel chains.
Great. So a little bit about us. As John mentioned, we run a parallel chain proof of work blockchain. And a little bit about me. My name's Stuart Popejoy. I'm a co-founder and the CEO. And I've been in technology since the 90s. And my relevant background here is I was a founding director of the JP Morgan Blockchain Center of Excellence.
And my name's John Wigley. I'm Chief Technology Officer at Cadena. I've actually been in engineering now for 36 years. And my team and I are responsible for the Chainweb and Pact technologies that we'll be introducing. And prior to joining Cadena, I worked in blockchain at Definity on the Internet Computer.
So we're going to talk about how we're taking the technology we've developed at Cadena and how we're going to bring it to the EVM ecosystem. But to kind of set the stage, I want to talk a little about scaling, which is obviously a topic that everybody's interested in. And just to get into it, and what's the promise and what's the peril in terms of scaling EVM technologies? So first thing I wanted to do is that when John and I think about scaling, having been in this industry a long time, been in tech a long time, we think of scaling very specifically as something where you have a resource that when you need to scale, you can throw more of that resource, and there's no limit on how much of that resource you can throw at it. So for instance, you have a website, you have a bunch of users coming in, you can throw more machines at it, you can throw more nodes at it, and there's no limit to that in order to be able to accommodate your use case, right? On the other hand, say you've got the world's fastest single node machine, then it can go to whatever TPS. Once you hit that top TPS, you're not going to be able to go further unless you have something that you can then throw at it to handle the next kind of burst of traffic or what have you. So today, what we see with Ethereum, of course, is that we're using rollups and layer 2 and layer 3 technologies to scale. And the progress has really been tremendous. We've got more blobs coming into the Ethereum mainnet, and it's really been successful enabling the Ethereum ecosystem to handle more traffic. So there's a lot to like, but there have been some drawbacks. And the main thing is with kind of decentralization and simplicity, in the sense that I think the reason why a lot of us are attracted to working in blockchain tech is that the idea is that in some way it should be centralized and it should be simple what you're trying to do, or more specifically, how you do it. So let's do a reality check. What is this scaling approach? What are some of the perils that we've encountered? And the first one is complexity and fragmentation. And that means that developers and projects, when they want to build a dApp and scale a dApp, have to make a risky choice choosing amongst diverse layer 2 platforms, or even run a layer 2 themselves, run a validator network themselves. There's a lot of complexity involved in scaling your app and potential fragmentation. The second problem that people are very aware of is that centralization has creeped in as people want to get stuff out to market that actually delivers on the layer 2 and rollup promise. They have had to cut some corners with decentralization, with sequencers, et cetera. And this has, it's something Vitalik has talked about, and it's something that is, it's regrettable. And worse, there's no kind of relief immediately in sight for how we're going to address the centralization issues. And then the last one is that decentralization is more than just a value. It actually adds up to real-world problems such as censorship and fraud when you have a small group of actors who might control a particular platform. So I like to look at decentralization as actually a security guarantee. When things are decentralized, you're actually more secure.
So what is the technology we've built to address these problems? We call it Chainweb. So in Chainweb, the expandable resource, if you could go to the next slide, please, is parallel chains. So we built this as a blockchain network that can grow with adoption and utilization pretty much forever without bound. In our network, the expandable resource that Stuart was talking about is our parallel chains. This is an environment in which there's no master chain, there's no hub. They're all equally independent of each other. And this is the only network of its kind right now in the blockchain landscape. Now, these parallel chains are unique in that they act as an oracle of each other's history. We use a mathematical construct called an expander graph that allows each chain to operate fully in parallel, completely independently, yet after a certain block depth, they each see the fullness of each other's history. That way, if an event occurs on chain A, chain B can validate a proof of occurrence by looking into its own history and seeing the history of chain A and being able to directly validate that proof. So this has the unique property that as chains are added, while efficiency and throughput increase, it actually becomes more resistant to attack. And this leverages the smooth divisibility of proof of work. I mentioned at the beginning that we're a proof of work layer 1 blockchain, and we chose that for its simplicity and some of the built-in security and decentralization guarantees we get with it. But it aids us as well in our parallel chain environment, because as chains increase, and we're able to increase them at any time, the divisibility of labor is also an advantage. The miners are now able to mine across a growing and growing pool of chains. So the hash rate distributes smoothly across all the chains, which eliminates miner competition and means that the energy utilization per transaction can actually go down as the TPS is going up. So some of the real-world benefits of Chainweb is that this has been running in operation, in production, without interruption for now 5 years. So this is not an idea or a promise of technology. This is technology that has been serving our community for quite a while now. And it hasn't been a walk in the park. We have been attacked. We have had hash rate disruptions. But the benefits of proof of work have shown through every time. So this is a technology that's proven, and it's here today. In this environment, gas has stayed cheap, congestion has remained manageable, and it means you don't have to run any kind of node or validator network separate from the core consensus of the proof of work blockchain itself. The second technology piece to our environment is, we call it Pact. It's both a smart contract language, but also a set of protocols. And what Pact does is it leverages this secure and effortless cross-chain environment that I told you built on the expander graph, and allows us to design and deliver a parallel bridging protocol across these chains. This allows scenarios, for example, where you can do true burn and mint. So I can transfer tokens from chain A to chain B, where I am burning the tokens on A, minting on B, and achieving a complete zero sum for balances across all chains. And this is done effortlessly. You can think of it as a kind of bridging in which no oracle is needed and no validator network is needed. It's an intrinsic built-in concept for our chains. This means that builders on our network do not have to worry about congestions or gas spikes. Now, a lot of networks that are new do have low gas fees, so we're not new in that respect. But as businesses know, when you build on any network, gas becomes expensive with utilization. So as your user base increases, as utilization of your app increases, even as external events on the network happen that have nothing to do with your app, but represent a huge demand on the network, your business can suddenly face gas spikes that price your users out of your business model. And we are able to provide an environment in which that does not happen. So 5 years into this journey, we're now ready for the next step. Stuart.
Thanks, John. So we're here today to announce Chainweb EVM. And we're really excited to be at ETHDenver because, EVM is what everybody's using, and it's the technology that we're all, using every day and very excited about and want to succeed. So today, the Cadena network runs 20 chains. We launched actually with 10, and then we forked to 20 chains, doubling our throughput. So later this year, we are going to once again double our chain count, but the new chains, 20 chains coming on, are going to be running fully standard EVM Solidity ABI that developers know and are used to and work seamlessly with all the existing great tools like Hardhat, et cetera. Not only that, so that gets you EVM, which you know and is familiar to developers. But on top of that, we've also introduced we're working on a draft EIP that brings the protocol that John was describing for secure sharing of assets across these chains. And in the case of specifically ERC20, you have the ability to mint burn from one chain to the next. And the thing to understand there is that this is a unique scaling technology in blockchain because normally when you move things off of a chain and onto another chain, you have to lock mint on the other chain and then release. And this is a different technology where you actually maintain the same overall balance of coins over all of the chains. So this is something new for the EVM ecosystem, and indeed there's no parallel chain architecture like this outside of Cadena in blockchain today. So it's something that it's going to be a new experience for developers, and that's where the EIP is going to be very important, not to mention our experience working with this protocol in Pact. The other important thing to note is that this is not vaporware, this is not a roadmap item, this is something that we are introducing a developer preview today where you have our Chainweb consensus running in a dev kit with 2 EVM chains so that you can deploy contracts right onto that and start testing out these parallel chain protocols yourself today. So we have a little demo for you. It's not a demo, it's a video because we're not crazy.
Stuart, before you go on to that,
yes,
one point I wanted to make really stress, because you might hear the term parallel execution from other vendors. I want to distinguish this from parallel chains. So you can think of parallel execution just like threading on a single CPU, where you're able to submit multiple jobs that could exist and run concurrently on the CPU, but the CPU at the end still has to sequentially sequence the updates to memory that happen as a result of the work being done on these threads. In a parallel chain environment, that's more like having multiple CPUs that are all making their own updates to memory at the exact same time. So this is true parallelism rather than some sort of optimistic threading scenario.
Yeah, that's a good point. So let's take a look at this demo. We had our UI team throw this together because it's not the most exciting thing to just show Bob sending coins to Alice on a different chain. So they put together something that is basically something that allows you to run the transfers and give you a block explorer in a interesting kind of throwback MP3 skin. But this also shows you that all of our stuff works with all the latest JavaScript technologies. It's very easy to build apps leveraging all the great EVM technologies, and indeed, even easy to handle the multiple chains in the development environment that you're already very comfortable with. So what the demo shows, and this is just a quick video to kind of give you an idea. We are actually running this. We'll have our booth running tomorrow over in the booth area. And this will be running on a laptop, so you can actually dive in and look at the gritty details of how the burn mint. So this is an ERC20 burn mint protocol. You have Alice funded on chain A. You have Bob funded on chain B. And Alice sends coins from one chain to the next. Bob sends it back. And the important thing is that this is very easy to do. This is not something, again, it is fully trustless. This is not something where you have to worry about getting wrecked in the middle of the transfer. And indeed, it's a fundamental protocol of our network such that the KDA token, which is the token that runs on our current network, will also be on these new chains such that the token moves around on those chains with the burn mint, and no tokens are created or destroyed in this bridging protocol. But you can use it for anything. You can use it for NFTs. You can use it. You can share assets, any asset, anything you want across all chains. Do broadcast, all that kind of stuff. So it's truly scalable. And in a situation where all those 20 chains are hitting their utilization limits, then we can fork to 50 chains, we can fork to 100 chains, we can fork to 1,000, 5,000 chains. There's actually no limit on how many chains we can fork to because, as John mentioned, the proof of work is smoothly divisible to essentially an infinite amount of chains. At some point, of course, bandwidth and some other considerations start to come into play, but we're way away from that moment.
So how does this impact you? One of the important things I've mentioned a few times is avoiding these gas spikes and not having to fight to get into a block. This isn't just about keeping gas prices low. This is about keeping them predictable and manageable within your business plan. You also don't need to run your own app chain. And what I mean by that is one of our core principles is to restore the simplicity of blockchain. Blockchain has a lot of promises in it that, of course, as a maturing environment, we've realized certain stumbling blocks, certain difficulties related to scaling, which have brought up a whole bunch of subsidiary and external technologies to try and mitigate these difficulties. We think they can still be solved within the regime of blockchain itself. These are also mature tools you now have available for scaling. Not just on the Ethereum side where you can use Hardhat, you can use Block Scout, you can use all the tools you're familiar with to work with our EVM chains, but you also have our mature tooling, the 5 years of experience we've had building these bridging protocols and developing the packed environment.
Yeah, and a little more color on that. We not just experience building these things, but working with builders. So one of the most successful apps in our current ecosystem is a DPIN protocol that they didn't really think about. They're in the single chain mentality, which is understandable because that's how pretty much every blockchain presents the compute environment to you. And so they were on a single chain, and indeed they were getting to the point where there was congestion and gas prices were starting to go up. So we worked closely with them to help them scale the app onto multiple chains. So, because it's a little different for every app, and there's many things you can do. There's things you can do with optimistic protocols for instantaneous liquidity across chains. These are all protocols we have. So if you have an idea, you should come talk to us because there are ways that this scaling can benefit you that aren't immediately apparent.
So how can devs get involved? So there's a couple of things I wanted to point out. One is that this is a blank slate for builders. Since we're introducing this today, really, this is an ecosystem and an environment where there's not a lot of competition yet for building out big DEXs or big applications in the space. So developers coming in have a first mover opportunity to get started before the space gets crowded. It's also very easy for you to port and deploy an existing EVM app into our chains. I tried it with Uniswap v2 and v3. In an afternoon, I was able to get both running on our chains. We also have an early access EVM developer community, and there's going to be some giveaway opportunities there if you join us on our Telegram. We'll have a QR code in a moment that'll show you how to get there. And you can come meet us at our booth tomorrow. We'll have several of our team there, our DevRel representatives and some of our devs, where we can talk more about how you might be able to use this technology for your own applications.
And we're also doing some giveaways, $500 giveaways for joining our Telegram group or participating in an ideation process. But the biggest news is a $50 million grant program. So we're putting money behind bringing people, putting money where our mouth is. And again, so if you have an idea about an app that that you've got running on EVM, but you're running into scaling issues, come talk to us, because we really want you to check out what we have, and we're here to help. And money always helps with that. So, come on over. So that's it. We're at booth 425. That's tomorrow. And we're really excited to meet all of you, show you the demo that we just were demonstrating here, and answer any questions you might have. I don't know if we got 41 seconds yet. I might have time for a question. I don't know. Oh, no. Getting the...
If you have questions, keep them. Bring them tomorrow. Happy to answer.
Thank you so much.
Thank you.
Alliance architect with the buffer corns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, flurry, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to voted fuck. Stealth crawl through your junk dancing. Bend it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing. You're just a rat with His firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like runs dial-up found. Age? Old as speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a bait.
Hi everyone, my name is Yuming. I'm the CTO of Gravity by Galaxy. Today we'll talk about how to build an ultra-fast EVM blockchain without millions of dollars. So think about this. DeepSeek managed to train the state-of-the-art model without a giant hyperscale GPU cluster. And the guiding question for us is it possible to build an ultra-fast EVM blockchain without massive funding from VCs or the crowd? So our mindset are very clear. If we want to do this, we have to leverage solid open source components as much as possible. And we need to focus on measurable engineering metrics instead of buzzwords like we got building some kind of another AI chain. And another goal is we're going to build this for public good instead of some kind of alien technology hype. All right, so many people consider building blockchain not rocket science. I agree, but it's neither trivial. So under the hood, there's a lot of things. So this is a traditional blockchain architecture. There you see all these components actually has a lot of like practical innovations that we need to do to reach very high performance blockchain. So for example, for execution, people always talk about parallel execution, and we want to do JIT or AOT to speed up the execution. And for storage, you may consider to employ a fully asynchronized I/O storage, and you have choices between RuxDB and DBX. And for consensus, there's also research and studies for new consensus algorithms as well. So to start with, let's start by choosing the right consensus algorithm. So our criterion is we wanted this chain to be so-called sub-second finality with more than 100 validators. We want it to be high throughput for independent transactions, meaning that, for example, your Uniswap transactions. We want it to be production ready and bottle tested implementation, and we want to get it done within 12 months. So we explored all options, like on the PBFT family, you got Tendermint, Hostile, Jortian, Aptos BFT, and there's a lot of fancy DAG-based consensus algorithms as well. So it turns out that Aptos BFT is a champion after our exploration. So some insight about Aptos BFT. So Aptos BFT is an improved version of Jortian consensus plus the optimization called order votes, which reduces the consensus latency to 3 hop. And for people familiar with consensus protocols, to reach PBFT, to reach BFT, actually the minimal theoretical liminal lower bound is 3 hop. And Aptos actually, their code, their implementation has the highest records on production. In last summer, they have 300 million user transactions in a day, which averages to 3,700 user transactions per second over the whole day. They have more than 150 nodes, and their block time, meaning the gap between generating 2 blocks, is around 220 milliseconds. And in their latest research, the end-to-end latency is around 380 milliseconds plus the client latency depending on where you are. And the bonus is that they actually did a bit of research on how to provide an instant on-chain randomness If you are interested, you can read their paper. But in general, that means that you need any oracle. Your blockchain validators also generate a verifiable randomness upon your request. So as they are also rapidly developed and innovated, there has been more than 100 AIPs pushed to production, not just draft. And some people ask, like, why not draft? Why not DAG-based consensus algorithm? So the reason is that in a scenario for DeFi transactions, all these transactions are interdependent, meaning that the stack-based transactions, the fast path that you don't need to run through a total ordering doesn't work. All right. Although the state-of-the-art consensus can hit some bottleneck, so the novel paper actually revealed a very interesting insight that the leader node's network I/O is actually a major bottleneck. If you look at the diagram on the right side, the light blue one is the hot stuff algorithm without solving the I/O issue. The TPS is somewhere less than 10K, or maybe just even smaller. But the darker blue one is the one that you actually solving the network issue, that you easily reach 50 or 75K. So what Aptos does is that they introduce a very simple and elegant mechanism called a quorum store, meaning that validators basically pre-share transactions into batches, and validators form a quorum store, proving that they have stored all these transactions already, so that when leader proposes a block, they only need to propose the proof of availability of those batches. And then upon execution, validators can always fetch transactions from other validators. And even more surprisingly, this mechanism, even being very simple, can be horizontally scaled, which meaning that you can actually have infinite TPS you want. So this is a diagram we also got from the novel paper, that with more workers per validators, your TPS can actually reach a very, very high level. On the right-hand side, you can see that with 10 workers per validator, if you are running narrow with hot stuff algorithm, you can actually have, I think it's around 600K TPS. Okay, besides the consensus, what Apple's also innovated is the pipelining architecture of a blockchain. So traditional blockchains, like the diagram I showed before, you first do transaction dissemination, you get all these transactions, validator propose a block that contains all these transactions. But in a pipeline world, consensus can be run independently with execution. So in this case, when block 100 is actually certifying all the changes, meaning it's generating its Merkle proof, the block 101 is actually doing execution, and the block 102 is actually still running consensus. So that means that with pipelining, you'll be able to reduce the latency. So for example, let's say consensus takes 200 milliseconds, execution is 500, commitment is 300, and percent is 100. For traditional non-pipeline blockchain, it will take almost like a second to finish a block. But for pipeline architecture, it's only the slowest stage, which is 500 milliseconds. These also comes, these benefits actually coming from much higher resource utilization, where in consensus, most of the resources are spending on network I/O, and when in execution, it's CPU bounded, and storage is just disk write. And so, let's say Aptos has already built this solid ground. Can we modularize Aptos? The answer is, of course, yes. So that's why we built Gravity SDK. So Gravity SDK is an open source modularized blockchain framework that's designed to be scalable and flexible. We do that by modularizing Aptos bottle-tested components. And that means like in this Gravity SDK, you get quorum store, mempool with quorum store for free. You get Aptos BFT with very low latency, and you get this pipeline architecture. So this is also the first of its kind, like pipeline the blockchain SDK as we know. And it's very easy to use. We don't want developers to know all these details of pipeline blockchain. So that's why we build Gravity Consensus Engine interfaces. So Gravity Consensus interfaces basically abstract out the whole consensus process from building a blockchain, that the developers, basically, you only need to implement all these 4 interfaces, that you tell consensus, well, is this transaction a potentially valid transaction upon the current stage? And you send transactions to consensus, then you will use mempool and quorum store to broadcast it. And once consensus order those transactions reach the block, you will send this order block to execution layers. And execution layer, after executing all these transactions, you will send back the block hash. And the consensus will run another set of finalization upon the block hash, which the whole process also piggybacked on the Aptos consensus. And once it's finalized, we'll basically commit and persist every results. So if you're looking at from the pipeline, the architecture will be like this. We're building a middleware called execution channel, where on the execution side, you basically, for each stage, you build a pipe. You build an internal queue or buffer or pipeline that transactions are sending through the channel to the consensus engine. Consensus engine continuously produce blocks to your execution engine. Your execution engine consume all this blocking order in your execution queue. And once you've done that, you send it back to the consensus engine and send back to the certified blocks commit, and you persist it. So Okto SDK is not just an idea. We've already built it for the past 6 months. It's fully open source, although it's still, we call it a pre-alpha version. But our initial benchmark is already very impressive. For simple concepts like row transfer, we reached 120,000, it's a 12,000 TPS. And for block count with our default configuration, it's less than 500 milliseconds. So that you can find the code here. We also built a demo project, a demo chain that is a simple key value store with Ethereum style account. You can find it here with less than 1,400 logs. Now you may ask, like, well, this is a very simple example. Why do we want to build an EVM blockchain? So that's what we did. So basically, we built upon REST. REST is the fastest Ethereum execution engine, and it's highly optimized. But so the challenge we faced is that REST is a traditional non-pipeline blockchain where things go just one by one. We introduced a pipeline execution engine called Blockstream Reactor that taking ordered block from the consensus engine, then execute it in a pipeline manner for all these stages. And you can find our code here. And there's also some other challenges, but due to the time limitation, I'll probably not cover. So the next step is, let's say we solve the consensus and pipeline issue. Our next target is the slowest stage of the pipeline. Remember that I said the execution is usually that one. Recall our goal of 1 gigagas per second. So an example is that if you want to have a 1 gigagas block for full Uniswap transactions, it's actually today, even you are running REST, it's going to take you 700 milliseconds. And this is under the assumption that the I/O latency is 0. In the real world, a 100 microsecond latency is actually very usual. So if in that case, the sequential execution actually can take 24 seconds. So that's definitely way slower than we expected. So that's why we need parallel execution and asynchronous I/O. So for parallel execution, it's actually a well-studied algorithm called a block STM. So what block STM does is so-called optimistic parallelization. In a very simple world, it basically executes a transaction all in parallel, all at once, as much as you can. And then you started the validation phase that starts to validate the transaction from the beginning. So now first transaction, everybody knows that it's not going to have any conflict. And the second transaction basically check, well, does it conflict with the first one? And then the third one checks with all these transactions that has been executed before. And surprisingly, to many people's surprise, the block estimate is actually very, very fast. Even it's optimistic. So in their papers, they can actually reach 160,000 TPS. And the slow overhead is actually pretty low. In a pure sequential workload, meaning that there's no opportunity to parallelize anything, the overhead is only 30% slower. Not just block STM, we actually did some interesting follow-up work based on block STM. So we call this Gradient 2.0, stand for Gravity Rust EVM. So instead of like we're following the block STM style that we basically schedule all these transactions one by one, starting from the lowest index, we actually schedule those transactions in parallel using a DAG. So this DAG can actually be obtained by simulating transactions in some other stage of the pipeline, fully shadowed under the execution. And then in this stack, we basically try to parallel execution transactions that has 0 dependency and the lowest index. And besides that, we introduce another mechanism called task group, where because we noticed that actually on the Ethereum mainnet, we look at all these history transaction data. There are many, many transactions that depending on each other tightly. So in our data, we will publish a paper very soon, but in our data, the P50 dependency distance between transactions is 2, meaning that most of these transactions have dependencies next to each other. So what task group is that it will basically, in the stack, merge those nodes that has tight dependencies into one task group. Then when we dispatch those transactions, we basically dispatch them as a group. So group transaction within the group won't be executed parallelly but sequentially, so that the latter transaction can correctly read the data that was right by the previous transactions. This effectively reduced the re-execution as the overhead. So the benchmark is also very good. We actually these algorithms can actually match block estimate performance for the most ideal case that independent transactions, which is definitely more than we need. And for high content workload, we put a transaction that has 30% transactions that depending on each other. It is like 29 times speed up, maintaining at least almost like 3 gigagas. And for non-parallelizable transactions, this mechanism nicely solved the drawback from block estimate, the 30% slowdown. We achieved only 3 to 5% slowdown than sequential execution. And because the re-execution is much reduced, we have 95% lower CPU usage if you just run block STM. So another thing that we found during this journey is that optimistic parallelism is actually way more effective than most people expected. So combining this, we have gravity chain. So the life of a transaction in gravity chain is that you'll first reach through JSON RPC, and it reaches the mempool and quorum store, and the leader of the consensus will propose a block and send it to our parallel execution engine. Then it will generate a new state that runs for block hash, and the block hash will run through another state consensus. And after all that, it will push to the storage for persistence. Yeah, so our next big release about rate staking module. So remember, initially you thought we want to build a proof of stake blockchain. And one concern we always had is, well, most proof of stake blockchains ask you to stake their own native token. I know this kind of was operated in a lending model or whatever, but we think it's not ideal. So by introducing rate staking, we allow other validators or economical security to be brought on Gravity Chain. So we were integrating staking protocols like EigenLayer and Babylon, which allows us to tap into Ethereum and Bitcoin's security level. And on the next release, we'll also introduce Aptos' recent optimization called Aptos, that they shadow all the executions by each other using optimistic tricks. Yep, so with that being said, with Gravity SDK, we believe that this is the first of its kind pipeline blockchain that reaches very, very high performance. With this kind of performance, we believe we can decentralize a lot more things than before. Feel free to come around and discuss and throw critical questions to us. You can feel free to also follow our Twitter here and also scan the QR code. Thank you.
Like, who's got the keys? Nullifier's huffing. You're just a rat with This firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected. I call it. Drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch they rock on PI. Get homemade in 7 for time. Shaboom, those that fish efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, boy. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto nodes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, boy. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Lag runs dial-up found. Old as speak, young as each block mine down. Professor Way's got the future on spin, boy. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just got you. 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 We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stacking stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stay She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized.
All right, folks, I think we're going to kick this off. Welcome to Smart Contracts, Smarter Agents. Thank you all for joining us. I'm Josh Nickerson. I'm a group product manager with Coinbase Developer Platform. I focus on our backend SDK, our wallets, and our staking API. I'll let Lincoln introduce himself.
Yeah, hey everyone. My name is Lincoln. I'm the product manager for Coinbase Developer Platform's Agent Kit. So we're giving every AI agent access to a crypto wallet and a comprehensive set of on-chain interactions. More about that a little bit later.
Awesome. So just by a quick show of hands, who all is building something that involves on-chain agents right now as part of this build-a-thon? Got a few folks, right on. Cool, and who all is new to building on-chain? A lot of folks, awesome. Well, cool, you're all in the right place. I think there's 3 main takeaways we want you to get out of this session. The first is just a high-level overview of Coinbase Developer Platform and the products that we have for you to use to build on-chain. The second is an overview of Agent Kit and what you can do with it to build agents that have on-chain superpowers. And then third, and I think most importantly, we want to inspire you with kind of our insights on what we see people building in the intersection of AI and crypto. So I'm going to chat for a few minutes about Coinbase Developer Platform and just give that high-level overview of everything that it's got to offer. And then I'll turn it over to Lincoln to talk through Agent Kit, which is built on top of Coinbase Developer Platform, and also those insights of what we're seeing in the space. So what is CDP? So Coinbase Developer Platform is a set of APIs and SDKs that empower you to build anything on-chain. And so the vision that we're working backwards from is 1 million on-chain builders. And I always like to ground things in that because, number one, that's a super ambitious goal, and I think it's really important to have that audacious thing that you're working backwards from. And then number two, that actually influences how we design and develop our builder tools. Because there's only like less than 50,000 builders on chain today. So to get to 1 million, we have to build a suite of developer tools that have all the power and low-level primitives that the existing on-chain builders expect and demand. But we can't stop there. We also have to make it intuitive and dead simple for Web2 developers that are transitioning to building on-chain, and also folks that are aspiring developers or may not even think of themselves as developers but want to get started building on-chain. So wherever you're at in that journey, we want to make it simple for you to build on-chain. We also want to make it simple for your users to get on-chain and to use the apps that you build. So you'll see that in several of the products that we have, and I'll give a few examples. The first one is Coinbase Smart Wallet, where your users can seamlessly get started with your on-chain app, and they don't have to think about setting up a wallet, understanding what that is, dealing with private keys, dealing with seed phrases. They can just use their email address or have biometrics that are tied to a passkey, and they don't have to think about what's going on under the hood on the crypto side of things. The second is Coinbase On-Ramp, where your users can really seamlessly on-ramp fiat funds into crypto. They can go through something like a guest checkout with Apple Pay, where they don't have to do a KYC process. They can just get crypto in their wallet really easily and get started using your app or using your agent. And then the third one I'll mention is CDP Paymaster, where as the app builder or the agent builder, you can sponsor gas for your users. So they don't have to worry about what is this gas thing? Why do I have to go buy this other token to do the thing I'm trying to do? You can abstract away all that complexity. So we won't stop until we bring the whole world on chain. We want to bring those million builders on chain so that you all can bring the world on chain. We're really excited by that vision. And, I think you're all here because you're excited by it too. So I've talked about a couple of these capabilities already with OnRamp and Paymaster. I'll touch on our wallets really briefly. So our wallet API makes it really simple, one line of code, one API call to create a wallet on the back end that can power your app, power your agent, or maybe you're creating them on behalf of your users. So there's a few flavors of those. You can have a classic kind of single private key EOA, where there's one private key that you're securing in some way. Really easy, quick way to get started. If you have a higher security bar for whatever use case, we also have multi-party computation, where instead of a single private key, that private key is sharded into 2 key shares. You manage one of them, and Coinbase manages the other one, and there's a really fun mathematical interaction of those that's required to sign a transaction. And then 2 days ago, we launched a smart wallet API, where with an API call, you can create a smart wallet on the back end to power your app or power your agent and gain the advantages of those account abstraction features, like being able to use Paymaster, being able to use arbitrary ERC20 tokens for gas payments, batch transactions, and things like that. The other one here that I'll mention is On-Chain Kit. So we have this powerful front-end library of React components that you can use to drop in things like enabling your users to connect to your app with their wallets, enabling them to earn with Morpho Vaults, and a variety of other things. Make a really beautiful user experience for them in minutes. This is a high-level overview of the CDP stack. So at the lower level, we've got networks. We support Base, Ethereum Layer 1, Arbitrum, and Polygon. See a lot of people building on Base for the secure, fast, cheap block space. We love that. There's an obvious kind of better together with Coinbase Developer Platform and Base. We also want to support builders wherever they're building. So we support those other networks. We're going to be adding more. At a level above the networks is our APIs. I've talked about several of those. And then a level above those is the on-chain kit, and then our backend SDK that I mentioned that's available in TypeScript and Python that gives you those really convenient, dead simple, high-level abstractions. And then this is just kind of the last view of just another way to kind of slice and dice our products. We've got that payment stack for storing, converting, transferring, and earning value on-chain. All these on-chain tools around data, Paymaster, verifications you can look into, and then all those, the SDKs and frameworks. And that's a good transition to Agent Kit, so I'll turn it over to Lincoln to talk through that.
Awesome. Thanks, Josh. Cool. So yeah, I'll be talking a little bit about on-chain AI agents. It's 3 buzzwords that separately get a lot of hype around them, and then when you squish them all together, it gets like exponentially buzzwordy. And there's a lot of noise going around, so really today I'll be sharing a little bit about how Coinbase Developer Platform is thinking about agents, the direction that we're taking things, and how generally we would encourage builders to build using Agent Kit. So this is a map of the crypto AI agent landscape. It was last updated in like early January, and since then it's gotten exponentially bigger, and a lot of these projects are no longer relevant. This just highlights how quickly the space is moving, and the fact that probably 10% of these projects are going to be winners long term, and another 10% that aren't even here right now are going to be the other winners. There's so much going on and so much to dig through, so I'm going to try to make it really simple for everyone to understand the space in a pretty straightforward manner. This is a typical hype cycle of what things look like in crypto, or just in tech generally. And if you go to the next slide, this is where I think agents are right now. It's getting a little bit frothy. Just over the past couple of days, I've seen so much hype and so much interest in AI agents, and I absolutely love that, but I also think we can kind of forget what we can build right now with our existing tools, and we get caught in this crypto trap of always trying to build out the infrastructure for the next 3 to 5 years and never really building anything practical. So I'm going to go into a little bit of the things that I think are really low-hanging fruits that could be billion-dollar ideas that nobody's really thinking about right now, because we're starting to see this hype start to dampen and discourage people from building stuff today. This is another great graph that I like to show, which I wish it went back a little bit further than December, because like November timeline, it would be 0 on both of these. But it shows the general market cap of individual agent tokens and the amount of agents that are being created. And if you go to the next slide, you'll see here that this is kind of where I think things are going. We're going to have a massive increase in the number of agents that are created. And the market cap for these individual agent tokens is going to go up, sure, with a little bit of speculation, but ultimately will trend towards zero. Spoiler alert, it's not because I think the whole agent space is doomed, but I think there's going to be value captured in different ways. And the whole goal of AgentKit, which we'll get into a little bit later, is we're trying to commoditize the ability for every single person to have access to an AI agent and bring a billion agents on-chain. So these are kind of the directions where I think agents are going from here. The first, like I mentioned, is going to be the commoditization of agent creation. Everyone's going to have an agent. It's going to do all sorts of stuff for them, not only in the crypto world, but also in the traditional services. It'll do stuff like order food, book hotels, all sorts of fun things for you, and it'll be kind of like a personal assistant that's constantly available for you. Value primarily is going to stem from the proprietary data and services that you can offer to agents. So I think a great example of this is AI XBT. It's, as far as I'm aware, still the largest individual agent token. And the reason that is because it has access to all of this data and years of training and fine-tuning to make it pretty decent at making crypto insights. Similarly, I think there's a lot of interesting services that you can provide specifically to agents that are in a moat that would otherwise be inaccessible. One example would be Byte. They're a food delivery agentic service. He's right there in the front row, who derive value because they're able to do something that agents typically can't do, which is order food. Another thing that I think will be happening is that we'll start to get some of these big tech companies join in on the fun of agents. Right now, it seems like a pretty crypto-dominated space, but all of these big tech companies, Microsoft, Amazon, Google, OpenAI, are all building agents and agent frameworks. And I think we're going to see a massive shift in the way that the crypto space thinks about agents once these big boys come in and join the fun. I think what this will practically look like is while these crypto frameworks that are building out agents are going to still be valuable and around, a lot of people are also going to look at these new agents and mesh them together with existing Web2 services. Lastly, I think on-chain interaction is going to be critical for this new wave of agents, and I'll get into exactly why here in a second. But before I do that, I want to talk a little bit about what AgentKit is and the role it plays in this stack. So as I mentioned, AgentKit is a way for you to give every AI agent, whether it's built with ELIZA, Game by Virtuals, LangChain, whatever, access to a crypto wallet and a comprehensive set of on-chain interactions. This is on every network. This is with every protocol. You can do all sorts of stuff like deploy smart contracts. Anything you can imagine, you can give your agent access to in like 4 lines of code. Our goal is to make it as simple as possible for every one of these agents to have an AI wallet because we think it's critical for them to ultimately have this as a payment rail. The reason for that is because it's impossible for AI agents to get access to a bank account. Though you could give it your information for your personal account, you have to trust it to not overspend. You have to deal with all of the complexities and problems with legacy banking systems, like the time it takes to transfer. None of this is built for the new world where we have internet native money and we need to move things around the world extremely quickly and without some of the concerns we have about the traditional financial system and its inability to do cross-border transactions efficiently. Crypto provides these rails in an internet native way that is very easy for agents to have. You can spin up a wallet for your agent with a single line of code, fund it with money, and then it can do anything it wants. It can send money to anyone, anywhere in the world for pretty much fee-free. It can also start earning on DeFi protocols. And if you want to plug it into the traditional banking system and give it a debit card, that's great. It can top it up with stablecoins as an intermediary step before, as we believe, the entire world will come on chain and all of these businesses will start to take crypto directly. So why specifically the Coinbase Developer Platform AgentKit? Why do we think this is the way that things are starting to trend? The first is because it enables new business models. For all of these crypto protocols that right now have to require users to go to their website, sign in with a wallet, know how to use their tech stack, click on buttons, all of that is way too complex to get a billion users to come on chain. Instead, wouldn't it be awesome if you could just tell your agent in natural language something like earn me money or swap? Super basic verbs that ultimately allow you to have a completely new interaction paradigm with these protocols. For the protocols, it opens them up to a completely new group of users who otherwise would not be able to interact with their specific protocols. Also, AgentKit is great for driving framework adoption and growth. We have, I think, something like 20,000 agents deployed right now. We've got over 2,000 builders who have already tried us out. The growth of AgentKit is amazing, and it's in its early state. It's better than ever to start getting involved and help create these standards and these commerce flows that AI agents are ultimately going to use as we move towards an agentic future. This is where I think AgentKit sits in that stack that I described earlier. It's not a framework itself. A common misconception is like it's a competitor with ELIZA. That is absolutely not the case. It is actually a default plugin within ELIZA, so you can very easily give all of your agents access to crypto wallets. Instead, it acts in this middle layer where you just plug and play with whatever you want. It's pretty compatible across the board, and we're always looking to take new contributions and collaborate with other players in the AI agent space. There are two main use cases that I think are primarily valuable. The first is this sort of human-in-the-loop, ChatGPT-style interface where you talk to an agent and it does something for you on your behalf. And then there's the much more fun example, which I think is a little bit further away, but we're getting to it, of fully autonomous agents that do things entirely on their own. The example I like to use here is the idea of a self-driving car that has like an AI brain and access to crypto rails. And basically, it could run some sort of taxi service and pay for its own operation and maintenance and just like exist as a thing in the world that's out there. So given this is a build-a-thon, and I'm sure a lot of you are building, and the ones who aren't, this is still good to understand signal around where to invest. I think there's 4 main areas that I'd love to see come out of this week. The first is pushing the envelope on autonomy. Right now, we've seen a bunch of agents that are either just like a front-end wrapper or adding a few new actions for the existing agent kit, but I think people aren't pushing the bounds of what's possible using the tech today just yet. For example, Truth Terminal, which really catalyzed this whole AI crypto narrative, came out with technology that was like 6 to 12 months old. Nothing about it was particularly novel, except it squished new things together in a way that nobody's thought of before. I absolutely think that's possible today in so many different ways, but nobody's really taking advantage of that. The second thing I want to see is people plugging into more Web2 tools. So starting to imagine not just crypto agents, but what happens when you give a traditional AI agent access to crypto as a payment rail. Lastly is agentic commerce. So the idea of agents starting to be your personal shopping assistant and do everything for you feels like an inevitable future, and one that we can start working towards today with the existing set of tools out there. And here are a couple of examples just to get you excited and inspired about what's going on. The first is this agentic food delivery that I mentioned. The next one is agents that have access to decentralized compute. So you can imagine creating like a self-replicating agent or something along those lines. And then the last one is robot dogs. So I think there's a lot of interesting capabilities when you start to mesh with embedded robotics and AI. We're going to have a couple of these robot dogs around the CDP booth at the actual ETHDenver conference. So I highly encourage you to come check them out. I've been playing with them at home for the past couple of days, and it's a ton of fun. So definitely stop by for that. So looking ahead a little bit and just trying to see where this space is going in a non sort of super hype manner. Agents, I believe, are going to be the primary actors on chain just because they make it incredibly easy to get started. And as robotics evolves, AI is going to start becoming physical, and we'll see these AIs start to move from just something that lives in your computer to something that is far more prevalent in your day-to-day life. We've seen this with these types of robots that are coming out. They're going to need a payment rail as well, and crypto makes a lot of sense for that. Agents today primarily also are using very centralized service providers. So think like a traditional AWS server, OpenAI APIs. While that's absolutely fine for today's use cases, I think as these agents start to push the boundaries a little bit more, we're going to see a little bit of controversy around these centralized services and their ability to properly service these agents that exist. Practically what this will look like, I think, is very similar to the current L2 roadmap, where we started out very centralized, and that allowed us to see massive performance improvements across the board and solve some of these scalability problems. And then we progressively decentralize as necessary to preserve the benefits that we've seen so far. The same exact thing happened with agents. Lastly, I think multi-agent swarms are going to become more and more commonplace. This isn't really a hot take, but typically the way to think about agents is that they can do a lot of things, but they're going to have some sort of way for your personal agent to plug into the Expedia agent, or for it to go off and do something else random in the world. And for that reason, you're going to have some sort of communication or sort of discovery service where your agent can go off and find other agents. So these are 2 links that tell you how to get started. Our Discord is great if you want to talk directly to our engineers and get white glove support as you're working through all of your agent builds. Our documentation as well has a 5-minute quick start. I know it's probably intimidating to even think about building an agent, but I promise you, just try it out. I don't consider myself a terribly technical person, and I have a bias towards making it as easy as possible for anyone to get started. So it's like literally 5 minutes. You don't have to write a single line of code. It's just copying and pasting the API keys that you need. We have lots of different AI-assisted builder tools tools to make it possible for anyone to build on chain and really change the definition of a builder from somebody who has to know how to code and has a little bit of idea of programming languages to somebody who can just express an idea in natural language and watch this come to life. So if you have any questions, we're going to be at our booth right across the stage over here. Happy to talk to you, jam through anything related to agents, other CDP products, how you can mix things together to make something super cool. And yeah, happy to take any questions. Thank you and happy building.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 burner phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Bend it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling. Why? Gas fees are confetti. They rock on P Island. Get homemade in 7-4 time. Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spinball. Plug in tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto nodes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spinball. Plug in tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Lag runs dial-up found. Age, old speak, young as each block mine down. Professor Way's got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spinball. Plug in tomorrow with yesterday's RAM stains. Running mad's just a beta test for Boodle. Oh, he jumps right to audible. He jumps right to audible. He jumps right to audible. He jumps right.
Hello, GM, everyone. Welcome to the workshop. This workshop is all about building chain abstracted dApps using Okto SDK. So, starting with the workshop, a little bit about me. My name is Persh. I am from the engineering team at Okto, and I work in the SDK dev team. Now, what is Okto SDK? Well, I like to put it as a one-stop and simple-to-use software kit which helps you build great dApps without even thinking about a lot of complex Web3 problems. Like, you can also visualize it as a simple chain abstracted embedded wallet. But before we start, I have a question for you all. Like, why would you use a chain abstracted embedded wallet in your project? And I hope by the end of this presentation, we all can answer this question together. Now, let's move forward with all the problems. So I have a list of a lot of problems that we as Web3 degens face regularly. Some of them, well, you might as a developer will also face. Like if your users go off app to sign transactions, like they have to go between apps and wallets again and again to sign a transaction. They have to sign multiple transactions, for example, a multi-chain swap. Users often want a risk-free embedded experiences across new dApps. User does not have enough liquidity or gas on the desired chain. Like these all questions are things that you as a developer needs to figure out before you can build a dApp. What if the user goes offline during the interaction? What if the users, for example, are fragmented across multiple ecosystems, right? You as a developer has to think about this, and you also want to offer single one-click experiences. So how do you do all of those and still keep on track, right? So Okay, so this meme often reminds me of all these problems in Web3. There's fire everywhere, but we often say it's fine. Well, it should not be. Yeah, so how does Okto solve it? At Okto, we have infrastructure of DWNs, ULL, and DTN. It's a general intent resolver. So using DWN, we offer secure, friendly, and interoperable wallets along with session delegation. ULL helps us offer you gas abstraction and cross-chain liquidity. And DTNs is a general intent resolver which helps you do general intents on chains, protocols, and multiple ecosystems at the same time. Now, what is a DTN? DTN, or which is short for Decentralized Wallet Network, is a MPC cluster which is on AWS and has a dollar-based policy engine. ULL, or Unified Liquidity Layer, is a 7683 compatible solver network, and DTN, Decentralized Transaction Network, is again a synchronous generalized intent solver, which can be extended using blocks, which is one of its superpowers. Now, let's get to the good part. So we are all hackers here today trying to build something cool. So what can you build on Okto SDK right now? So at the hackathon, we are offering a lot of different features, including, but not limited to, social login using interop embedded wallets, session key delegation, chain abstraction ecosystems such as EVM, Hyper EVM, Aptos, and Solana. We do offer guest sponsorships, generalized intents such as token transfer, NV transfer, and raw transaction. And most importantly, we offer it in a very great developer experiences. So we have multiple SDKs across platforms. We have developer dashboard and adapters for WAGMI and ELISA. So I think that's all the slides have. So maybe we can move on to the hands-on session. So let me just quickly set this up. So yep, here we go. So how do you get started on Okto? So there's two things you can do. First, let's go to the Okto dashboard. So the dashboard is dashboard.okto.tech. You can just go there. You can enter your email ID. I'm just going to quickly enter my email ID. I'm going to log in. And it's going to send you an OTP on your email. So I'm just quickly going to put it in. Just a second. So yeah, I'm on the dashboard. So I think I have already logged onto this dashboard, but when you'll come back, you'll basically what you'll do is you'll go to the APIs key section, you'll generate API keys. So here you see two different options. One is the client SWA and the client private key. The client SWA is your recognition for the chain, that Okto chain, and client private key is how we help you access the Okto chain. So I have these values already with me, but you can just create a new one and you can save that with you. Now, since Okto is a multi-chain architecture, you obviously need some chains, right? So let's go to the chains and token section, and you can enable a lot of chains. So right now I have Polygon enabled, but let's go enable a few more chains. So let's say I enable Base, a few testnets like Base testnet, and let's say I enable Polygon testnet as well. So I can go ahead, enable those chains. These chains will be enabled, and I can also enable some tokens. So let's say I enable Matic and USDC on Polygon Amoy, and on Base, I go ahead and enable some USDC. Now, we support nearly every token out there. So if you don't see a custom token that you want to use in the dashboard, you can just shoot up a quick DM on our Discord channel, or we have a booth right back. So you can just come and we'll help you out. Oh, by the way, since this is an Okto testnet, you might also need some faucet tokens. So Okto tokens help the Okto chain operate and help you, the dApps perform their interactions on the chain. So we have a quick, easy to use faucet right in the dashboard. Just come here, click on request credits, and the tokens will be deposited into your client. So it's that simple. I'm just going to cross it for now because I already have some tokens. By the way, we also have guest sponsorship. So if your application requires you to sponsor your user's transaction on some destination chain, let's say Polygon, you can obviously come here and simply activate it. It uses standard ERC-4337 sponsorship. OK, let's go ahead. So now we have the API keys and all set up, but we still need a project, right? So let's go to the docs. So the docs is on our website, docs.okto.tech. So I'll go there. For the purposes of this demonstration, I'm going to be relying on React, but you are free to choose from Next.js, TypeScript, React Native, and a lot of them. So let's choose React Quick Start. If you already have a React application set up, you can follow our steps to implement Okto in it. But since I do not, I'll just use the Quick Start template. So you can click on Run Template, and it will give you a couple of steps using which you can clone a template repository, you can install the packages, and copy the environment files, right? So now that all that's done, let me just quickly copy this. I can, let's say, open my terminal, and I can clone it. Remind me later. OK, where's my terminal? Here it is. So I can clone it, and I can install it. But for the sake of time, I have already done that in the behind the scenes. So here you go. So this is the repository. Don't focus on the red colors. We are quickly going to make them go away. So it's the same repository that we cloned. The only thing that I did is I came to the env file, and I pasted all the values. Right, so what are these values? So there are a couple of them. So the first one is the environment variable, which will be sandbox. Then the next two are the Okto keys, which we just got from the dashboard. And then other next two are for the Google OAuth. So Okto offers you something called the social login. So you can offer login via Google to your applications. Now to achieve that, you have to use Google login, and Google Client Secret is a simple client key that you can get from GCP portal, and it helps you get those tokens. Now let's move on to some code, right? So in your React application, you must have a root file where you define providers, strict mode, browser routers, everything. So in the same file, you can define Okto provider as well. So you can simply import the Okto provider from the Okto SDK, and it will ask you for a config. The config is nothing but all these three values that we just saw. And at the same time, you can also give it a Google OAuth provider from SDK as well. So by doing that, your whole application will have access to all the niceties that we have to offer in Okto. So that's great. Now let's see how your user can actually log in, right? That user needs to log in, otherwise how he's going to use the app. So let's go and see the login page. Now, in the login page, I have some code written here already, but we will mainly focus on the Google login part. Now, how to do a Google login? Well, it's not that complicated. The Google SDK provides you a single-to-use React component. You just import it using from the SDK, and you just add it to your HTML, right? Just like this. It gives you a callback function, which I have defined right here. Now we'll come to this callback function later, but how to use Okto here? So first of all, what you're going to do is you're going to import the Okto client using the Okto hook. Since we have already used the provider earlier, it's as simple as writing use Okto, and it will give you the Okto client, right? And let's, while we are at it, let's create a handle authenticate function, which takes an ID token. Now, what is an ID token? We'll get it to a little bit later. But for now, what you can do is simply call Okto client login using OAuth and provide that ID token, and you're good to go. The ID token, well, as we were just discussing, comes from the handle Google login function. As you can see, it will return you something called a credential, which is also another name for an ID token. Just pass it to Okto, and the user will be logged in. That's good to go. Now let's see it in action. So I'm just going to run a quick command called npm run, and we'll just see this. So it's going to run on localhost 5173. I have that just right here. Oh, let me just close this. Right, so here's the login screen. Now, as you can see, we already have a login using Google button. If I just click on it, boom, I get a Google login pop-up. I select the email ID that I want to use, and I am logged in. Now, it looks like the Wi-Fi is a little slow, but that's OK. We can get with it. So this is a sample screen that we have created to show you all the capabilities of Okto. So here you can see all the Explorer functions, such as user accounts, user portfolio, the chains that the user can interact on your dApp. For example, right now, since we enable a lot of chains, If I click on it, again, the Wi-Fi seems to be a little slow. Yeah, here we go. So we have the base chain, base testnet, Polygon, and everything. But the cool thing about Okto SDK is, while all these features are available to you, your user doesn't necessarily need to know this. It's all abstracted from me. Only thing the user needs to know is the user SWA, which is right here, right? So that's all about the Explorer functions, but what about actions? Actions are something that we call as intents in Okto SDK. So intents are the actions that your user wants to do. So for example, if your user wants to do a token transfer, an NFT transfer, or something custom, so we offer an intent for each of them. Now, instead of showing you it through UI, why don't we walk through the code? So I'm just going to go back. Now I have created another page called demo token transfer. And I have written some skeleton UI code here, but we'll go through the logic as we are here. Right? The first task is we need to import the Okto client. So as we just saw earlier, you just write const, okay, I'm not sure if I'll be able to do it like this. Const Okto client and use, okay. Use Okto, and the Okto client will be imported. So the Okto client is there. Now you want to make a transaction. How do you do that? You come, now I have a function which handles the transaction, which you can call. So I'll just create token transfer function. So I'll just import token transfer. I'll pass the Okto client that I just imported, and I'll pass some parameters. Now what are these parameters? These are some basic intent specifiers that you have to give. So for example, it is asking you the token that you want to give. So for now, I'm going to leave this as empty. I'll explain what that means. And the next one is the recipient address. Now, for the demo, I already have another wallet that I created earlier. So I'm just going to note down the user SW of that wallet, and I'm going to paste it in. Right? Then we need amount as well. So I'm just going to put some arbitrary big number. Let's say this, maybe at one more zero. I'm not sure what that number means, like how much that is, but we'll see. Now, again, we also need something called a CAIP2 ID. Now, this might be a term that not a lot of you might be familiar with. So what CAIP2 ID is, it's a chain agnostic blockchain identifier. So instead of calling it Polygon or something, we have a construct to define them. Now you can learn more about them on the docs, but for now I'm just going to put in the chain ID of Polygon. So it's going to be EIP155:137. And by the way, you can also see them all here in the UI as well. So this is all done. And for the token that we left out empty, right? So here what you can do is you can actually put that address of the token contract, and it will automatically recognize it. But since native tokens don't have addresses, I left it at empty. That means it's a native token. Now, the token transfer intent is created, and once it's executed, it will return us the intent ID. So I'll quickly catch that intent ID, and we can also check the status. So let me do that real quick. Now I have an intent ID that the transaction is successful, but how do I know that? I also need to check the status of it. So what we can do is I can create another function which will give me the status of it. It's called getOrderDetails. So again, similarly, we'll just import that function and pass the ID. Now what I did here is I got the order details and I set it in a use state hook so that I can use it later. And by the way, I also need to invoke this function, right? So I'm just going to invoke this just like this, and the function is invoked. And in the handle transfer function, as soon as I click the button, this should work, right? So let me just do that real quick. If I go back to the UI and I go to the custom route that just we defined, demo token transfer, as you can see, we have the UI here. Now, if I click on token transfer, It will, in the background, create the transfer payload. It will get it signed by the DWN. It will put it on chain. And once that's done, it will also fetch the status using the useStatus hook. Now, we see the order status, and we see that it's pending right now. I guess I should fetch it again, but the intent is there. Now, if I want to check if the intent is successful, obviously I can refetch the API, but for the sake of this demo, I'm just to copy this intent ID. I'm going to go back. And in the get order history, I can check that the intent should be successful in a bit. Yeah, it's still in progress. Let's give it a couple of seconds. Hopefully it'll be there. It often, yeah, so it's done. See, it's successful. It's successful on the chain, and you also get the transaction hash of the downstream chain. So if I copy it and go on Polygon Scan, I can see that it's successful. Let me do that real quick. polygonscan.com. I can just paste it here. And OK, I'm not sure what just happened. But yeah, if you see it a couple seconds later, it might be there. Maybe the Polygon Explorer is not working right. Oh, yeah, it's here. So the transition is successful, and you are good to go. So that's all about Okto SDK. But what about all the developers who are already familiar with some of the other tools? Let's say you are a Web3 developer who's familiar with WAGMI. You already wrote a lot of code using WAGMI, and want to offer social login to your users. How do you do that? So for that, we also have a WAGMI adapter that we have created. So you can simply go to the our documentation, and you can go to, let me just find it real quick, in the React part, integrating with WAGMI. So it's a very easy to use setup. You just install the WAGMI adapter in your existing code. You write 3 lines, which is basically a connector called Okto. You pass the same values that you passed earlier in our SDK, and you're good to go. You'll get a new button, new connector called Okto. User can click on it. They'll be able to do Google login and nothing else. That's all. So yeah, that's all on the hands-on coding section. I think we already covered the WAGMI adapter. At the start of this session, I asked you all a question, like why wouldn't you use a chain abstracted embedded wallets? I hope I was able to answer that. And what I feel the answer is, well, why wouldn't you? So that's all. Thank you, everyone. By the way, our testnet is already live, and the mainnet is going to be live in a couple of months. So if you have any questions, feel free to drop by our booth, and we'll be happy to answer. Happy building.
Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing, while the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes in.
My name is Tzahi Zeidenberg. I am a tech lead in Off-Chain Labs. I work in the Nitro team. And today we're going to talk about one-step proofs in Arbitrum. For me, this is the most basic explanation of how Arbitrum, or most optimistic rollup, actually works and what makes it correct. We'll start with a toy simple problem. Let's say I want to do this computation. I want to do a factorial of a not small number modulo another modulo a non-small prime. And this is just a toy problem, of course, but for me as a programmer, it's quite an easy problem to solve, right? All I do is I write some code. In this case, I write it in Go. I compile this code. When you compile the code, it compiles to an assembly. This was done on an ARM64 machine, so this is an ARM64 assembly. And I execute this on my laptop. Specifically, this will take more than a second, less than a minute to execute. And in the end, I will have a result. Not only will I have a result, but any one of you that will execute this code will have the same result. And that's all fine and good. But how do I prove this result on chain? How do I prove to Ethereum that this is indeed the correct result? So the first simple in a quotes approach would be, well, to prove it on chain, what I need to do is execute it on chain, right? So instead of Go code, I will write Solidity code. This is already a little bit problematic because Solidity has a few constraints. You can't do a few things are harder there. And I will compile it to EVM. EVM is the assembly used on Ethereum. And then I will execute it on chain. This is a major problem because executing this one, I didn't go through the gas compute calculation, but I hope you trust me that it's very easy to define a problem that will take days and years of executing on taking the entire blockchain space. So sometimes I want to prove you the result, but I don't want to execute this computation on chain. So what do I do? What do I do is a third approach, which is provable execution. So it will look like this. I will start with Go code. It is exactly the same, with some caveats, but basically exactly the same Go code that I used originally for my, when I executed it on my laptop. I will compile this Go code not to ARM64 or x86, but to WASM. WASM is WebAssembly. It is another type of assembly made to be emulated by software, originally WebAssembly because it was made to be emulated by browsers. And I will take this WebAssembly and I will execute it on a special emulated machine called Arbitrator. After I execute it on Arbitrator, all I do on-chain is prove the execution on-chain using the fact that I executed it on Arbitrator. And what that means is what we will go into depth right now. So what is Arbitrator? Arbitrator is written in Rust. It is a fully emulated machine, so a fully emulated virtual machine. It executes WASM. It is deterministic. It has hashable state, and it can produce one-step proofs. All of those we will talk about now. So the first thing I said is Arbitrator is fully emulated and deterministic. That means that if you look inside Arbitrator, if you look inside the code, what you will see in essence is exactly what you would expect to see of every fully emulated machine and even of every computer and every CPU. So the Arbitrator machine has representation for the code that is executing. It has representation for the memory, for the entire memory space that a program sees. It has a representation of stacks for the local and the WASM for local and the WASM stacks. And it has a program counter, which is a pointer that says what is the next instruction that I'm going to execute. And if you look in the code, in essence, the Arbitrator does exactly what you expect of an emulated machine, which is it has basically a huge loop. This loop fetches the next instruction that needs to be executed. It loads it. It advances the program counter, which is the pointer that says what's the next instruction that needs to be executed. And after that, there is a huge select, or in Rust it's called match, which goes over what's the opcode, and according to the opcode, I will just do the thing that the opcode says. In this case, the code we have here is of the opcode I32EQZ. It's a WASM not. Pop the top of the stack. If it was a 0, push a 1. If it was not a 0, push a 0. And that's basically, when you compile your code, that's what all code compiles to. A sort of very, very simple instructions. What Arbitrator has that's not true for most emulated machines is, first of all, we've said it is deterministic, which means there is no source of non-determinism. So mostly clock time, wall clock time has no meaning in Arbitrator. Right? There is no place it can get data that is not fully deterministic. Another property it has is it is hashable, which means I can get a 32-byte hash that depends on every bit of state of the Arbitrator machine. So the entire memory, all the code, all the stacks, the full machine that is currently emulated, if I can go and get a hash, one 32-byte hash that depends on every bit of state in the entire machine. So when I say Arbitrator execution is provable, what I mean is this. Given a machine hash at some point, I can prove the next machine hash. So if we both agree, or if I have proved machine hash in step n, I can prove absolutely what will be machine hash in step n+1. Now, by extension, it means that if the first machine hash is known, so the initial machine state is known, the entire execution is provable, right? Because step after step, it is all provable. Now, this extension is not at all trivial, right? Proving billions of steps from proving one step is not at all trivial. It is a huge undertaking. This is what we call the BOLD protocol. I think it is an ingenious protocol. I love it. I recommend everyone to learn about it. But this is not our topic. Our topic is this. Given one machine hash, how can I prove the next one? And when I say prove, I absolutely mean prove it on-chain, prove it on Ethereum, which means I have a smart contract. I have a smart contract that does this proving. Smart contract I have here the link to like the code path in the Nitro repository for it. And it has an entry point which is called prove one step. Prove one step is a function. It receives two important inputs. There are other inputs, but we won't talk about them. The two important inputs it receives. First of all, what was the previous machine hash? What's the given that we're proving from? And second of all, it receives a large byte array that we call a proof. Its output, thanks to these two inputs, its output will be that next provable machine hash. So it will tell us the next machine hash, and if it agrees, then we have proven, basically, our claim. And to talk about how it works, I will first talk about arbitrator machine in Solidity. So we have the arbitrator machine in Rust, right? The local executed machine. This has the full state of everything. It might have hundreds of megabytes of state in memory. The Solidity implementation, of course, cannot have hundreds of megabytes of state. What it has is it has small state. It has state of a few functions. So it has the full program counter. It has, for example, it holds modules root. So it holds one hash which depends on all the modules, and all the modules hold all the code and memory and global variables. So all of that is condensed into one hash. The stack is interestingly condensed into the top few elements and a hash of all the rest. And that's because stacks were not using Merkle tries, we're using Merkle stacks, if you will, that makes proving computing hash from this sort of thing simple. So the one step, the proof that the one-step proof entry accepts, that large byte array, the first part of it will be the deserialized machine. So it will be code, it will be a byte array that Solidity deserializes into arbitrator machine, right? And the first thing, the almost first part in the one-step proof entry is I deserialize this machine, and then I go and I check what's the hash of this machine. If the hash of this machine matches the given hash, that means I have proven everything in this arbitrator state machine. So I have proven the top few elements of the stack, I have proven the program counter, and I have proven the module root. The next step, just like I have a representation of the full machine, I have some small representation of a module, the current module. And it will come, I will add into my proof the representation of this module and a Merkle proof. This Merkle proof proves that my module really is a part of that arbitrator machine that I have already proven. After that, in the same manner, I now prove a piece of the code. So I Merkle prove a piece of the code against the module which I Merkle proved against the arbitrator machine. And now I have proved what's the next instruction that has to be executed. So I have proved the right part of the code, I have proved the top few elements of the stack, and I have proved what's the program counter. The next step in the one-step proof looks very much like executing, looks very much like the execution of arbitrator. So it will do exactly what the local arbitrator machine does, which means at first it will advance the program counter. Then there is this large select, right? Check what's the opcode, match it against every possibility of legal opcode, choose what you're going to do, and then execute it. And here is execute EQZ, which is the Solidity implementation of the same thing we saw on Rust. So I know that now I need to do an EQZ. And so pop the head of the stack, check if it's a 0 or a 1, push a 0 or a 1 accordingly. When I did both the program counter advancement and that execute EQZ, I changed the representation of the arbitrator machine. I changed what I now know about the world. So all that's left for me to do is check the hash of this new updated machine. And this will absolutely 100% proven to be the next machine hash. So I have solved the problem I showed you at first. I proved that given one machine hash, I can prove what the next machine hash is going to be. By extension, using bold algorithm, I can prove, given the first machine hash, I can prove to you the entire execution of everything that can happen now. In Nitro, an execution, what it does is it produces a block knowing the previous block. So if we both agree, or if Ethereum believes that it now knows what's in block N, what's the hash of block N, and what's the next input, I can prove to Ethereum what's going to be exactly block N+1, the arbitrator, and that's how basically ARB1 is proven. There is then another step of extension, which says that given we divide the blocks into something called assertions. So every assertion proves a bunch of blocks, and that's all also done using bold. So because we can prove one block, we can also prove a bunch of blocks. Those are called assertions. And what you see on-chain in Arbitrum is you see on-chain assertions, and each assertion is proven by accepting that the previous one is correct, and we know all the rest of the input. Okay, so let's go over what exactly is that code. So I didn't have code samples here because it would be too difficult, and I'm doing something much more hand-wavy. But this command replay main.go, we have the actual code that is the on-chain provable execution. So we said we are executing something over arbitrator and proving that. That's what we're executing over arbitrator in ARB1. So the algorithm goes like this. First of all, you need to read the previous block hash. Then you need to load the state of the block from that block hash. Then you need to load what the next transactions are, what is the next input. Then you execute those transactions, and some of those might be stylus transactions. Then you compute the next block hash, and you finish execution. 99.999% of those instructions of the WASM instructions executed are going to be just like the EQZ that we saw. They do very simple things that are entirely in WebAssembly, right? Write to memory, load from memory, push to stack, pop from stack, do some computation. But there are a few places where you need some communication with the outside world, where we have added WASM-like instructions. We call it WAVM, WAVM instructions to assist the extra required functionality. So, for example, to get previous block hash and finish execution and compute block hash, we have something called a global state. A global state is basically the main input-output of the system. So when I said the first machine hash is given, the first machine hash is one-to-one computable, knowing only the global state and the constant code, which doesn't change. So the first machine hash is known just by global state. The last machine hash is only depends on global state, and that's how. So when my executable has an input of the previous block hash and an output of the next block hash, this is how that works. We have an interesting read inbox, so I can read the next to read the next transactions, what I need to do is read the inbox. The inbox is something that was posted on chain. My one-step prover knows what's posted on chain because it exists on the same chain. So it is very easy to prove to it what was proven, what exists on chain, and then I can read inbox from it. And my personal favorite, one of the latest additions to the WAVM is a link module. Link module allows you to add a new module to the same arbitrator machine, which means you can now load dynamically more code, which is exactly how Stylus works. So when we allow proving WASM executed smart contract, this is what's going on under the hood. The interesting part, and when designing all of those, is to make sure each of them can be one-state provable. So for each of them, we have both an implementation that executes them and a Solidity implementation that, if required, can prove them absolutely, can prove the next block hash from the previous one. At this state, I will say thank you. I'm Tzahi from Off-Chain Labs. Come find us at the Arbitrum booth in the full event that will start. And I am just on time. Thank you very much.
You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I snooped and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk den scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Urgent notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bees flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin, boy. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-a-phone. Age? Old speak, young as each block mine down. Professor Wade's got the future on spin, boy. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains.
Hey everyone, my name is Lee. I'm an engineer at Euler Labs, as well as doing some BD work. And I'm here to talk a little bit about the DeFi yield market, just kind of an overview and some of the kind of interesting risks and dynamics that have come into play over the last couple of years as it's approaching some more maturity. Title being picking up hundreds in front of a steamroller, kind of a play on the classic picking up pennies. But yeah, we'll just jump right into it. And also, none of this is financial advice. So I'll talk a little bit about kind of a brief history of DeFi yield markets and lead into where we are today. Talk about what the risks of that are and how this might all blow up someday. And then talk a little bit about how Euler fits into all of that. So, brief history of DeFi yield markets. So start with what is yield, and I'm sure most people are kind of familiar with what it is in general, but yield is essentially a payment to allow somebody else to use your capital while you don't have access to it today. Really coming down to time value of money. $1 today is worth more than $1 tomorrow, thanks to opportunity costs. I'd rather be able to do something now than I would in the future, but somebody else might pay me to make up for that. There's different ways to kind of assess how much you should be paid for that, and that depends on a lot of different factors, such as who you're lending your money to, what they're doing with it, how long you need to not have access to your capital, but all those things are kind of calculable risks. And then yields in DeFi in particular, there's certain things that I and we at Euler like to think of as more real yield, and other things that are, I would say, not so real yield. Real yields being kind of things coming from sort of the real world, being treasury yields, dividend yields, and also more specific to DeFi and crypto, things such as staking yields for proof of stake and validators and whatnot. And then there's things that are not quite as real yields, Terra Luna being one of the classic ones, and other protocols that we've seen over time where you have these kind of issuance of whether it's governance tokens or other kind of payment that is sort of floating kind of willy-nilly value, but people kind of like to think of that as a real yield, even though underlying it might not necessarily be that real. One thing that DeFi has done a really good job of noticing is that people really like yield and like to do sometimes silly things to get access to that yield. DeFi summer is what everybody always likes to remember, where you can be earning thousands and thousands of % APY on some silly tokens and making tons and tons of money and taking on a ton of risk to do that without either paying attention to it or acknowledging it and just not caring and doing it anyway. So yeah, I would say the kind of the peak of this was in the DeFi summer, as I said, and over the last couple of years it's settled down a little bit and started to kind of mature into a more developed market where risks or yields are starting to look a bit more real. People are starting to understand the risks a little bit better. We've had some interesting evolution over the years of what that specifically looked like. So it started with kind of the shift to the proof of stake system and the classic staked ETH versus ETH trade, where you're earning yield on your staked ETH against kind of an underlying ETH product without yields. But that's evolved over time because that trade kind of went out. The classic one nowadays is the points meta, so we can thank Blur and Blast and Pac-Man for kicking that off, and now everyone and their brother has a points program that they want to do, and it still works, so people are still doing it. And nowadays, I would say kind of the yields are settling down in that sort of 20% range for stablecoins-ish, 10-15% for ETH, and 5-10% for Bitcoin, which is still not bad. It's pretty good. It's a good way to kind of put unused capital to use. So where does that bring us to today? There's a lot going on in the DeFi markets. There's point systems, there's kind of leveraged carry trade systems, there's Euler and Aave and Morpho and Pendle and real world assets, and the classic governance token trades and carry, and anything that you can think of, someone is doing it, and someone is doing it in a leveraged way, and building up bigger and bigger positions and earning more yield on top of it. But there's a lot of options nowadays. One of the things that's been very popular recently is sort of assets that are trying to breach into kind of more real world yield generation use cases, such as Athena or USR, where you have something that's an underlying spot versus a shorted perp against it to do sort of a delta neutral carry trade, which originates in the finance world. Kind of the interest rate carry trades are super, super popular, and we've seen them be very, very successful in DeFi nowadays. Similarly, we have a lot of these kind of staking-based tokens where they might have a time lock component to them that people are either not realizing or not paying attention to, or not sort of thinking about what the kind of risk associated with that might be, as well as more complicated kind of aggregated yield baskets that might look like sort of one thing where they're getting a nice juicy yield on it, but not really sure what's going on under the surface. But again, it doesn't matter because you're getting paid out a nice amount. And we're starting to see a lot more of these being used as collateral in lending protocols and other protocols to, thought of as kind of safe yield-bearing assets, when in reality, a lot of these under the surface are really just kind of tokenized sort of funds and kind of discretionary trading strategies that are a bit more risky than they seem. Similarly, one of the other evolutions we've seen is a big focus on capital efficiency. And what we mean by that is kind of better ways to put capital to use, so that things are not just sitting idly and allowing more of your assets to earn more yield, and everyone's making more money and we're all happy. So it definitely leans into where we're getting more and more degen in the DeFi space, as some of the yield numbers have been shrinking relative to what they were in DeFi summer, and people are trying to grasp at anything that they can. If I want to lend my collateral and somebody wants to borrow my collateral, that's better because I'm earning yield on my collateral, maybe double, and it's more efficient, and there couldn't possibly be any problems to this. And I'll repeat this until I'm sufficiently leveraged for my personal risk tolerance. If anybody remembers the Wall Street Bets days, people are getting more and more, like I said, they're either not paying attention to the risk, or they are and just ignoring it because the yields are too good. One thing that we at Euler and a lot of lending protocols and kind of risk managers do like to think about as regards to these sort of things is, how do these trades fit into the market as it stands? How do you think about sizing your positions? How do you think about the liquidity that's available on chain? What's an appropriate size? What's a not appropriate size for both an individual level and a protocol level? Primarily for these yield-bearing assets, or even the non-yield-bearing assets, or really anything coming into a lending protocol. And then thinking about kind of more unique risks at an asset level. So things that might have a time-based unlock or redemption period to them. And for now, as far as we've seen, people do a decent job of thinking about this and kind of gauging and sizing positions appropriately. As these markets mature more and more, we're starting to see a lot more institutional players kind of start to think about getting into the DeFi markets, which is going to be interesting as it grows more. I would say they're not quite here yet. but the size and the behavior of the institutional players is a little bit different from kind of how your traditional DeFi player works. We like to think about TVL and sizes in the billions, and they tend to think about sizes in the trillions. And it'll be an interesting growth of the market as we start to capture and sort of handle larger and larger sizes as institutional plays and RWAs move more and more on chain, hopefully, maybe. And just kind of seeing how the system can handle that over time and making sure that people are kind of positioned appropriately and ready for that. So where does this lead us to, and why is this risky and kind of worse than we all think it is? Like I said, bigger markets, bigger players, more and more people getting in and really grasping at anything they can to juice yields, pick up more returns. And as I started with, the classic kind of saying for, I would say, trades like this in the traditional finance world is picking up pennies in front of a steamroller, which sort of analogy for, you can find some tiny little yield and continue to, pick it up over time, but eventually you got this massive kind of steamroller risk behind you that's going to come crush you when you're not expecting it. Fortunately for us in DeFi, the pennies are more like $100 bills, with yields being what they are relative to what you'd get in the normal finance world doing some interest rate arbitrage trade. And for now, it seems worth it. Like, if you can get a 20% yield on a stable coin and level that up 5x, 6x, and get to, 100% plus in your yields, why wouldn't you do that? As there's a risk that it blows up, but if it's a 0.01% risk, then that's kind of worth it at the time. So people are starting to more and more kind of leverage up and kind of take advantage of it while they can. We'll take a step a little bit into kind of the TradFi markets a bit, talk a little bit about kind of the 2008 and what happened there. And it's sort of a nice analogy for kind of the way that the normal, the traditional finance system broke down and had kind of its own little explosion. As most people are familiar with, this kind of originated with mortgage-backed securities and subprime loans, and everyone thinking that these trades were amazing and safe and kind of structured in a way that could never possibly blow up. And then it did. S&P was down 50% over 2 years. We had trillions of dollars wiped out from the global economy, a massive recession. And it was sort of an interesting way in which that happened in the markets. It sort of was a built-up kind of understanding that things were going to blow up. And talking with people who were on the trading desks at the time, it became kind of literally a mark-to-market standoff where everyone knew that all the assets they held on their book were not quite worth what they thought they were, but nobody wanted to be the first mover to actually take that hit, because they would have to be, the first one to take the loss, and then sort of knew that that would start this margin call cascade across the entire industry, which, led to what happened where we had the bankruptcies of the banks and kind of this giant recession that sort of impacted the entire world for many years following it. Now, what about DeFi? We've seen kind of tastes of this, I would say, over time. A couple of the big ones being, the Terra Luna explosion from a couple years ago, where, again, these were these massively leveraged positions and people with sizes that I think they were not prepared for, and a liquidation cascades and unwind that people were not quite aware that that was a risk. In hindsight, I think to everyone it seemed sort of obvious that this was what was going to happen. But at the time, again, it was too good to ignore. So everyone was in it. I myself was in it a bit, and I think that that's sort of the prime example. We've seen it. We've seen hints of it a couple other times recently, where we have these kind of yield-bearing assets, again, massively leveraged against these non-yield-bearing assets, building up risk to a level that people are not as aware of, even on just like the straight-up asset basis. And then when you start to pair that with these assets that really are leverage trades under the surface to generate that yield on them, you sort of get a multiplying effect of when a perp market starts to unwind, you start to have issues with assets that are relying on that perp market. And yeah, it could get ugly at times whenever this, whatever triggers that unwind. We're in the hundreds of millions now, but as I said, as this market continues to grow and we get into the billions and hundreds of billions that are in these assets, that gets very, very sort of explosive in a way that we're not quite ready for. Some other things that we've seen hints of it, there was the Barristone kind of risk or incident from last month where we had a little bit of market wobbliness on its own, which then led to people kind of getting scared and wanting to get out of any sort of locked ETH vault position, and that kind of triggered its own unwind, which triggers a depeg, which then triggers more unwind, and it kind of cascades upon itself. And then another one that's very topical and very relevant to the last couple of days is the Bybit incident, where fortunately it sort of didn't have any kind of cascading effects, but there's some serious chances of this being something that could have a heavy impact on assets that are relying on those things when you don't quite know where sort of the underlying assets are being held. So for instance, had one of these kind of delta neutral trading positions had everything held at Bybit, Bybit loses all the funds, all of a sudden this yield bearing stablecoin doesn't actually have any asset backing anymore, that blows up, depegs, and then sort of triggers a cyclical downfall from there. Again, talked about this a little bit, but like I said, over the last couple of years, we've seen people more and more willing to take on these risks and consider these assets to be safe, when in practice they're not quite as safe as they think they are. So we've seen kind of lending protocols continue to grow their caps, grow their sizes, which is great. We'd love to see more usage of lending markets and things like that, but I think there's sort of a little bit of a lack of awareness to the kind of true level of safety of kind of what's happening under the surface with these. Yeah, and sort of the big kind of thing that this comes into is when everyone starts to kind of do their own risk assessments and build their own positions, and from a protocol level start to think about how they need to think about the risk of these positions and what happens when they start to unwind and set LTVs and caps appropriately. It tends to be done, I would say, a little bit at kind of an individual protocol level, which is great for the protocol, but becomes less great for the protocol when there are 10 protocols also doing that, and everyone sizes their max unwind or max deposit at whatever they think the market can handle, without realizing that everyone is going to be unwinding at the same time that they are. And that's when you really start to get into the cross-contagion risk, where if everyone has to unwind, if 10 protocols have to unwind 100 million of some asset because there's 100 million of liquidity available in the market, then all of a sudden you've got $1 billion trying to sell into a $100 million market, and you start to look elsewhere and kind of hedge that risk or sell out of it appropriately, and everything starts to tumble together. This is not necessarily specific to a leveraged unwind, but kind of the most recent, I would say, market explosion that we saw in the beginning of February, where you had sort of some rockiness to the market, and things really started to cascade, and liquidations started to stack up. And I think we dropped 20% over the course of an hour, which is a lot for a market. And I think kind of the crypto world, we kind of forget how big of a move that is. And it became, this was on mainnet, where this was, we internally at Euler were literally looking at kind of liquidations happening and how expensive stuff was, and gas spiked to 600, which was sort of the biggest I've seen in a while, and that on its own causes some interesting kind of market freezing problems. But again, you pair this with everyone trying to unwind at the same time, and this is sort of a very clear direct impact of that, where everyone is trying to hit the chain at the same time, get out of these positions, and then all of a sudden no one can do it because liquidity's dried up, it's too expensive to interact with, and you drop 20% in an hour. Fortunately, the market actually handled this one pretty well, I would say. It did feel like a little bit of a, kind of a red scare where it looked like it could keep going down, but yeah, as these positions go up and leverage continues to build over time, this is just going to get worse and worse. Yeah, so to repeat, like these trades are still kind of working at the moment, which is kind of an interesting dilemma, because you can still go get 20%, you can still go lever that up and get 100% on these trades, and it's going to continue to work until one day it's not going to work anymore, and it's going to it will be a bloodbath basically of whenever this really starts to unwind. And this is the reason I was titling this section a black swan is because these are sort of considered a black swan event where it's it's a 0.001% chance that it happens, but as we all know in DeFi, if it can happen, it will happen, and it's just really a matter of time. Kind of the way that I like to think the best ways to avoid those things are just to adjust your personal risk tolerance to what you think is appropriate. Be aware of these risks, and then from a protocol level, size vaults, size positions, and size caps accordingly. Set the risk parameters to something that's appropriate for the market and what you think the market can handle, and kind of take the whole dynamic of the market into account and not just your individual protocol. So where does Euler fit into this in both the good and the bad? So for those unfamiliar with Euler, Euler v2 is a lending platform. It's a interconnected vault system built in a modular way that allows kind of anyone to build and piece together any lending market that they want. It's structured where the kind of minimal unit is a vault, and vaults can be enabled as collateral for other vaults to sort of restructure or recreate any sort of lending market, whether that's isolated pairs or as sort of whole market clusters. And Euler allows for a collateral re-op application system, which means if you have asset A and asset B, you can enable them as collateral for each other. Then that means that your collateral can be borrowed out at the same time you're using it as collateral to borrow out another asset. Michael, our CEO, wrote a really good article about this. You can find it on our blog on sort of the trade-offs associated with that, which we'll talk a little bit about. But there's, like I said, there's been a big kind of focus on capital efficiency and reducing costs to borrow and allowing kind of scaling these positions up, which is great because, again, everyone makes more money. There's more usage. We can kind of bring more people into using lending markets. But again, this comes with a problem where you might run into situations where you're trying to unwind a position with some collateral, and that collateral might not actually be there. So what do we do? Initially, it's really all about kind of setting the risk parameters appropriately, making sure that you're sort of understanding this as a risk and setting sort of the caps and the LTV ratios to allow for that. And then when it comes to what happens in practice is, when there's something where things are starting to unwind and you're trying to take out collateral, it will, as collateral gets withdrawn and the utilization ratios go up, interest rates will go up for both depositors and borrowers, sort of really heavily incentivizing borrowers to pay back their position because they'll start to get charged, hundreds of %, and maybe incentivizing other suppliers to get back in as well. And a couple other things on top of that I'll talk about sort of next in the next couple of slides. So how do we deal with this, and how do we think about this at Euler? The big one for us is setting up markets appropriately from the get-go. One interesting kind of feature about Euler, as I said, it's sort of a very flexible system that allows the building and the setting up of isolated markets. So you can have kind of one whole cluster that exists as all of the ETH derivatives, and you have a cluster that exists as all the stablecoin derivatives, and those can exist completely separately from one another. So if there's something that happens where there's one of the ETH derivatives blows up, it's not going to impact kind of anybody else in any other asset. Like I said, we have a very sort of dynamic interest rate system where when utilization starts to change around, interest rates are going to change around appropriately with that, allowing for sort of the market to determine what's an appropriate level of utilization and deposits and borrows in a vault. Going back to kind of how these are set up from the get-go, there's a lot of thorough analysis done by kind of us and external risk managers on what LTVs should be, what risk parameters should be, what interest rate models should look like, so that we can sort of avoid any kind of catastrophic scenarios in the best way that we can. And also, one kind of feature that we've worked on a bunch is sort of whether or not things are governed or ungoverned, and fortunately we allow for both, which allows for, on the one hand, doing fully ungoverned immutable markets, but on the other, allows for governors to retain the option to kind of change parameters appropriately as market dynamics shift around, which can mean raising and lowering caps as more liquidity comes in and out, changing interest rate models and things along those lines to sort of best match what the current market scenarios are. One other big feature that helps kind of Euler stay safer in these scenarios is our liquidation system, which I think a lot of people might be familiar with, but it operates as kind of a reverse Dutch auction is what we like to call it, which is essentially kind of a scaling liquidation bonus as accounts become unhealthy. And what that means is that liquidations can happen very quickly and very early at a very low cost to the borrower. In our V1, I think the penalty was less than 1% for positions over $10,000, which is pretty good. And it sort of it scales as positions go more and more underwater, which really incentivizes kind of liquidators to get in and kind of clear these positions out and keep the protocol safe in kind of a quick, efficient way. Again, as I mentioned, sort of quickly or carefully scaling deposit caps and market sizes. And then on the other hand, we're also like to take sort of a fully customizable approach to kind of interesting new trades and markets that are emerging over time that we think pose interesting opportunities for people. But again, done in a careful way where you can sort of start small and kind of scale into it as it becomes more and more stable. And that's sort of it. Feel free to pop into our Discord or check us out at app.euler.finance or follow us on Twitter, or we'll be around. We have a booth here for the main conference. And yeah, thank you.
Tickle nodes into doing things right. Up to do with for do with for do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my corpse too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Get it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging. dancing where the bottleneck's been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Lag runs dial-up found. Age? Old speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just got you. 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 Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your joint and scene. Pan it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaks. At the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, those efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, boy. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin, urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin, dug in tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial-up found. Old as speak, young as each block mine down. Professor Wade's got the future on spin, urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin, plugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Buddha. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, cause permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stay. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked intrudes from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with as firewall splinter to confetti bits, I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Chaos is not compeller, order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age, old as speak, young as each block mine down. Professor Way's got the future on spin, urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Running mad, running mad's just a beta test for Buddha. Oh, he just got to oh, he just got to oh, he just got to oh, he just got to. Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen fiddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with a do with for do with do with do with do you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, not just 3 burner phones. Quantaries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Crawl through your joint dance scene. Bend it up, the entropy. Mace cracked balls like who's got the keys? Nullifiers huffing, you're just a rat with firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it guitar slide. Guitar coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin, urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spin, plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Age? Old as speak, young as each block mine down. Professor Wade's got the future on spin, urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spin, plugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just got
dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted.
Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
Floating fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, cause permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right.
Hello, hello. I am Grigore Rosu, the CEO and founder of Pi2. And our mission at Pi2 is to bring the next million developers to Web3. We have a big problem in Web3. A critical pain point is fragmentation. Hundreds of billions of dollars are split across different ecosystems, different blockchains, different applications that try to steal each other's users instead of smoothly working together. And user experience is at best very complex. It's a process to move funds from one ecosystem to another. Our proposal to this fragmentation problem is, in one word, universality. Universality with respect to programming languages and program execution. We want all programming languages to be available to Web3 developers. Universality with respect to verifiability and different proof mechanisms. We want all of them to be used. And universality with respect to distributed consensus to assure security guarantees. We want that to be as fast as possible. Sorry, something happened here. Oops. Don't touch anything. Okay, sorry, something is going on here. Let's go back and all right, you see, universality, one button only, which doesn't work. Okay. Our stack contains 3 major components. One, the universal language machine. Think of it as a blockchain in which you can write smart contracts in any programming languages. Even in programming languages that have not been invented yet, you can bring your own language, BYOL. The second component is the universal settlement layer, which allows us to generate proofs of execution and settle them across, on a common layer across various ecosystems. And that will be instant finality, instant settlement. And what counts as a proof can be both mathematical proofs and zero-knowledge proofs. You'll see that mathematical proofs are just as important or even more important than the zero-knowledge proofs. And finally, the Universal Consensus Protocol, which allows extremely scalable parallel consensus, which is not based on a total order of transactions or blocks, as in the blockchain. We'll talk more about that as well. What does this really mean? It means that we can bring, ULM means that we can bring all developers in all programming languages to Web3. Any developer is a Web3 developer. USL means that we can now prove correct execution across any applications in blockchain or not, in Web3 or Web2. That includes millions of applications around there. Everything, everybody who wants to prove that something happened can settle that computation on the USL. And UCP means that we can have consensus at optimal speed. You cannot do any faster than that. Again, same problem. The market opportunity for this universality that PySquare brings is immense. The world of developers grows from 20, 30,000 of developers as we have today in Web3 to 30 million or even 100 million if you include all the AI prompt developers as well. Essentially, every programming language can now become a Web3 program. A few words about universality. So why we want universality. But before diving into why we want universality, let's first try to understand why we don't have it already. What stays in the way? Programming language barriers. Programming languages are not easy to implement and to integrate in an ecosystem. Because for each programming language, you have a variety of tools that you want to offer to the developers. And you have cross-product between languages and tools. And each of these arrows is an entire complex system by itself. For example, compilers for C took 40 years to develop them, or interpreters for EVM. All these need to be implemented in order to be deployed on blockchains, which is a highly, highly non-trivial task. And not to mention maintenance, which is a hell. You have to maintain all these tools as languages evolve. And all languages evolve. All languages worth their salt evolve. We have a new version every few months. What is our secret sauce? The secret sauce, what brings us universality, is the K framework. The K framework was invented 20-ish years ago when I was still a researcher at NASA, and I moved to academia. And what K offers is this complete separation of concerns between programming languages and tools for programming languages. You define a programming language, or implement a programming language if you want, once and for all. And once you have that, which is a mathematical theory, now the K framework generates any tool that you need for your language. But what is really important here is the fact that K is a prover, mathematical prover. So everything that these tools will do to the right is supported by a mathematical proof under the hood that K constructs as it performs the task. For example, for execution, when you generate an interpreter for EVM, let's follow this path, the interpreter will not only execute EVM programs, but will also generate a mathematical proof why the execution of that EVM program is correct. And that allows us to separate concerns, which is a golden principle, programming languages from tools, while at the same time assuring correctness by construction. We call it correctness by construction. Very quickly, to give you a flavor of what it means to define a language in K. This is a complete definition of a simple language, which has only 39 lines. Here you have the syntax of the language. Here you have the semantics of the language. In the syntax of the language, you have usual context-free grammars describing how statements look like if then else, which is strict in the first argument. That means that we have to evaluate the first argument. On the right, we have semantics, and what's important here is you have like one semantic rule, which is an axiom, mathematically speaking, for each language construct. For if then else, well, it depends on how many cases. If then else has 2 cases, so it has 2 rules here. What is important here is not the details, but the fact that this is all you need to do in order to plug and play a new programming language. You define the language like this, and now plug it in K, and K will give you an interpreter that also constructs proofs under the hood. We are going to demonstrate this language, actually, a slightly more complex version of this language shortly. So pi squared comes from proof of proof. The name pi squared comes from proof of proof, specifically from zero-knowledge proof of mathematical proof. Why? Because K already gives us mathematical proofs, and now we generate ZK proofs from mathematical proofs. Bear with me for a second. All right. So at a very high level, this is how it works. You start with a program and an execution environment, same like in any ZK VM or VM for that matter. And what we get at the end is a zero-knowledge proof, same like in a ZK VM. What is different and critically important is the fact the programming language itself is an input. And also what is super important is that after K does its magic, we obtain a mathematical proof here that stands for the correctness of the execution of the program on that input, in that execution environment. Now, all is left to do now is to verify the integrity, the correctness of this mathematical proof. And we can use it, we can do it using any existing ZK technology or new ZK technologies. What I insist to observe on this slide is that one circuit works with all programming languages. You don't need one ZK VM for each VM, for each programming language. You only need one circuit for mathematics, and now you've got ZK VMs for all languages and all VMs. That's why we call this verifiable computing, this picture, verifiable computing 2.0, because it is verifiable computing as you know it, but it is universal and correct by construction. Universal because it works with all programming languages, and correct by construction because there is nothing to formally verify. ZK VMs need to be formally verified, which is a very complex process. Here you don't have to verify anything specific to any particular programming language. Moreover, the ZK circuit can be implemented using any ZK VM. So you can bring universality to any ZK VM this way, following this path. All right, so that's the theory. Now, what's the current status? 1 year ago, when we started the company, Pi Squared, actually exactly 1 year at the previous ETHDenver, this was our wish list. The K framework, in spite of being correct by construction, generating mathematical proofs, was slower, not in spite, it's kind of expected it was slower than handwritten interpreters, in particular, about 10x or 1,000% slower than Get. That was a big challenge. We had to improve the performance of K. And I'm happy to say that now, with all the optimizations that you can do at the mathematical level, mathematical proof optimizations, proof engineering, we managed to execute EVM programs actually faster than EVM. Right? This is, again, very important because it's not only that you get a correct by construction execution that builds a mathematical proof under the hood, but it is also faster than the ad hoc manually written interpreters. So performance is not an issue. Whoever tells you that formal semantics is great but it's slow, tell them no, not anymore. And send them to our white papers. All of these optimizations and techniques I explain in detail in the white papers. The second task that we really wanted to get accomplished very quickly was to prove the concept, to prove the proof of proof makes sense. That it makes sense to generate a mathematical proof and then a zero-knowledge proof out of it. And initially, we wanted to use just one ZK VM, which was risk zero. But very shortly, we started talking to different ZK VM developers, and everybody was interested. And before we knew it, we had 7 different implementations of our ZK circuit using all the major ZK VMs. And also, we have a benchmark now that contains more than 1,200 tests, multiplied it by 7. And many people think that this is actually the most extensive benchmark ever developed for ZK VMs. It's all public, everything is open source. You can also read the white paper to see the details and how the whole thing works. Finally, we wanted to demonstrate that we can generate mathematically provably correct claims from Ethereum transactions, Ethereum blocks. So more or less to mirror Ethereum on the USL by proving every single block mathematically. Nobody has done that before, by the way. We heard of zero-knowledge proofs of blocks, but now mathematical proofs of blocks. Okay, more rigorous than that. Well, we've done more than we expected. Actually, we'll see a demo today by my colleagues here, that not only that we've done that, but we also integrated USL with Wormhole. And now we can use USL instead of Guardians to prove all the transactions and to have instant finality. And also with the pod protocol that gives us maximum optimal consensus. And our pod colleagues are also here. Thank you. Finally, one thing that we didn't plan initially, and now it's done and we'll demonstrate it as well, was to actually demonstrate an Ethereum-like blockchain that would support all programming languages. Right? That's what we want, after all, to plug and play our language. And what would be easier to understand than an Ethereum-like blockchain where you can do certain transactions and plug a new programming language and then write smart contracts in that language. It turned out that that was a lot simpler than we imagined to do. Sometimes when you do things, the right things right, they are simpler than you expect. So we are going to demonstrate that as well. So it's basically a blockchain ULM that supports all programming languages. And moreover, it is implemented using for consensus on top of the pod protocol. And with this, I will pass it to Ovidiu, who will talk about this blockchain ULM and will demonstrate it as well live.
Thank you, Grigore. GM, everyone. My name is Ovidiu, and I'm glad to talk to you about ULM, which is something I've been working at with PySquared for the last few months. And we're very proud of what we achieved up until now, in the sense that you will see that in just a few minutes, we will be able to have one blockchain where you not just bring your own language, you bring your own languages. For now, we support Solidity, EVM, WASM, Rust, and also a special language that you've probably never heard about up until now, but you will. And we'll soon have also Move, Python, Go, JS, and so on. Now, let's talk some theory first. I'll be brief, I won't bore you, I promise. So, when it comes to formal semantics, it's basically a mathematical definition of all behaviors of all programs in that language. Meaning that if we have that mathematical definition of said programming languages, we can know how that programming language behaves in any VM, ISA, computational model, and so on. Moreover, we can have, using that definition, automatically generated language interpreters that are correct by construction and fast. Now, how do we get this and put it on a blockchain? We do this by having interpreters that should be able to modify the same blockchain state. That's one precondition. And we solve that by having all semantics implement the ULM interface. And second of all, we have smart contracts that need to interact with each other. I want to have my EVM contract calling your WASM contract without any issue. So that's why we have contract calls that take place through ABI encodings, meaning that all smart contract interactions are programming language agnostic, meaning that if I have an EVM contract, I don't care that your contract is WASM. I can just call it like any other contract. And we'll prove that soon. Now, let's see how everything works for a minute. So first of all, we have a transaction that goes into the ULM, and that transaction is a contract call. That contract call sees what semantics it has to use in order to execute said call. Maybe it's EVM, maybe it's Rust, maybe it's move, and so on. And using a ULM interface, reads and writes to the blockchain database. And that's how we do all those changes. The ULM interface basically abstractizes everything that's programming language specific when it comes to interaction with the blockchain database. And that's the beauty of it. Now, we went through enough talk. Let's see something hands-on. So with that being said, Musab, let's go through the bring your own language demo. So this is our quick demo in which we show you how to bring your own language, meaning that you can just come to the chain and in the same way you would have a smart contract deployed, you can deploy your own language, which will work and can then be referenced in smart contracts to use them. And let's see how we're going to do that. And you can see in the top corner that we have a language registry, which shows all the available languages that we have on chain. For now, we have EVM, and that's relevant, obviously, because it's the basic programming language for EVM compatible blockchains, and it's K beforehand, and it's important because it's not the usual execution engine, it's rather implemented in K, and that's how we run programs, by using K, not by having the usual execution engine. We also have the ID, which I'm going to show why it's relevant later, and the hash, which helps prove that the language that we're running is authentic. Basically, by having the ID and hash of a programming language, we can check that the programming language that we're using in a smart contract is the language we expect it to be. We can also, using that hash, check in the node, as I said, and we have this definition here as well to see what you see here is the definition of said programming language. We won't lose too much time on this, it's just interesting to see all the complexity behind it, but on-chain, we don't care too much about the specifics of it. Now that we have the hash, what we'll shortly do is add one more language.
EVM execution
and as we add a language, we see that we can choose any language that we want, and we will quickly add Solidity.
Solidity. So
as you see, we have the definition here, and as this definition will be added on-chain via a transaction. You can see it's a transaction like any other sent via MetaMask. And we also have a disclaimer showing what we have saved on-chain, URL, language ID, definition, and so on. Now, the language is there. We can use it. It was that simple. And attention, this is Solidity. We're not compiling it to EVM. We take the ID, and we input the ID here, because we use it when deploying a contract to tell the node, hey, this contract will be in this programming language. It's relevant. That's the code you need to run. And as we do that, let's deploy a token that is directly Solidity on-chain. Now, we're deploying USDC copy. You can see the Solidity code there. And attention, we're just hex encoding it and sending it to the blockchain. You can even see that it's recognized as a contract deployment transaction, and without doing any change to MetaMask, of course. Now, as this transaction gets completed, we have the address of said contract that we can simply copy and then use to interact with the contract. Now, we input the address, and as the address goes on, we also obviously need the ABI, because that's the usual interaction that we use for all contract interactions, and we will use the USDC API. We have some options there because we're in a demo mode. Now we load said contract and we can see USD coin, symbol USDC. We quickly copy our address, check our balance. Obviously our balance is 0 because we just deployed the contract. and we're going to mint some tokens. We're going to mint pi squared tokens, 986. And you can see it's a simple transaction like any other. Now, we don't care anymore that the contract is directly in Solidity. All we care about is the fact that it's a contract and we can interact with it. And we have the transaction receipt, which shows that it's working like any EVM execution engine. It's, again, language agnostic. It doesn't care that it's written in Solidity. And now, as I read my balance, you can see that I have 986 tokens, which is amazing. We have interacted with a Solidity contract directly, and we're going to show that on-chain as well. Now, you can see that it is detected as being a Solidity contract, and that's relevant. How does the Explorer know this, even though all contract interactions are language agnostic? Well, we'll show you exactly. If we see the contract code, you can see it's hex encoding, but the first 4 bytes are the ID of the programming language used. That's the only change we make outside to the EVM interface, to say so. We have the language ID, which is basically how the node knows, okay, I will run this code using this programming language. Now that we have done it, let's add one more language. Now, in order to go a bit faster, we will use the predefined menu, and we will deploy Rust. You see, it's just as before. Nothing special when compared to Solidity, but very special in general. Special enough in the sense that with a simple transaction, we enable 3 million Rust developers to use our blockchain. And we use the language ID. We deploy a contract. We're deploying a wrapped Bitcoin contract. And as this contract goes on, we're pretty much going to go through a similar flow as we did with Solidity. And as we do it, you can see wrapped Bitcoin as the name. You can see WBTC as the symbol. But now we will use the allowance endpoint to show that it works as well. Now, as we use this endpoint, now we will use just pi as our mock value. We send the transaction, you see it's recognized as a spending cap request. MetaMask has no idea this is Rust. And MetaMask shouldn't even know it is Rust. This just makes it greater. Okay, the transaction is completed and we have this on-chain. We have the spending cap increased, and we can also see it on-chain. You can also see that once again is detected as a Rust contract. The language is known because of the ID here. The code is again hex encoded, but is directly Rust.
Okay.
And you can see we have the free languages. And now what we will do is also run some KEVM code to show that it works as well.
We're going to get the ID.
So you saw before Solidity, which was directly Solidity. We didn't compile it to EVM. Now let's see some ugly EVM bytecode being executed.
And by
now
using this
we put it on chain. This is wrapped Ethereum, and as opposed to other tokens, we will need to deposit Ethereum to actually get wrapped Ethereum back. So you can see the name there, wrapped Ethereum, and what we'll do is we'll check our balance, which is 0, and we will deposit some Ethereum. We will deposit 0.1 Ethereum, and we confirm the transaction. We see that all works well. We wait for the transaction to be completed, and as the transaction is done, we have the receipt again, all well. The balance is here, 0.1, and we can also see the balance here. The contract has received 0.1 Ethereum from us without any issue, and it's also depleted from my own balance. And we can also check it on the Explorer. We can see that it's recognized as a KEVM contract, which is the usual EVM. We can see it has 0.1 Ethereum. Basically, it works without having to worry about anything that is programming language dependent.
directly Rust.
Users don't
Now
even
let's
have to
add
know it's written in
WASM.
something specific. Now we add
As we add
WASM
WASM,
quick as well.
It's going to be a transaction like all other
The
transactions.
transaction is going to be completed any second now. And boom, we're now at our fourth language in just a few minutes.
Now we put the language ID here.
We also deploy Doge in WASM.
contract, which you can see is
And
already compiled to
as the
WASM.
transaction gets deployed, we will have the address and we'll once again look to mint some tokens in order to show that it works.
And let's
Okay, you see Dogecoin, Doge, all's good. We copy the address, we see our balance, we go and mint,
mint some tokens real
yada
quick,
yada.
just to see that it works as well.
Here goes the transaction, and
Okay.
now we have
As the transaction gets completed, let's read our balance
the
again,
balance there.
and
Good.
let's also
So we had
check
Rust
that.
directly, and we also had Rust that was compiled to WASM, and
We have
yeah,
the language ID
it's as
here,
it's
everything
it's
is
as
working
easy as that to say that. Now we have shown some
Last but not least,
impressive
let's
languages,
also
some very well-known languages, but you don't have to use something that's already created.
simple
You can
comes
just
from
create
simple
your own
developing
programming language, which is simple in this
which
case.
is
We created a
basically
programming language just to test things
programming
around and see that
language
it
we have
works.
created
Why we
as
did
a
that?
toy to
Well,
just play
because
around
we
and
can,
check
and we
that
want to show that you can create your own programming language as well. It might be good, it might be bad, but the point is it's going to be supported on chain without any issues. Now, as we have deployed simple,
simple to test things around, and it actually works.
we are going to also deploy a contract in simple. And because it's our own programming language, we're going to deploy our own mock Pi² token.
Simple.
Now, we go real quick to deploy it,
We deploy it really
and
quick,
as we confirm it,
and once
we will get the address and once again go through the whole process. And if you are thinking, oh, he's at the third token already, how many more is he gonna mint? If you feel like it might be a bit boring, great, it should be. Having multiple programming languages shouldn't be exciting or complicated. It should just be there like a normality. Now we mint 9.86 tokens, Pi². And as the transaction gets completed, we check the balance and it's there, obviously. We also check it on chain. We can see we have the Pi² token that is detected as being in a simple programming language. The language ID is there, easy to see. Now, what we have just done is have 5 different programming languages on the same blockchain in under 15 minutes, for sure. This is amazing. And it's not just that. We have more. Musab, I think you can stop this, and we can go back. We can go to the next demo, which is going to be the decentralized exchange demo. We're going to show how you can basically have a DEX that has multiple programming languages interacting between them. Basically, you can have a token that is created in one language and swap it for a token in another language. Now, let me explain the setup real quick. So we have our DEX contract, the router, the Pi² token, the Wrap Bitcoin token, DAI, USDC, and Doge. You can see real quick, our router, that is the DEX itself, is an EVM contract. Next, you can see the ID there as well, as it's EVM. And next token is Pi². You can see it's in simple. Next token is Wrap Bitcoin in Rust. Next is DAI, it's EVM again. Next is USDC in Solidity. Next is Dogecoin in WASM. And what we're going to do is do a quick swap. We'll swap from USDC to Doge. What's relevant to know here is that here we don't show the programming languages because the interface does not care about the languages. You can see it's recognized as a spending cap request first. You have to approve the spending of tokens for the contract. And here it goes. Once the spending cap is processed, we will have also the transfer request. We approve that as well. And As that gets done, you are able to see that our balances have changed, and we can also check that on-chain. Now, this is my favorite part. If we look at the transaction on-chain, you can see that we have interacted with a KEVM contract, transferred 986 Solidity tokens, and received back 895 something Doge tokens that are in WASM. 3 programming languages interacting between each others in one single transaction or contract call. That is as amazing as it gets and as simple as it gets. It's not, I wouldn't even call it language agnostic. Like, the DEX, not just that it doesn't care about the language. The DEX doesn't even know they exist. It's language atheistic, if you want to call it like that. And you can see that it works as we say it does, in the sense that here's the code of the DEX, and here's the transfer. No programming language is specified. You can see that it's just where we send, what we send, and so on. And this is because we use, as we said, ABI encoding to basically make sure that all the inputs and outputs that are sent between programming languages are, let's say, normalized. So again, KEVM, Solidity, WASM, one transaction working together without any issue. So this has been our multi-language swap demo. I think you can stop the recording, Musab, thank you. And that being said, I want to give the mic to E to continue with our next cool products.
Hello, everyone. My name is E, and I'm glad to be here. So first, I'd like to thank Ovidio for his very informative presentation on these universal language machines. So next, I will talk about our second component in our universality stack, which is the universal settlement layer, and we call it USL. So if I want to give one sentence to describe what USL is, then it will be bring any off-chain data to on-chain in a verifiable way. So there are 2 keywords in this sentence, the data and verifiable. And this corresponds to 2 important concepts in the USL, which are claims and proofs. Claims are anything provable, and the proofs are something that used to verify the correctness of the claims. So let me try to give you some examples of different claims and proofs. So first, we can use claims to capture the computations in any program languages and VMs. For example, we can use block transition claim that is interpreted as this tuple, the pre-state, the code you can think of as a list of transactions, and the post-state. So this tuple can capture the blockchain transition in any rollups. And we also can have this blockchain query claim that simply we call this view function on a certain state to get some results. And these claims can be verified through different mechanisms. They can either be verified through mathematical proofs, or they can be verified through CK proofs in any approved CK VMs. And even they can also be verified through re-execution. Then we can also have the consensus proof, which basically states that a claim is included in a canonical blockchain. So the accompanying proof is usually a list of signatures from all the validators that approve this block. And we can also use the claims to capture those validated knowledge or information like oracles or identity, and we can prove them through digital signatures or certificates from zkTLS. So now we have some basic concepts of claims and proofs. The USL is just a decentralized network of incentivized verifiers. And those verifiers receives claims and proofs from users or applications and verifies them. So there's one important property of USL that I want to highlight. First, we require those claims to be self-contained, meaning that they can be verified independently. And then all the verified claims actually form a set instead of list or sequence. This is very important because the order of the verification is not relevant anymore. And actually, they can be verified in parallel. This important property can enable us to achieve fast finality if we choose the underlying consensus protocol properly. That I will talk about it more in the implementation slide. So once the claims are validated, and then the claims are accumulated in this validated claim set, which is the state of the USL. And the USL also provides this so-called membership or inclusion proof for user to check whether a claim belongs to the USL state. So, and this membership proof are succinct and can be checked very efficiently. And all the applications or blockchains who wants to connect to the USL only needs to implement these simple verify membership functions. Okay, now so far I covered this universality of USL, which it incorporates various types of claims and proofs. And also, once the claims is verified on USL, it can be used everywhere. Next, I want to talk about this our implementation of the USL settlement layer. And we are collaborating with the pod team. Actually, we're implementing the USL on top of the pod. So first, what is pod? The pod is a layer 1 primitives that receives transactions as input and produce logs as output. But unlike the traditional blockchain or consensus protocol, so the pod doesn't provide a persistent total order on the transactions. In fact, the order of transactions are subject to change over time. And by accepting these features, it actually allows for making very performant systems. And the pod team has produced some theoretical results showing that pod is optimal in latency and throughput under some constraints. So as we said, we implement our universal settlement layer on top of pod. We implement the verification logic as a precompiled and deployed as some specific address on top of in the pod network. And submitting claims and proofs to the USL is equivalent to send this verified transaction to the pod network. So once this verified transaction is executed successfully, and it will be appended to the pod log. And we have this USL client to query the pod network for this log and the membership proof. This membership proof is just an aggregation of signatures of the validators from pod who approves these transactions. And then we can use these claims and membership proof anywhere in those dApps. So next part, I would like to introduce real use cases of our USL, where we use USL as a verification layer for the Wormhole's entity framework. So the Wormhole entity framework is a native token transfer framework that allows users to transfer tokens between chains by burning or locking tokens on the source chain and minting tokens on the destination chain. So under the hood, there's a message verification layer which verifies the messages between chains. And it also allows developers to introduce their own message verification layer, and they can configure which message verification protocol to use at runtime. So this is basically the basic workflow and how we use this USL as a customized message verification layer. So first, user submit bridge transactions to interact with the entity manager. And this entity manager contract will burn the tokens on the source chain and construct an entity message that specifies the amount of token to be minted on the destination chain. So the message will be stored on the source chain, and we have this claim generator off-chain component to monitor the transactions on the source chain, especially those bridge transactions, and generate claims and proofs, which we will see in a second, and submit those claims and proofs to the USL. Once these proofs claims are verified on the USL, the relayer component will query the USL for the validated claim and the membership proof and submit it to the destination chain. On the destination chain, it will first check the membership proof by running this verify membership function, and then they will parse the validated claim to extract useful information and performs the token minting. Now let's go to see the real demo. So I have prepared 2 demos, and let's play the first one. Okay, so this is the bridge demo where it allows user to transfer tokens from Sepolia to Arbitrum Sepolia network. So in this transfer tab, it is a very basic bridge interface. And on the upper right, there's a force button to allow user to mint some test tokens. In the history tab, it basically shows the bridge transaction histories. And each entry contains information like the source and destination transaction hashes, the pod transaction that verifies the claim and proof, and the claim itself. Now let's move back to the transfer tab and transfer some tokens. We already approved a limited amount of tokens, and now let's input some token to transfer. So okay, let's input 11 and then click the transfer button. So the standard is quite, the workflow is quite standard, and we approve the bridge transactions on the source chain. So now let's go to the history page and wait for the bridge transaction to be completed. As you can see, now the transaction on source chain is completed, and the pod transaction is completed, and we just need to wait a little while for the destination chain to be a transaction to be completed. Okay, now the bridge is completed, and we can click each link to verify what is happening. So we first click the link on the source chain. And we can see that the amount of token is actually burned on the source chain. And then we click the transaction on the destination chain, and we can see the same amount of token are actually minted on the destination. As we said, so actually what happens under the hood is that our claim generator generates claim about the entity message and then submits to the USL for verification. Now let's see what the claim and proofs actually look like. So we can click the claim button, and it will show you the hex format. And we can click the decode claim, and it will transform this hex format into human readable format. So in this assumption field, it shows the block header of the current block being queried. And then this action field shows the actual view function that we are called on this blockchain state. And the result is the entity manager that is being stored on the source chain. And we can further decode it to see the actual tokens, the amount of tokens to be minted on the destination chain. Now we can go to the proof tab to see the actual proofs that is being generated. They are actually the Merkle inclusion proofs for those storage keys that are being used to execute the view functions. Okay, great. And then once the claims are verified on the pod, right, and then the relayer will submit this verified claim and proof to the destination chain, and we can check the transaction of the pod on this pod explorer. Finally, let's go back to the transfer page and verify that all the balances on the two chains are updated correctly. So this is the end of the first demo. Okay, so let's play the second demo, where I will show you a scenario where the claim generator stops working and the user can still complete the bridge transfer in a trustless way. So let's first stop the claim generator and then performs a normal bridge transfer. So we enter 21 tokens here and do the transfer. We click approve the transactions in the MetaMask, and we go to the history tab to see what actually happens. So now the transaction, a source transaction is completed, and we can see the amount of tokens is burned on the source chain. However, since the claim generator is not working, so no one will generate claims and proofs, and the whole bridge workflow gets stuck. Instead of waiting for the developers to fix the issues, the actual users can start the claim generator locally, because the bridge is actually by the claims and proofs. It doesn't care who actually generates the claims and proofs, as long as the claims can be verified by USL. So now let's do that. Let's start the claim generator in manual mode. Once in the manual mode, user needs to provide the transaction hash of the source chain and submit it to the claim generator. Let's copy it from the Explorer and give it to our local claim generator. Now we submit it to the local generator, and boom, you can see that it is its job to generate proofs and claims and submit to the pod, and everything goes well. Now we can check the destination chain transactions. And verifies that the actual amount of tokens are minted on the destination chain. I think that this concludes my demo. So, and I will hand over the presentation to Grigore for the UCP component.
All right, thank you. I hope you guys are as excited as we are about what happened here. Let me put things a bit back into perspective. Okay, so we've seen multiple programming languages on the same blockchain. And we've seen programs written in these multiple programming languages where they interoperate on the same blockchain. Programs written in Wasm, Rust, Solidity, and Simple. But Simple is a new language altogether. All of them on the same blockchain. Okay? It felt and looked like any blockchain using MetaMask to do transactions and everything. But what happened under the hood is critical, because everything was turned into a mathematical proof that was checked. Okay, so everything is mathematically correct. You don't have to worry about an incorrect implementation of an interpreter or compiler, right? Because everything was executed with the actual mathematical definition of the programming language. That has never happened before. Okay, we've seen zero-knowledge proofs where you have a way to generate a zero-knowledge certificate for an actual interpreter. Here, there is no interpreter, actually. There is just a mathematical proof that justifies an execution. The interpreter only helps generate the mathematical proof. Then we've also seen how we can implement bridges, so basically programs across different blockchains and different languages, also using the same infrastructure, where claims are settled once and for all at the speed of light, using a protocol called the Universal Consensus Protocol, inspired and done in collaboration with the pod colleagues from the new pod company. We're also writing a paper together, so we cannot tell you a lot about the protocol right now. But what is important to know is that every single transaction generated a claim, which is a rigorously proved mathematical fact, which is verified by a decentralized network of verifiers who agree that that is indeed correct. And that happens only with a round trip of messages. So it's the maximum, it's the optimal possible consensus that you can get. And with that, we have a few minutes for questions before, or maybe let's put this again into perspective before you ask questions. What really happens here is that now we can use all programming languages to write Web3 applications. The programming language is not a barrier anymore. You no longer have to learn weird programming languages only to become a Web3 developer. You can use your favorite programming language. All you need is to plug and play it into the Web3 framework, and you've got it. That opens the Web3 space to millions. And if we include AI inferencers and AI prompts, hundreds of millions of users. And that's how it should be. With that, we thank you, and we are open for questions. We have 5-6 more minutes for questions in case anybody has any question. Thank you, first of all. And questions, please. We can pass the microphone for questions. We save some time for questions on purpose. There is no bad question. Please feel free to ask anything.
What's the timeline to get to production or mainnet for the tech?
Oh, good question. So 6 months, let's make it simple. 6 months for testnet, 1 year for mainnet. And mainnet for us means the USL network that can settle claims in any languages and interconnected with several layer 1s and layer 2s as well.
Hi, my name is Nico. I'm super excited about what you guys are building. And something that I wanted to ask you, maybe you already sort of explained it, but I didn't get it, so sorry in advance. For the programming languages that you can implement, how different can they be in terms of, is it only syntax that, for example, you're building something in Solidity and then you're going to be able to build it in Rust? It's like Solidity with syntax on Rust, or how deep can you go with that?
The languages don't know anything about each other. There is obviously an API, a storage API they have to agree on. So they read and write using an API. So you have, when you define the semantics, you have to accept that API and define the semantics using that API.
Yeah, and that was my question about the API. The API is sort of like a generic form of what Solidity does. So in some level, you're still going to be we'll have to take care of some bugs that are in Solidity, but in Rust, because of the way that API is. Basically, the question is, how deep can you go with the language, and how different they can be between them besides the syntax?
You have to stop at some moment where you say, this is my storage model, and every language has to agree on the storage model, how you access the storage model. For example, Move. Move has a slightly different storage model, more general than EVMs, but they can live together. We can go, that's very technical, it gets very technical. In some sense, that is what we call semantics engineering. So when you define a language, it's an engineering process, and you have to understand the semantics, you have to understand the built-ins on which you build your semantics. Like numbers, you have to pick numbers, infinite numbers, finite size numbers, and so on. And similarly, you have to build to accept your domains on top of which you define computations above. And this is a moving target, even for us now, the storage model. We keep improving the storage model as we add new languages.
Thank you so much.
Any other questions?
Or you guys want to add more on that, on the storage model? No. All right. Thank you for the questions, and thank you for being here. And I hope you'll soon try USL and ULM. You can try them right now. Go to our website, and you'll find them there. Thank you.
Floating fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games.
dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted.
Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
Armor clinking with layer 2 lullaby, scalability scripture. She winks at the moon while Lagrange drools over slow motion doom. Walks grind, her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Let it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spin, book. Urgent notes dancing where the bottlenecks been. Professor Wade's got the future on crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs down a fountain. Age? Old speak, young as each block mine down. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Calling me mad, but mad's just a beta test. A boodle. Oh, P-Jobs trying to do. Oh, P-Jobs trying to do. Oh, P-Jobs trying to do. Oh, P-Jobs trying to do.
Hello, how's the audio? Good? Hi everyone, my name's Michael Strike. I am the speaker and the chief technical evangelist over at the QRL. So my, just a moment about me, my classical background is route switch firewall process improvement. I've been a network engineer for a long time. My non-classical career is here at the quantum resistant ledger. I've been in blockchain since about 2013. And most of the slides have a lot of the words on it, so that I know that half of you probably aren't even listening, so you'll be able to circle back to it if you hear anything interesting and I've already moved on. All right, let's get started. We're going to try and do something fun here. We're going to try and make blockchain and quantum fun and sexy. One of those might work, probably not both at the same time, but let's see. All right, who are we? Our project is the quantum resistant ledger. We've been running our own layer 1 since, actually that should say 2018. We're the only blockchain in the world that uses an NIST recommended DSA since the first block, which makes us fully quantum computer secure. We have coming up this year by 2025 our Zond hard fork. And with the hard fork, we're going to be migrating to some new NIST standards, which we're going to get into a little bit shortly. So let's move on. Who knows what a quantum computer is? Okay, I saw 2 hands. All right, let's see if we can have some fun with this. So your phones, your PCs, all the computers you see in front of you, these are all classical computers. They all have what's called very deterministic outcomes. Quantum computers have probabilistic outcomes. And the part of nature in quantum mechanics that makes it possible to be able to have a probabilistic outcome and be able to solve problems that classical computers cannot is because of quantum superposition and entanglement. If I start talking about either of those, they will pull the mic, but if someone else wants to, come down by the booth and I'm happy to do that. So essentially, quantum computers enable an exponential speed up for solving specific problems such as the elliptical curve discrete logarithm problem, which underpins Bitcoin's ETHDSA. We will get into that a little bit more. So this is an abbreviated version, but this is essentially how a Bitcoin wallet is created. A Bitcoin wallet, when you create a private key, is nothing more really more than a 256-bit random number. Using ETHDSA with the SECP 256K1 parameters, that's a type of ETHDSA, you create a public key, and that's like a one-way function. Now you have a private and a public key. This is also why you can create a Bitcoin wallet offline. So how do transaction outputs work? This is necessary to understand in order to understand the DSA, which I'll get into, and also the solution, which I'll also get into. So when you're doing a transaction output on Bitcoin, the first thing is you present your public key, the one that you generated from what I was talking about a moment ago. You present your public key to the node that you're sending your transaction to. Eventually that gets hashed using SHA-256. It gets hashed a second time, and that reduces the public key size. Essentially the final output is what's actually called a Bitcoin address, which gets written to the blockchain in most transaction types, but not all. Essentially what this means is a Bitcoin transaction sent most of the time means the public key is exposed. And that all goes back to that's okay with asymmetric cryptography. You're supposed to be able to reveal your public keys, but that also goes back to the 1970s when asymmetric encryption was initially proposed. What's a DSA? When it comes to post-quantum security in blockchain, the DSA is everything. DSA is a cryptographic method for signing and verifying data using public key cryptography. ECDSA is what the DSA that Bitcoin uses. And that is based on the ECDLP problem, which is hard for classical computers to solve, as we talked about earlier. Everyone with me so far? Yes? All right. So what's the problem? Well, Bitcoin and 99% of all other altcoins have essentially a quantum problem. And the problem is Shor's algorithm run on a sufficiently powerful quantum computer can break ECDLP and thus ECDSA, which is Bitcoin's digital signature algorithm, and it can allow a private key to be created from a public key, which is not supposed to be able to happen. So that's Salt Bae, but it's actually, I couldn't find a good Pepper picture, so I really wanted to use him. I did anyway. Public keys are already peppered all over the blockchains, mempools. Public keys are being harvested for future years. Store now, decrypt later, all those things. Public keys are meant to be out in the open, and they are. So what's at risk? Older Bitcoin transactions, in a lot of cases, the public key is stored directly on chain. Yay, immutability, but immutability also has a couple caveats in that in the early days of pay-to-public key hash transactions, the public key is actually written to the blockchain, and there may be funds, Bitcoin funds specifically, tied to that transaction, and maybe, and that's all visible because of one of the core principles of blockchain, which is immutability. So newer Bitcoin transactions involve presenting the public key to nodes. We talked about that a little bit early. When I send a transaction or a TX output, that I provide my public key because that serves as cryptographic proof that I created that transaction, and it ties to my private key. And in return, when you send a transaction out, all Bitcoin's nodes broadcast all of those nodes to all other nodes, and that way, hopefully, when a miner solves a block and sends it to a node, it will have that transaction in it. Great, okay, so this all leads us to something called Shor's algorithm. So this is a quantum computer specific algorithm. It is quantum, it is not classical. It was developed by Peter Shor, a brilliant mathematician in 1994. Designed to run only on quantum computers, although you can simulate it using a classical computer. And it has the potential to break RSA and ECC, or ECDSA, like we talked about with Bitcoin, by efficiently finding prime factors of large numbers. So the latest estimates, and this has been on for a while now, is that a quantum computer with up to around 2,500 logical error-corrected qubits could potentially break Bitcoin's 256-bit ECDSA. We're not there yet. We don't think we are there yet. We're not there yet. A lot of people like to talk about quantum computers as far as being able to take over the hashing market and being able to up the difficulty by solving cryptographic problems with it. That's really not that feasible. The ASICs, the worldwide ASICs, and the power that's being drawn right now, that would be attacked by Grovers, which gives you a quadratic speed up. To be able to find the pre-image in order to mine faster than all of the miners, it's not really a problem. The biggest problem right now is going to be Shor's algorithm. And like I said, we're looking at less than 2,500 logical qubits. And that less than 2,500 really is right based on the technology as we understand it now. It doesn't accommodate for future advances in algorithms, improvements to Shor's algorithm. It doesn't, maybe there's a it doesn't apply to the type of quantum computer, being a trapped ion or photonic, whatever. So Bitcoin can just hard fork. I love this question. So as with many things in life, it's really the nuances that really get important. I would say Bitcoin can hard fork, but I wouldn't say Bitcoin can just hard fork. First off, you can hard fork. I give a lot of credit to blockchain developers are some of the most creative people in the world, and I'm only saying that because everyone here is a developer and I'm outnumbered as an engineer. So, but community consensus on new DSA and block numbers for community consensus on a new DSA would be needed. You'd have to select a block number in order to start your new post-quantum digital signature algorithm. You'd have to upgrade all the nodes, you'd have to successfully hard fork, and then you'd have to deprecate all that ETHDSA stuff that I talk about. That is all doable. There's nothing in the rule book. There's nothing in the community or physics or anything that says that that can't be done. But I'm going to tell you guys what the catches are, and these are the things that people don't talk about. This next slide. Even if you execute it perfectly, users are going to have to make a manual transaction from the old Bitcoin address that they have to the new post-quantum secure address, be it a LAN port signature or whatever. This is a manual thing. It can't be automated. It will be impossible to migrate all of the 21 million Bitcoin. The 21 million is a magic number in the ethos of blockchain. It'll only ever be 21 million. Well, there's gonna be, unfortunately, it would have to be less because you won't be able to migrate all of them, and there will be orphans. By the way, that is Annie. She's the most famous orphan that I know, and just realized how old I was. God. So the other thing is the old DSAs must be deprecated before powerful quantum computers exist in order to protect non-migrated Bitcoin. Also, migrating old wallets to new post-quantum secure wallets will take a minimum of 74 to 300 days. I recently had a podcast where we were talking to some academics. They were doing a paper. Their estimate was 70 to 80 days. And that's just Bitcoin processing power in order to take that old ETHDSA Bitcoin address and migrate it. So you'll need at least 75 days of, some people like to call it downtime. I don't like the word downtime, but those transactions would need to be interlaced with normal TX outputs and normal Bitcoin transactions. That's substantial. That's a lot of processing time. Also, we have no idea as to the real state of quantum computer progress. Governments have no reason to tell us, and they stopped returning my emails. So, except NIST, those guys are great. They always return my emails. So here's the current ecosystem. Here's the blockchain challenges that we have. First off, no ERC20s are post-quantum secure. You can tell me whatever you want about an ERC20. You can take the Library of Congress, you can XMSS wrap it and then put it on the blockchain, but at the end of the day, if a quantum computer can empty your wallet and steal all your gas, you're not going to be able to go anywhere with it. You're done. 99% of blockchains use ETHDSA and are thus vulnerable. And the other thing is you need to be post-quantum secure since the first block. Otherwise, you have this huge mess that I'm describing in that you have to go and have all of those previous transactions migrated to a new DSA, deprecate the old DSA, and then make sure that everything's there. And then you eventually have to cut off the old DSA and stop the transactions, and whatever isn't migrated is lost. So maybe BTC becomes BTQ, or I don't know. Someone will figure that out. These are some known attack vectors. I'm not really going to go through them. How am I doing on time? 6 minutes? Okay. Okay, these are some known attack vectors. You get a couple of these have to do with the double spend. And if anyone that studied Bitcoin history, you know that that was one of the biggest problems that the Satoshi's white paper solved was the double spend problem, based on solving the Byzantine Empire problem. Oh, let me go back one more. If you have time, ask me in person about a novel attack vector called rogue node theory. So a lot of us has heard not your keys, not your crypto. We all know that, right? Not your crypto, right? We're all self-custody? No? Okay, some of us. I saw 2 hands. But also not your node, not your rules. And that's not as well known, but it is relevant because these nuances that I'm talking about that make these attack vectors realistic or work, some of them depend on that, but rogue node theory depends on not your node, not your rules. Always run your own node. So, if you're looking at other blockchains that claim post-quantum security, there's a few. I put together a few checklist items. First off, as I mentioned before, the blockchain should be post-quantum secure since its first block. This second one might seem a little silly, but it's really not if you look at volume and market caps. Does the project have an actual chain? Is the DSA in cryptography recognized by industry experts, government, statehoods, NIST, people that know what they're talking about and the experts? Is the DSA recognized by them, or is it something that's closed source or proprietary or whatever? Are there any remaining legacy DSAs that are not post-quantum secure on the blockchain? If so, then I can create a transaction here that's not post-quantum secure, and I can create one that is post-quantum secure, but somehow it's the same token or the same coin, right? That doesn't maintain fungibility, and that coin should be, they should maintain value. This coin, 1.0 of this coin should maintain 1.0 of this coin. And meaning, an additional post-quantum secure transaction type does not a post-quantum secure blockchain make. That is Yoda, and he is a little upset because he was browsing the internet the other day and he saw a lot of post-quantum claims that might not be the whole story. So we have a solution at the QRL. How much time? He's gone. We have a solution at the QRL. I'm going to move forward a little bit. We are coming up with a hard fork. The hard fork is called Project Zond. We're moving from proof of work to proof of stake. We're using all NIST government-grade security. We're adding Solidity compatibility. If you're able to code in Ethereum, you'll be able to code on our chain in post-quantum secure since the first block. You'll be able to tell your customers that if you deploy code on us and you have your code running on Ethereum, if your smart contract's on both places, you'll be able to, in some way, tell your customers that you're post-quantum secure. This is a big deal, guys. This doesn't exist anywhere else. If you want to go post-quantum secure today, besides with QRL, you're going to have to make some compromises. And believe me, if you start making compromises in security and blockchain, the trolls are going to find you online real quick. We announced our beta testnet live as of yesterday. This is all day one information. You'll be able to set up and test your own private node. Anyone that wants to take a screenshot, I'll leave that on for just a sec. How am I doing on time? 2 minutes. Do not take my word for it. Don't trust the guy in the hat. Governments are working on this problem as well. If you see your state there, this is a short list. It's not a complete list, but it gives you an idea as to how many governments are working on this problem. Oh, and United States of America, or US, just moved their target deadline a few months ago from 2035 to 2030 in order to upgrade all of their systems to post-quantum security. These are corporations, big guys. They're all working on quantum CPUs. This did not exist 5-10 years ago. Things are changing. Things are different this time. Do your own research. NFA. Questions? Come see us at booth 419. I think that location's right. And And those are some links. Feel free to screenshot. And that's it. I'd ask any questions, but I'm getting the eye, so I think that means I got 20 seconds left before the mic cut. Oh, okay, any questions? Did that make sense? So minimum staking as it is right now is 40,000 QRL. That's last I heard. $40,000 QRL is the coin price times the number of QRL. 40,000. You'd have to, I don't know what the price is right now. Sounds like someone knows. All right, hey guys, thank you so much. I mean, blockchain and quantum, it's difficult to talk about this stuff. You try to make it fun. But don't repeat any of this at any after-bar parties. Thank you.
Young as each block mine down. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Plugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Boodle. Oh, he just got just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing, while the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash, but we don't need your central banks. Regen biddlers stacking stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. Chains. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco ball, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with the bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do.
Hey everyone! Today I will be speaking about the unseen threat, why attackers see what developers miss. I'm going to speak from my own experience because I work in cybersecurity for quite a lot. Yep, and of course, yeah, it works. So yeah, I started hacking 15 years ago. It started very early. You know, I was the first kid to get banned during the high school, during the IT class, when I tried to hack the other people with Keylogger. So it started very early. Also, I joined Web3 in 2013, when, you know, the Bitcoin was still growing up. I remember I had 200 Bitcoins back then. It still hurts. So yeah, for the last 3 years, I worked for Hacken. It's the cybersecurity company. I found around 70 critical issues, and I also found a lot of issues in bug bounty programs. So yeah, the Hacken itself is the cybersecurity company, Web3 cybersecurity company. We do almost everything: audits, pen testing, proof of reserves. We work with the big clients. I even managed to find an issue for Binance. But let's finish on that, and let's think how hackers think. To be honest, I'm only telling from my own experience, but I think it all starts with curiosity. Just a simple question: how do things work? What will happen if I change something? Can I somehow bypass the restriction? You know, the same story. When I was a kid, I was the one who was disassembling the toys to see how they work, the cloaks or some other stuff, because it was more interesting than the toy itself. To create something better from it was more interesting than just the toy itself. I really love that. So, you know, I would like to show you how I think when I start working with the projects, when I start the audit, when I do some bug bounty. I will show you 10 places, my top 10, and general patterns where I search for the issues. It's mostly from my own experience. I don't know if other hackers work the same, but good luck with making a general ranking. So this is my private one. OK, let's start with number 10. It's the code ported from another platforms or languages. Yeah, so in many cases, when we have a project, for example, in Solidity, and the team is starting to moving it to Solana or Sui Aptos, they try to copy everything they have because the product is already audited and it works. It works so far, so let's just copy it. But it's not so simple because there is a lot of platform-specific behavior. So if they have developers who don't have real experience with other platform, they just want to port it because they think it's easy, it's a very big trap. And a lot of companies fall for it. Recently, I was working on such project, and they were porting from from Rust to movement, and it should be almost the same, but they made 2 critical mistakes in their project. Yeah, so they made an issue with filtering data. At the bottom is the example. So in the original code, it was Oracle project. In the original code, they were parsing data for every Oracle, every feed they had. And it worked correctly. It was taking the timestamp of the first package, and then it was verifying that timestamp for all other feeds packages is the same. But when they ported this code to movement, they decided to do an optimization. And they added option to filter data, to receive only data for given feed from the same signet data. And of course, they made a mistake, because later, when they verified this data, they verified only filtered data. So all the other data which was in the package for the other feeds was not validated at all. But later, in the same code, part of this unverified data was used to calculate the timestamp. It allowed to move timestamp into the future for an Oracle. Pretty big issue. The other very interesting issue I had was when code was ported from 64-bit platform to 32-bit platform. So, right now, almost all the code runs in 64 bits, but there's a very rare case, which is WebAssembly, which uses usually 32 bits. And by doing that, they assume that nothing can go wrong, but it did, because the change, the size of U size changed from 8 to 4 bytes, and it introduced overflow. And it was possible to manipulate the signature verification. OK, next category, 9. Code using algorithms. I really love algorithms because before starting my cybersecurity career, I worked a lot with optimizations, games, algorithms. So I have a lot of experience in this. So I always check how the developers use the algorithms. Even the simple one, like sorting, like finding median, or some mathematical calculation. Do they know about the complexity or not? Are they handling edge cases correctly? Because the interesting fact is that actually there's a lot of developers who don't really have experience with algorithms, or the only thing they have, like maybe sometimes they don't even know what's the difference between stable and unstable sorting. But if they don't know that, they can introduce some issues in the projects. And I will show you one issue like this. This one is very, very, very stupid, but I got 50K bug bounty for it, so it should be interesting. And the issue was that one project, it was layer 1 project, used base 58 instead of base 64 to encode the data. When they, emitted events, for example, or some logs, etc., they were using base 58. And, there's not much difference. There's only 4 characters difference when it comes to base 58 encoding. But there's one hidden problem, which costed them 50K, and it's complexity. Base 58 has n² complexity. So the thing is, if you start feeding it with a lot of data, the computations will take a lot of time, minutes, sometimes even hours. And base 64 don't have this problem. So yeah, simple mistake, and someone and a potential attacker would be able to take down the entire network just by sending a huge transactions with base 58. So yeah, a stupid mistake, but it happens. I was interested if AI would be able to find out this mistake, because right now we're having a lot of tools, AI-based, to search for mistakes. I asked ChatGPT O1 Pro, yeah, I subscribe, if it's safe to use base 58. It said it is safe. OK, so I asked it, OK, in this structure, which they had in their project, it was used for emitting events and serialization of data. Is it still safe? It said yes again. So I asked it even more directly, what are the risks involved with base 58? And it didn't know. So for me, that's a good thing. It means I can still keep my job for maybe a few years. OK, next thing, number 8, code on which multiple developers work together. This is hard to show in a practical example, and it would be a little unfair. But the thing is, when I'm checking the code, sometimes the difference between code quality is very visible. I can see that there's one experienced developer, the lead, who's create amazing code, but he has like 2 others who make mistakes. And sometimes just by following the other developers, those who make mistakes, it's very possible to find the issue. Because focusing on the weakest point is the best idea, and sometimes the developer can be this weakest point. OK, next thing, recently updated code, especially old code. So let's say we have some big project. It has a lot of legacy code, and they want to introduce a new feature. And to do that, they need to change something in the old code. And the problem is, when they do that, sometimes this old code changes behavior or some other code, which was used for something else. Like, in many cases, the updates like this are being done in rush. And it's, from my experience, it's quite usual to make mistakes, especially when changing something in the old code. So have a lot of tests. OK, next thing, code integrating with third-party components. OK, the problem with this is that usually the developers don't assume how to handle the situation if something goes wrong. So, OK, what should we do if Oracle starts to returning wrong data, or if it has some denial of service and don't work correctly? There are, or even worse, what if this third party will want to somehow abuse our own smart contract? From my experience, like 60% of projects don't assume such thing. They just integrate with third party, and they count that everything will work correctly. So this is the place I always check, especially that a lot of projects have small mistakes, low severity issues, not dangerous at all. But sometimes the low severity issues can lead to high or critical severity issues in other projects. OK, number 5, complex code with lack of tests. So sometimes when you have very ambitious project, like using zero-knowledge proof, or like doing perpetual decentralized exchange, lending market, you have a lot of complex operation, a lot of math. And when I see one thing, there's one special thing. When I see that the code is not tested, then it's a huge red flag. It means that almost for sure there's going to be something wrong with this. Because if developer cannot even test its own code, then it says a lot about the project. So I always check those places. So yeah. And the next thing with very complex logic is that sometimes, even if you achieve 100% test coverage, there are still some edge cases which, OK, maybe in total everything is covered, but in individual cases, it's still very, very easy to miss something. Yeah. I have an example of such issue. 2 years ago, I found a critical issue in Binance zero-knowledge proof of reserves. They were using pretty complex solution to calculate the assets. They were dividing it into the batches, linking with each other. And I found an issue which allowed to fake their proof when they were linking one batch with another. So yeah, I won't be going into the details. If you want, you will find it in the internet, the whole story. So yeah, search for Binance zero-knowledge proof of reserve Hacken, and you will find the whole details about the story. OK, next thing, number 4, dangerous places in the code. So there are some dangerous things like cryptography, randomness, oracles, serialization. I love serialization. And the thing is that people think that those functions, packages are easy, but they are not. They are not easy at all. they require very specialistic knowledge to use them correctly. So yeah, when I only see someone trying to use those things, or even worse, trying to change them somehow or customize it, then it's another red flag because yeah, the complexity behind it is really huge. I will have some example. For example, with randomness. This is when I didn't find this issue, but when I read about this, Jesus, it was amazing. So imagine that we have a blockchain game, rolling a dice, and it has some randomness. Let's say it takes it from chain, or it has some built-in randomness. And you send the money, and based on this randomness result, you win or lose money. And the idea was that when you lose money, the smart contract will use more gas. So yeah. And there was a very small difference between winning and losing the money, like few percent difference in a gas. And someone managed to abuse it just by setting maximum gas cost of the transaction. Yeah. So every transaction he was sending, if it wasn't winning, it was reverted because there was not enough gas. But when he was winning, the transaction was successful. So yeah, crazy edge case. Same goes for cryptographic function, for example, hashing. Like, okay, we want to create some hashing function which will generate something unique address for some input data. And if we don't do it correctly, we may end up in a situation where different data will result in the same hash. Like in this example, it all depends how we enter the length of given field, because combining some things together, we can use them to generate an issues. So yeah, and if everything, but the thing is, it will work. Everything will work perfectly. Test will work correctly. But if a hacker sees this, then he will know how to abuse it. Yeah. Number 3, multi-step operations, multi-transactions. Okay, this is another very complex case because it generates a lot of edge cases. So if you need to do like 3 operations to make a transaction, or I don't know, lend some money from lending market, then pay off your debt, then there is a lot of opportunity to find some issues, because everything can happen between 2 transactions. The state of the smart contract can be changed, liquidity can be changed, prices of the token can be changed, and in many cases, not all edge cases are considered. And the same thing like with the complex code. If there's no test for it, if I don't see test of such scenarios, that's a huge red flag. As I say, if you cannot test something, you shouldn't be writing it. And it gets even worse if you add flash loan. And I found one very interesting issue with this. It was on lending platform. By doing very complex transaction, I was able to create exploit which would be able to steal $1.1 million. So yeah, this was my biggest issue I found when it comes to number of money. Imagine this, being able to steal $1 million. Of course, I didn't do it. I explained the whole issue, how by doing these 8 steps, by doing some crazy stuff in the transaction, like starting liquidation twice and creating one more loan doing the liquidation, you can steal the money, get an advantage over the lending pool. And of course, they fixed the issue, paid some bounty. The whole story is also publicly available. I was speaking about this during the DEF CON a few months ago. You can search for lending platform Hacken exploit, and you will find it. Okay, next thing, number 2, reinventing the wheel, coding something that shouldn't be coded. Sometimes the developers are very ambitious. They want to do everything by themselves. So if they start working on things like custom serialization, custom cryptography, custom peer-to-peer, something which is already, very available, then it's a very, very high chance that they're gonna make some mistake with this. Those things are extremely hard to code. There are hundreds of edge cases, and in every situation, I've seen that the project is building something themselves because they have a better idea or something like this. It always ends up with a mess, seriously. So it's a very big red flag when projects try to do everything themselves. Yeah, there were some cases, but I'm gonna skip it because I have last minute. So last thing, number one, my most favorite, economic attacks. Those are perfect because sometimes even auditors cannot detect them. Yeah, because for many developers and auditors, not all of them, of course, they don't understand economics between economics of a given project. For example, lending market, where they make money, where they lose them, what are the risks. And if they don't understand it, it can be easily abused. Let's give you an example. Let's say we have a lending platform, we can borrow USDC, we can borrow Ethereum, and we can use some meme coins to add our collateral. But those meme coins have very low market liquidity pool. In this case, by buying those meme coins for $20,000, we can raise the price to $1 and use it as collateral, which would be worth $1 million, borrow $200,000, and steal the money. Yeah, those are the perfect attacks. Yeah. Last thing, and I'm finishing, and the most important thing is to combine it all together. OK, so yeah, if you combine everything together, then you get the best results. Thank you.
You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my broken fuck. Stealth crawl through your junk dancing. Hand it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Energy notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Plugging tomorrow with yesterday's RAM stain. Crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller. Orders just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox.
What's up, everybody? My name's Osman. I'm one of the developer relations engineers here at Alchemy.
Hey guys, I am Sahil. I'm also one of the developer relations engineer here at Alchemy. And today we're super excited to be here at ETHDenver. It is one of the most amazing events and just a nice way to see what everyone is working on before the beginning of the year. And today we're excited to showcase what we have been seeing at Alchemy, being one of the top teams in Web3, and where we see the future going from here. Now let Osman take over from here.
Yeah, thanks, Sahil. Yeah, so, we wanted to start off this conversation from first principles. You guys are here at ETHDenver. It's one of the biggest Ethereum conferences of the year. It happens yearly. And if you walk around this build-a-thon, and then tomorrow when you go to the hackathon, you're going to see so many booths. You're going to see so many names of companies that you may recognize, some companies that you may not recognize. And it feels like this industry is consistently growing at a pace that we can't even quantify anymore. But actually, let's try and quantify it. So just in the past year, it really does feel like we're at an inflection point for this industry where we're seeing the active addresses across all blockchains hitting an all-time high. Really feeling reminiscent of numbers related to early internet adoption, 220 million active addresses across the crypto ecosystem, generally speaking. But what we're seeing that's super interesting is that this isn't just happening across one chain, that the diversity of different blockchains across the ecosystem is actually incubating their own unique communities, their own unique developer ecosystems, and it's happening all over the industry, right? It's happening throughout many chains that leverage the EVM. It's happening on new chains like Solana. But one of the biggest trends that we at Alchemy have seen this year and recent years is this move to layer 2 networks and rollups in general. And what we're seeing is that actually a significant portion of Ethereum's activity is moving to these L2s. You're seeing many of the top applications nowadays that are leveraging the EVM, that are leveraging Ethereum, they're built on top of one of the top rollups or one of the top layer 2s today. And what this is doing is actually reducing costs for users at a very significant level. But what has that actually done for the usage of these networks, right? We're seeing costs get lowered. We're seeing developer communities proliferate across so many different chains. But this is what really speaks to the growth of this industry. If you guys were here, ETHDenver, 4 years ago, blockchains today, in 2025, 4 years ago, we processed 50 times as many transactions per second across all blockchains than we did just 4 years ago. So not only have we seen the demand for block space increase like crazy, we've also seen the amount of block space increase like crazy, and the usage and the actual sustainability of that block space increasing in a very significant way. But you might be wondering, how? What has changed in the past 4 years that has allowed this level of growth to take place? Well, just 4 years ago, it felt like we were all having these conversations about how do we scale Ethereum? How do we actually launch applications that can sustain hundreds of thousands or millions of users? And the thing that we've seen here at Alchemy is that when applications reach a certain threshold, when they cross that line from toy project to real application that's sustaining load, they need real, powerful, sustainable infrastructure that powers their entire platform. And we just threw some metrics up here for you guys to take a look at about in the past 7 years, what have we seen actually happen with the folks that are using this technology and the stats related to that. So you can see 90% of Web2 companies that are building in Web3, they leverage Alchemy. We've powered 50 billion public RPC requests in the past couple of years. And these numbers are continuously growing as the industry is expanding because of what we just talked about here. So now I'm going to go ahead and pass it off to Sahil, who's going to talk about one of the major problems that we're seeing within the industry.
Thanks, Usman. So as we just talked about, we are seeing huge growth in the ecosystem. But let's talk about how we even got here. So I think we can all agree that blockchain data is complex. And we realized this at Alchemy years ago. So even today, when you have to build an app, you have to use different providers for your app. Different ones for fetching blockchain data, different ones for smart wallets, and different ones for building your rollups. So what we did, we built Alchemy, which is the only comprehensive Web3 development platform. We have the Node API, we have data services, we have rollups, and we have tools. But at the heart of it all is Node services. Today, we support 40+ chains, and we serve 30 billion requests per week with 99.99% uptime. And you can see the progression of chains we have added, how it is growing.
And what this means is that smart accounts are coming in a really big way. And what we've seen in the past year here at Alchemy is that these stats speak for themselves. Users are choosing to deploy smart accounts as opposed to original EOAs when they're deploying new wallets for the reasons that we've seen in the past couple of years. So today, 16 million smart accounts have just been deployed by us across all these different chains that you can see here. And it's been really exciting to see. But what makes a smart account so interesting, right? What these folks have figured out, when you look at across these chains and you look at all these user ops, and you're like, wait, that's a lot of growth. A lot of folks are actually using smart accounts. They've realized in order to increase the transactions on their application, in order to make the application smoother to use for users, they need to solve UX. And UX comes in many different ways for many different people. You have the UX for your builders, you have the UX for your chains, and you have the UX for your users. And if you are able to solve all of those problems for each of those people, you create this really unique flywheel that actually onboards many users on chain in a really significant way. And what we've seen is that teams that are actually using smart wallets and smart accounts are actually seeing 4 times the transaction growth that they would have seen prior to using smart wallets. And so when we talk about this, we talk about smart wallets, we talk about simplifying UX for developers. It's really talking about 2 key steps here. Wallets are really 2 key parts. When you guys use your friendly wallet that you're utilizing, there's really 2 key components to it. There's the onboarding aspect, actually signing up, actually signing transactions, and then there's the transactions aspect of the fees associated with the transactions and other gasless operations. Many providers that you see, they do really good at this. 1/2 of the equation, which is embedded wallets. This is what we're all so familiar with. Sign in with Google, sign in with X, sign in with Apple, really creating a really friendly user experience to embed a wallet within your platform so that users can sign in with operations that they're familiar with and still gain the functionality of a wallet. But what we're seeing is that this second half of the equation, which is transacting, typically happens from other providers. Right? Providers who are good at this typically don't really focus on this. And why is this important? The second half of this equation, transacting, is the second half of that user experience. When your user transacts, yes, you are able to create a wallet for them in a really simple way, but are you able to make them feel like using this application is like using any other Web2 application, that there's no such thing as gas, that there's no such thing as signing transactions, and that's where smart accounts come in. And what we're seeing throughout the industry today is that these tools are super fragmented. Any production-grade application, if any of you guys are running production-grade infrastructure or building any application that has this smart account functionality, you've either had to deploy an embedded wallet and then connect it to some smart account that's working in the back end. But today, one of the really unique things that we focused here on Alchemy was that we wanted to make sure that we didn't give our developers the problem of having to go to 10 different providers to stitch together their platform. So we said when we look at EIP 7702 coming, we look at the smart account and an embedded wallet ecosystem today, let's create an offering that actually combines both worlds so that developers don't have to combine XYZ provider with XYZ provider to create a user experience that is meaningful for them. They can just do it all in one SDK, our Alchemy Account Kit SDK. And if anyone was here at ETHDenver last year, you remember 3Lao, you remember that they onboarded all of their users in a very Web2 friendly way, all using Alchemy Account Kit. So this was super cool. I think they hosted a really big party and they were using the sign-in to kind of get everyone inside of it. We're starting to see this proliferate in a very major way, and the big reason for that is because costs have now dropped less than 5 cents, and these costs are working to be even cheaper as more layer 2s are proliferating and as EIP 7702 is on the horizon. So we've talked about the infrastructure powering applications. We've talked about how to connect to applications, but one really key big proliferation we're also seeing in the industry is developers launching their own chain in the form of rollups. So I'm going to hand it off to Sahil, who's going to talk about all the cool ways that we support rollups here at Alchemy.
Thanks, Usman. Rollups, rollups, rollups. I think we can all agree rollups are the hot topic right now. But why should you even launch your own rollup? It isn't like I just have an app and I should launch my own rollup. So why should you? Let me explain it to you with a couple of different examples. There are a few reasons for launching your own rollup. One of that is faster and more reliable transactions and lower transaction fee. A key example of this is World Chain. World was 50% plus of OP mainnet transactions, and that was resulting in slower transaction confirmations, rising fees, and unpredictable transaction times. And when they launched their own rollup with Alchemy, with us, they were able to solve all of these problems. Another example of this is customization. What you really need a rollup when you need to customize the chain. You really need to fine-tune it for your own needs. An example of this is T.xyz, who are connecting on-chain user wallets with GitHub PGP keys. And lastly, of course, there are financial incentives for launching your own rollup. You have the sequencer fees, you have MEV, and the native gas tokens, of course. An example of this is Degen Chain, who are using Degen as the native gas token for their chain, which provides the utility to that token. But why should you use Alchemy for rollups? A few reasons for this. One major one is reliability. We have 7+ years of engineering experience and proven track record of supporting large customers. So you get to save on engineering overhead and reputational risk. Plus, we have 99.99% uptime. Another key feature is when you launch with Alchemy, you don't just get your own rollup. You get the whole damn platform. You get instant access to millions of developers who have already signed with Alchemy. You get access to our tools, our documentation, and our dashboard, all included in one package. Plus, you get the white glove customization and support for customers launching with app chains. And lastly, we're really excited to tell you more about the Rollups programs that we have launched recently. One of them is the Everything On-Chain Fund we just launched 2 days ago, and the Arbitrum Grant. The Arbitrum Grant is for teams launching on the Arbitrum Orbit stack, and it is a $10 million of total budget and credits, plus the Everyone On-Chain Fund is $5 million. Please stay tuned for more information on these at the end of our slides. And we have a very special offer for you at the end. So stay tuned. And now I'm going to pass it over to Usman, who's going to talk more about data services.
Yeah, so it's been an interesting conversation so far, right? We've talked about base level infrastructure. We've talked about how to connect apps to that infrastructure. And we've also talked about deploying your own chain when you get there. But if you're a developer in the audience, you know that's not enough. You know that there's many other pieces to building an app that we didn't cover here today. And that's why when we say that we support the whole damn platform, we really mean the whole damn platform. And what we mean by that is we talked about smart wallets, we talked about RPC infrastructure, we talked about deploying your own rollup, but we have a slew of enhanced APIs that we know that devs have been using that they love to ping that make it easy to build your application, right? NFT APIs, token APIs, transfer APIs. We also support WebSockets and smart WebSockets and custom webhooks. And one thing that we're really excited to be kind of diving a little bit more deeper into is this sector related to subgraphs and indexing and things related to that, where we've seen that devs typically, when they build their applications, they have to connect to our RPC provider and do all these other things. But the subgraph is always something they have to go to a third-party provider for, and we're happy to kind of announce that they can do all this stuff in one platform. So briefly, we're also going to just touch on some really exciting things related to pricing.
Let's talk about pricing. Pricing is one of the most important things that developers look at when choosing a development platform. We're super excited to announce that we have just launched the most affordable Web3 pricing plan in Web3. It is pay-as-you-go, no monthly fees. So you only pay for what you use. And on top of that, we have significantly reduced the CU costs for each of our APIs. For our enterprise partnership, for our enterprise customers, our pricing is very simple. You pay one fee to access all the amazing products and services we provide, including SLAs, 24/7 engineering support, and even pay in crypto. And we're not just ending there. Here is Usman with a big announcement.
Yeah, so thanks so much, Sahil. So yeah, so one of the interesting things that we've talked a lot about here today is all these cool tools that devs can utilize. And you know, here at Alchemy, we're really committed not to just enhancing the developer ecosystem within Alchemy or just building up our own developer ecosystem. We really want to push the EVM forward. We really want to push the Ethereum ecosystem forward. And we really want to empower just devs to build apps in super easy ways. So today, we're super excited to announce the launch of Scaffold Alchemy, which is a brand new open source tool. If you're familiar, if you're an OG in the Ethereum space, you know Scaffold ETH. You know what it did for the ecosystem. You know how easy it made to spin up Web3 apps. It's easily one of the most forked open source dev repos out there in the industry today. And we wanted to revamp it. We wanted to make it a little bit better using all the super cool tools that we just showcased to you today. All those tools that we just talked about, you can leverage them all within one little IDE. if you've ever wanted to build with Web3, if anyone here is new to building in Web3, this is your tool. If you ever just want to get started, this is your tool. And we wanted to showcase a super cool demo. I was gonna live code it. It won't take me that long, but I can see I have 1 minute and 17 seconds here. So we knew that could happen, and we just shot this really cool video to showcase to you guys what this could look like. So as you can see here, we're just kind of spinning up an app, create Web3 dApp, we name our project, we CD into the repo, and then we can go ahead and immediately open up our Explorer, right, or our IDE. And then when you go into your IDE, we give you a base smart contract that you can start with. You can deploy it right off the bat. You don't have to fund any pre-wallet address. It already comes ready to go. You can see how that the counter contract just deployed on its own. And then here's the UI for Scaffold Alchemy. You can see that we're signing in with our Web2 login. And then here's that fresh UI that is sending on-chain transactions right as soon as you started. Utilizing this, you can actually build really anything that you want. You can take this framework. It has a bunch of Alchemy APIs and tools built into it. And you can edit it in whatever way you would like. So super excited to offer this, especially for here at ETHDenver, where we know a lot of devs are going to be utilizing this tool. We've already talked to a bunch of devs, and they're super hyped to kind of just have this super easy way to spin up. But we have one last big announcement to make.
Yeah, thanks, Usman. I love how Scaffold Alchemy kind of combines everything together, all of those products we talked about. So definitely check it out and even use it for your hackathon project. And here's me keeping my promise of a special offer just for you guys. If you're paying for infra anywhere else, we are giving you 3 months of free infrastructure. So scan this QR code right now before it is gone. It is non-transferable and claimable by 15th of March just for you. And there is more information on our grants and funds for rollups. And thank you so much, guys. That is everything from us for today, and we're out of time. And that's Alchemy for you. Thank you.
Thanks so much.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da. Alliance architect with the buffer corn's grit, teaching still.
Welcome. Thanks for joining our ZK Verify Buildathon presentation. I'm Rollup Support with ZK Verify Foundation. I'm going to go through, this is specifically for the builders here in the audience, so I'm going to talk loud. All right, got a quick agenda so you can see what we're going to go over. Basically, with ZK Verify, we're doing ZK proof verification. Zero knowledge proofs is kind of an esoteric type thing, so I'm going to do a brief explanation of it. I'm going to talk about what it can be used for, then talk about what ZK Verify is bringing to the party, who we are to be building this stuff, and why you can rely on us, and then talk about specifically what our awards are, how they can be stacked with some of the other awards here, and how you're going to get support to build an awesome project. So let's go through and do that. All right, so first off, zero knowledge proofs, they're kind of a new, well, they're not really that new, but they're new in use technology that allows you to prove that a computation happened, which seems kind of boring until you realize you can do private transactions, you can prove that an AI model was run without exposing the underlying model, you can do private polling and voting. There's all sorts of different things that it enables. Also supply chain, but the big idea that I think zero knowledge proof is going to be used for over the next few years is to be able to allow Web 2 to interact with Web 3. So you can prove that something in a Web 2 application was done, and then you can bring that information along with its zero knowledge proof into any type of Web 3 system. The important thing to know about zero knowledge proofs in this advanced cryptographic mathematics that it does is that you have to prove, you have to create the zero knowledge proof, and then you have to verify it. Doesn't do you any good to create it without verifying it. And so you can probably guess what it is that we do by the name of our project. We verify ZK proofs. Now that seems kind of basic, but there's actually a really big problem in the industry. So I'm wearing my Zen shirt because I'm the co-founder of Horizon, and that's one of the first projects that was launched that had a ZK circuit in it. And that was back in 2017. So Zen, Horizon, still an ongoing project. ZK Verify is from the same team that has all this experience. And we recognized over the years with this experience that the problem for zero knowledge proofs is they're slow and they're expensive. And I mean, who wants to pay $5 to $10 to do kind of private polling or voting? You need to be able to pay 1 or 2 cents. You need to be able to do it quickly. So that's the specific problem we're addressing. We're making zero knowledge proofs fast and inexpensive. And to do that, we have 2 things that we're doing. So first off, there's a bunch of new ways to create zero knowledge proofs using new cryptography. It makes it much more accessible for people that don't understand how to build all the circuits and the logic to do that. So one of them is ZK virtual machines. So RISC-0 is an example of that. You can take any type of Rust code, run it in the ZK virtual machine, and it'll create a zero knowledge proof that the Rust code was run properly. Another is many different types of elliptic curves. The elliptic curve that's on Ethereum, which is where most people have been verifying their ZK proofs, is an older curve. There's newer and more secure curves. And as many of y'all know, elliptic curves aren't quantum computing safe. So we have to look at new types of zero-knowledge proofs that are quantum computing safe if we really want to look to the future. Then another thing is Plonkish types of proofs. So these are proofs that are optimized for being able to be used on end-user devices like mobile phones or web browsers. In a lot of cases, you want to be able to do your proofs right where the information is, right where the user is. The cool thing about doing them on your devices is they have a very low cost to create them. And so with the flexibility of Plonkish proofs, and Aztec has created the Noir system to create these proofs, it's a great domain-specific language. Now, the next part is the verification. So our developers decided that the best way to be able to address the two main problems of slow and expensive was to make an optimized blockchain system that's built on new technology. This is built on Substrate blockchain framework, very similar to Polkadot. And you can see over on the diagram that we have multiple different types of proofs that can be sent to our proof verification system. And once 2 of 3 validators verify the proofs, they're put it onto the blockchain. For a lot of Web 2 applications, that's all you need right there. Fast, quick, inexpensive proofs. However, we also integrate with many different types of Ethereum virtual machines. So we can take a bunch of these proofs, the receipts for them, send a data structure to our smart contract on an EVM, and then the proof verification is available to any Web3 contract that wants to use them. So this is our system. ZK Verify is not a smart contract platform. It's a system that enables people to use new, fast, and inexpensive proofs for many different types of applications. So, who's building this? Can you rely on us for doing this? All right, let me tell you a little bit about the team that's building ZK Verify. This is Horizon Labs. So Horizon Labs has 8 years of experience building blockchains and zero-knowledge systems. We got people all over the world. We've worked on many different projects with many different organizations. So first, if you like our first project, Zen, you can still buy it on Binance and Coinbase. It's been active since 2017. Our team developed Zendu, a ZK-based sidechain bridge. This is actually designed to help a UTXO protocol like Bitcoin extend its capabilities by having a sidechain to another blockchain. We implemented that for Horizon, and so right now the Horizon project is actually 2 blockchains, a UTXO proof of work and an EVM sidechain, which happened to be a custom EVM developed by the Horizon Labs team. One of our cryptographers was a key contributor to the Poseidon 2 hash function paper for you ZK technology geeks. Poseidon 2 is a pretty advanced hash system. And then last summer, we really got into the middle of doing DeFi and Web3 experience by working with the Ape DAO to bring Ape Chain onto Arbitrum as an Orbit chain. So we're experienced in a lot of different aspects, specifically with zero-knowledge proofs and with blockchains. All right, so what are the awards that we got here at the ETHDenver? We got $25,000 in prizes. 5 different prizes, all for the same thing. Build us a really cool app, a Web 2 app, a Web 3 app that uses zero-knowledge proofs, and integral to the application, creates a proof, verifies it on ZK Verify. Pretty straightforward. We got lots of people that can help you, and specifically this week, we deployed our ZK Verify attestation smart contract onto other sponsors, so you can stack prizes. You can stack prizes with Flow, with Base, with BNB Chain, Arbitrum, or Ethereum. So not only can you do ZK proofs and get prize money from us for a good project, but also from these other projects as well. So we want to help you be successful with that. Now, how are you going to learn and use ZK Verify? We have outstanding documentation. Go to our documentation website. It explains what it is, how to use it. We got links to tutorials on using these 3 main verifiers. Then we got example code on games. And then recently, we just wrapped up an online hackathon that was done with DevFolio. And you can see the screenshot to the right here of some of the winning projects. And so let's talk about some of those winning projects, because they can provide inspiration for the projects that y'all might want to build. And this was a Web3 online hackathon. So these are all Web3 projects that integrate the ZK Verify smart contract. One of them, I'll just go across the top. So Shadow ML was a way to be able to use a machine learning algorithm, prove that it was used, but hide the actual algorithm. And I can think that many people who develop proprietary training algorithms and sell their usage, whether through tokens or fees or whatever, but they can generate a ZK proof that this algorithm was actually used. WinWave is a cool way of selecting a winner in a social media platform. So from like X, the number of likes or the number of follows or different things like that. And it does it in a provably fair way and uses ZK proofs for that. ZK Leaderboard is a project where when you have a game, a Web3 game, okay, that's fun, but it's more fun when you can beat other people, because winning is fun. And that's what the leaderboard is all about. It takes the proof that you got a specific score in a game, brings it to a leaderboard, and shows the winners. And you know that the people on that leaderboard are correct because it uses a zero-knowledge proof to do that. Now, once you have a leaderboard, other people can bet on it and stuff like that. But I think the leaderboard is a really important part of it. Edufy was a neat project that allows people to get microloans in a private way. So you can have some people like to contribute to charity, but they like to do so privately. So this way you are able to pay for people to get educational loans with microloans in a private way. Proof of Med, another neat idea where you have pharmacists or doctors that create a prescription and then pharmacists that fill it. But the current way to do it, at least what I've seen, is the doctor writes a piece of paper and you bring that to the pharmacy, and that's pretty much what you get. There's a lot of opportunity for some things in between there where you can just pretty much get anything from the pharmacy that you want. So this system would allow doctors to create a zero-knowledge proof of what the prescription is, and that can be verified at the pharmacy. Now, the one on the bottom right wasn't actually a Web3 prize, but I included it here anyway because it's pretty neat. So the ELIZA OS is an AI agent type application. And so this integrates ZK proofs into the AI agent. It's worth taking a look at and allows you to prove that certain things are true and improves your interaction with the agent. All right, so how are we going to help you build winning prizes? Well, what we learned in our online hackathon is that it's great to have mentors and people to assist you in doing these kinds of things, and that we separate the mentors from the judges. So we got our main development team in Milan. We got a DevRel team also in Europe and in India. So we should have round-the-clock support on our hackathon Discord. But what we've got, and I got pictures here of Steve and Rodrigo, they're two of our main contributors to the ZK Verify project. They try to sit here and help people every day. So if you're looking how to use ZK Verify or want to talk about ideas, we've got about 10 people here all together, but these guys are here to help you, and that's what they want to do. All right, so let's go over again what our award is. So if you go to the ETHDenver DevFolio, you can see what our award list. We've got a bounty video where I talk about it quickly. We got a ton of links to including the hackathon, the tutorials, all sorts of different things. We really filled it up. So we want you all to build a Web 2 or a Web 3 application that creates and verifies a ZK proof. It's got to be useful and interesting. I mean, it can be crazy, non-useful. We were talking to a group that was, proven how big of a fish you catch in a legal area. I thought that was a really cool idea. It doesn't need to be a serious idea. It doesn't need to be infrastructure like Rollup as a service or anything like that. It can be just a fun end user app. And we actually like those kind of apps because the more proofs that are sent to ZK Verify for us to verify, the better off we are. And here's the important part. The ZK proof has to be part of the application functionality. You can't just build an app, create a proof, send it over to ZK Verify, and then not care whether it got verified or not. And it's really helpful to our judges, which are going to be part of our extended team all over the world, to have a video of how it works. So that's my guidelines for you. Please look at stacking our prize with others. And if you have any questions, we're going to be here. We got a booth in the main floor where we sit at tables here every day and we walk around and just talk to people about projects. Thank you.
How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs down a found. Age, old to speak, young as each block, mind down. Professor Waze got the future on spinball. Urging notes, dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's ram stains. The beta test for Boodle. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks. Regen biddlers stacking stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby doo crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, not just 3 burner phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Hand it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing. You're just a rat with these firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it. Guitar slide. Guitar slide. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom. Dose, the efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spin, boy. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin, boy. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. wings flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spinball. Air notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3.
Hello, ladies, gentlemen, biddlers of all ages. My name is Riley. I am the Director of Integrations Engineering for Quad Network. And today, I'll be talking to you about how to multiply developer impact and speed for global adoption. And so really what that boils down to, it's a lot of fancy words to say, as developers, we can do more in less time with better tools. So I'm going to talk to you a little bit today about how we at Quad Network have kind of approached our building to tools and how we hope the industry as a whole moves towards building tools for their users. So first, let me talk a little bit about Quad Network to help you understand what it is that we are trying to build for when we design our tool set. So first, Quad Network is a scalable, programmable, proof-of-work blockchain network. Okay, we are a monolithic network, meaning that there are not L2s built on top of us, but instead, we actually incorporate horizontal sharding into a hierarchy of merged mined blockchains in order to do our scaling. Okay, and so what this means from a technical perspective is that we have a sharded address and execution space that we are taking into account when building on Quad Network. Okay, so that actually ends up being a pretty good bit of complexity for the user from an outside perspective. Okay, in addition to that architecture, Quad Network actually is a 2-token system. We have Quai, which is a gas token, which kind of applies to the saving model, meaning it is intended to be deflationary over time. And Quai operates within the Quai ledger. Okay, this is an EVM or account-based ledger. Our second token, which we call colloquially the energy dollar, is called Chi. Okay, Chi actually operates in a totally separate ledger from Quai. They still maintain, or they're co-located within shards, you can say. So for every shard, we do have both a Quai ledger and a Chi ledger. Okay, but Chi is a UTXO-based ledger. It is not an account-based ledger similar to Quai. This does kind of make it a bit of a fragmented experience from the outside. So this actually means our tooling has a lot of work to do to unify this experience for developers. Okay? So we kind of have this philosophy that we abide by, and I think this is generally applicable to other blockchain networks, but even beyond blockchain network systems in general. Okay, and the philosophy is the greater the complexity of the system, the better the tools must be. Okay, and so if we can put it into an example, if we have system A and system B, system A has a very high level of complexity, system B has, let's say, an average level of complexity. In order for a developer to do the same amount in the same time on system A and system B, the tool set for system A must be better. Okay, this is a very simple principle, but it actually does matter quite a bit when considering the complexity of your system and how you're going to approach building its tools. So let me talk a little bit about how we actually philosophize these design principles. Okay, we kind of want to take a first principles approach to building our tools. And so our main philosophy is for any user, we want to reduce their cognitive load or their cognitive burden associated with operating within our network. Okay, so really as a developer, whenever I try to build something or interact with any system, I have an intention of what it is that I want to do. Anything ancillary to that intention is cognitive load. Okay, if I have to consider something that is not helping me execute upon my intention, that is additional overhead that I should not really have to consider. So let's talk about how we actually tackle this problem in Quai Network. So like I mentioned a few slides ago, we are a hierarchy of merged mined blockchains with a sharded address and execution space with 2 ledgers per shard, EVM, UTXO. As a developer, if I just want to send an EVM transaction, if I just want to send Quai from me to someone else, that's a lot of additional things to consider that is outside of my intention. My intention being that I just want to send Quai, okay? So what we do is we actually say, let's just let them focus on the intention. Let's make sure that our tool set handles the complexity of this multi-sharded environment, handles the complexity of deriving addresses that are valid in shard, handle the complexity of routing requests to the proper shard in the first place. Okay, the complexity actually grows when you think that as a node or a miner, I don't have to actually provide data or mine for the entire network. I can take a slice, okay? We call them slice nodes. And a slice node is starting at the highest level chain, which we call prime. We can actually go back just a few slides to help envision this. Okay, so there are 3 levels in the hierarchy: are prime, region, and zone. Zones are, we could think of as any L2 or an L1. This is the chain that I, as a user, am interacting with. If I want to send Quai, I will direct my transaction to one of these zones. The higher level chains are actually to orchestrate state transfer across the zones. Okay, so let's think about this in an actual concrete example. So if I am in zone 1 and I want to send a transaction from zone 2 or to zone 2, let's imagine these 2 zones are co-located in the same region. Okay, if I want to make a transaction from zone 1 to zone 2, the region chain for that region will help orchestrate that state transfer. If I want to send a transaction from, let's say, zone 1 to zone 5 might be in a different region. Well, in this case, we're actually going to use the prime chain to orchestrate that transfer, okay, that state transition there. So there's quite a bit going on here, but me as a user, I only care about sending on zone 1 to zone 2. I don't care about any of the state transfer. I don't care about this hierarchy. I just want to do my intent. Okay, so let's go right back here. So that goes back to this cognitive load. Don't think about prime. Don't think about region. Don't think about any of this sort of trustless bridging. All you have to do is provide an address that's valid in zone 2, which someone will supply for you, and just the value. And the tooling handles the rest. Okay, so our tooling in this case is called Quais, or the Quais JavaScript SDK. That is our primary dedicated tool set that I'm going to be referencing here quite a bit. So our next philosophy is actually reduce the number of steps to complete a task. Let's just go back to this same example. I, the user, just want to send funds. It might even be within the same zone. Just another user in the same zone as me. I just want to send them Quai. Well, let's think about the steps required to do that. Okay, first I need to supply the to address, the value I want to send. I need to estimate gas. I need to get a gas price. I need to know how many transactions that I've sent so I can set my nonce. I need to make sure I set my chain ID, right? And this is, just to send this sort of very basic transaction, you kind of get up to, almost double-digit steps. And this is the most basic form of transaction there is. Okay, so what does it mean to reduce steps? And let's go back to what I was talking about with developer intent. If I'm a developer and my intent is to send value, I just want to provide my value to send and who I want to send it to. The rest should be done for me. I don't care about estimating gas. For the most part, let's say on average, the average user doesn't want to set these things. It should be set for me under the hood. And then if we start talking about Qi, the complexities continue to grow. Okay, so with Qi, not only is it a UTXO-based ledger, similar to how Bitcoin operates, but it is strictly denominated, very similar to how you might think about actual physical cash. Okay, and that's how we designed Qi, was to be electronic cash. We want you to spend Qi. Okay, and so the reason we do this is both for privacy and to make sure that you cannot differentiate between denominations. Okay, so like a 5 Qi denomination is a 5 Qi denomination. It is not scriptable. It is not non-fungible in any way, shape, or form. It is strictly to be transferred. However, you run into a problem when you're trying to spend several of these denominations. Not a problem necessarily, but an extra set of complexity. Okay, let's imagine you're at the store, you want to pay for something that costs $13. Okay, you might have a $20 bill, that'll cover it. You might have 5 or 3 5s, and those 3 5s would also cover it, but the change you get back will differ. And an additional set of complexity within Chi is that it actually enforces address non-reuse per transaction. What does that mean? Well, address non-reuse means that for every output within a transaction, there must be a unique address. Okay, so the way UTXOs work, we're not going to go into a whole workshop here, but just for any curiosity, you have transaction inputs, you have transaction outputs. And in the Bitcoin world, you might only have one output that goes to the recipient you want to send. These outputs can be of arbitrary value. It can be 0.025 Bitcoin. It can be 1 million Bitcoin. Does not care. Okay, but you can imagine if we go back to that example I just gave you, where you're at a grocery store and you're spending these inputs. If I have 3 5s, they go out as 3 inputs. And then I need to get $2 back, in this case Chi, I need to get 2 1 Chi denominations back in the outputs. Okay, you can imagine this change-making problem begins to balloon after a long period of time. Users have to manage all these addresses. Users have to care about how many addresses you give them in order for them to properly map it to the output. Okay, so we're going to get into that, how we solve that in just a second. But as you can see, like I mentioned, these complexities continue to balloon. So what we need to do is we need to say to the developer, you only need to do 2 things effectively. You need to sync, aka find all of your UTXOs that you can spend across all of the addresses you know about. And then you also need to just send the value. This should be a very simple interface for developers. It should be me expressing my intention through your interface. And my intention here is I just want to send Chi. I don't care about the complexities that happen under the hood. I just want to send it. Right? And that's exactly what we do. The interface for sending Chi is exactly the same as the interface for sending Kwai. There is no difference, right? And that is because we want users to feel familiar when using this product. The next thing, and this actually builds on how we implemented Chi, is in your tool set, you want to be opinionated, but you don't want to limit. So what does it mean to be opinionated offer a product that is opinionated? Well, when you offer a product, the default case or the easiest path is effectively your opinion on how the user should use the product. Okay? And in my understanding of the opinion of how a user should use your product, that means it should be the most optimal case for how your user wants to use it, or in the case of maybe a public network, it should be the most optimal use of this network. Okay, and so with Chi, like I mentioned, there has to be a unique address per transaction output. This means that even if I were to just want to send you 5 Chi, let's imagine, for example, I have 5 1 Chi denominations. So I'm effectively going to pay you, each one of those 1 Chis 5 times. Okay, rather than me saying, hey, I need you to actually supply me with 5 addresses so that I can send you these 5 Chi, we've actually come up with a solution that is much more elegant and better at preserving privacy for the user. That's our opinion. That's optimal both for the network and for the user. What this solution looks like is by effectively having a single payment code. Your payment code is effectively your identifier. You could be thought of as almost one single address, but we can use some fancy cryptography. It's called elliptic curve Diffie-Hellman, which effectively says, if you provide me this payment code, I can derive addresses for you. And then I can give you my payment code, and you can then derive those exact same addresses that I just derived. Okay, so what this means is we're not passing around, dozens of addresses every time we want to send a transaction to anyone. All I have to do is get your payment code. I can derive your addresses, right? And there is one sort of hop on information exchange, but that can be handled through smart contracts and done very seamlessly. So that is our opinion of the best solution. And of course, like I said, not limiting. Users can opt out of that solution. They can go through the effort and the additional time to maybe make a worse solution. But again, it would not be optimal, but we are not forcing you into a box to do it. And last, complement existing workflows. This one feels obvious. Okay, if a user goes about their day or goes about their work in a specific pattern, don't disrupt that. Find out where you fit into their workflow and build according to that. Okay, and so how we did this is we actually said, we have all this complexity, but we don't want a user to learn another library. They already have Ethers, and they have VM, and they have WAGMI, right? And the list goes on. So we're like, let's just fork Ethers. Let's get all of that complexity forced under the hood, and let's give them an interface they're familiar with. You don't have to go learn a new tool again. All you have to do is just use a different library, same interfaces, all new functionality. So these are about the tools of today. Let's talk a little bit about the tools of tomorrow. So we believe the tools of tomorrow make you build things that are more decentralized, right? If I'm building something on a blockchain network, chances are I care about decentralization. Why should I have to worry about Etherscan to get contract ABIs? Why should I have to worry about Infura being the only provider of data? Okay, and these are not attacks on these. These are fantastic services, but in our industry, it's don't trust, verify. But we're putting a lot of trust into these people. So for data providers, for example, I'm going to ask for some information about the blockchain state. You're going to respond, and I'm just going to trust you. But there's no reason you can't lie to me. Okay, so we actually invented this thing called NEPO-POWs, or non-interactive proofs of proof of work. And what NEPO-POWs are specifically meant to do is allow you to verify the data you receive on-chain is correct. We build this directly into the SDK. So the default path is now this means any node can be a data provider. Okay, this means that the SDK can route you to a decentralized set of nodes and validate that the answer they give you is true. Okay, this is actually a very sort of big deal in our industry because we have these very centralized roadblocks, and this is how we break out. And the next big thing is uploading IPFS or utilizing sort of a decentralized data storage network for storing contract ABIs. Okay, so this is another thing that we've actually already done. It's in production, and it's a standard we've created so that when you upload a contract, you first upload the ABI to IPFS, you receive a content hash, and you append that to the bytecode in the contract. That means if I have a contract address on Quad Network, I can get the bytecode, I can parse out the IPFS content hash, and then I can just grab the ABI directly from IPFS, and I can know how to work with any contract on chain. No centralized providers needed. The next thing is, we all know we're in the AI era here, of course. Everything is AI, from agents to developer tools to the music we're listening to right now, right? And so what does it mean to build a system and tools that are ready for the AI era? Well, number one's pretty simple. Just make your content and your docs indexable. Okay, this is actually something that a lot of companies get wrong, right? So imagine, you're using some very sophisticated, very JavaScript-heavy, fancy graphics for a doc site. It's actually very hard to web crawl that, right? And it's going to be hard for an AI to actually use that information and embed it into the prompt for it to be able to give you a good response, right? And so in order for us to empower developers, I'm not sure how many of you guys are using tools like Windsurf or Cursor or Replit or these tools that are helping us build, but it is imperative to use these tools correctly, you must have correct docs that are indexable by the tools. Okay, so these are low-hanging fruit, but the next one is actually preparing for the world where agents are doing the work. Okay, what does that look like? How do you integrate with that? Well, first of all, there's several actually kind of crypto-native AI frameworks. We've integrated with a few, but there's also really easy things you can do with NPCs to be able to kind of provide tools or common workflows to these AI agents. Okay, so they can say, well, if I have the Quai tool and you ask me to send Quai to you, I can just very easily use the SDK to be able to send Quai without having to worry about it, right? And this is only going to get more popular. We're only going to see more developers using these tools, more AI agents performing these tasks. So the next generation tool set needs to be built with AI in mind, and we're absolutely applying this and building with it every day. So I think we're right up here against time, but thank you all for listening here. I think there's a lot of work to be done. As a developer and as a builder, I know that we are only as good as our tools, and our tools have to continually be getting better until we fall, or else we fall into sort of a legacy system here. But I think we all know that's not where we are. So again, thanks everyone. I appreciate the time. Again, my name's Riley with Quad Network. Please come visit our booth, 521. There's plenty more to learn, and we're happy to talk about it. Thanks.
They cackle and shout, self-sustaining hugs flicker in the blackouts out. Professor Waze got the future on spin, urging notes dancing where the bottlenecks been. Professor Waze got the future on spin, hugging tomorrow with yesterday's ram stains. Chaos is not compeller, order's just a bug I forgot to unfurl. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop, a singularity jukebox. How you stay charged, espresso straight through my cortex. Who's your nemesis? Light runs dial-up-found. Age, old as speak, young as each block, mine down. Professor Waze got the future on spin, urging notes dancing where the bottlenecks been. Professor Waze got the future on spin, plugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Boodle. Oh, detox, right? Oh, detox, right? Oh, detox, right? Oh, detox, right? We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. Another bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we biddy led the city on sports and chains. We biddy led the city with regen brains. We biddy led the city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance of lightning.
Hey everybody, how's it going? I don't know if I've ever spoken in front of this large of a live audience, so this is quite intimidating. Getting yelled at. Okay. Oh no. Oh God.
There we go. Let's see. Is it back? There it is.
Okay.
Oh, whatever you did made it disappear. Oh, there we go. Can you advance it? See, this is the problem. Can you do it with no clicker?
Yeah. I can stand back here.
Does that work?
Yeah.
Cool. Sorry, brother.
Sorry. All right. Take 2. So yeah, I am going to do a talk on diving into shallow markets. And my name is Will. I'm the founder of Amalgam. Just a quick introduction of why this matters to us. We're building a DEX and a lending protocol that are both one single primitive. So think about a peanut butter jelly sandwich. The DEX is the peanut butter. The lending protocol is the jelly. And Amalgam is the peanut butter and jelly sandwich. All right. One of the problems that we had to solve when doing this is this concept of how to do lending with shallow markets. And this quote and the title is inspired by very well-known security research, currently at Paradigm, that wrote a paper on an article on lending and oracles that I would encourage everyone to go read. But this quote specifically talks about how shallow markets are dangerous to lend against. And the reason for that is that it's very easy in a shallow market to change the price. And if you can change the price drastically, lending becomes problematic. So why should we care? A few things that's happening in lending right now is it's actually quite centralized in a number of domains. The first being that in order to have an oracle, most lending is done with oracles. Those oracles are mostly sourcing off-chain data, and that off-chain data is coming from a centralized exchange. And so you can't get a lending market price feed without first getting a centralized exchange listing. That doesn't seem very decentralized. Another issue is that many protocols like Aave use allow lists to limit what tokens can be borrowed and traded on those platforms. And they do this because they want to protect the market from shallower traded tokens from being manipulated and used to taking the more important assets or the rest of the assets. And then, lastly, I would also say another bucket here that's not on the slide, but is configurations. You have now other lending protocols like Morpho that are heavily relying on analytics firms to say, hey, here are the parameters that make this specific thing able to be borrowed, right? So a lot of great analytics teams there, but you're still trusting somebody else. You're trusting some analytics firm to protect you. And so ideally, in this decentralized world, I'm very excited about trying to push the boundaries of what we can do on chain with less centralized controls and really being more decentralized. So another really important thing why this matters, this is about $500 million in hacks across some of the more famous lending attacks that happened because the price was changed drastically. So Cream Finance, Bonk, Mango, Compound, and then these are some quotes from different articles, but we have the highlighted sections in which you can see the main point is that the price was changed. Compound, there's a 30% increase in price that led to forced liquidations. Mango had, that's like a 30x increase going from 3 cents to 91 cents. And then Bonk, this isn't quite a price change. It was more of a, hey, this is now worth this. And the protocol being like, okay, and then leading to a huge hack. And then lastly, Cream was a thinly traded market, but also there's a little more to it. But basically, they changed the price and then profited. And so always the same formula. The art of infinite borrowing is post one asset as collateral, change the price for that asset, borrow as much as you can, and profit. And these hacks were all the same simple formula. How the price was changed might be a little bit different, but then once the price is changed, it's very easy to just take all the money. So I spent 2.5 years thinking about this problem, and decided to try to tell you guys about it in 20 minutes. And so some of the naive approaches about how you can potentially solve this is one, why don't you just slow down the rate at which you let the price go up, right? Make it take longer to update the price, right? And there's a few drawbacks of this. If you take a really long time to update the price, you may not actually be able to execute a liquidation when the assets of certain positions have led to the position being completely approaching insolvency, right? You want to be able to liquidate. So you need a price that doesn't move quickly, but also moves quickly. Okay, that sucks. Then additionally, you can maybe rely on arbitrage, right? If there's some external market, well, we assume if that external market exists and somebody's trying to manipulate the market that we're using as the source of truth for what these assets cost, if we slow things down enough, then people's cost to attack that price keeps going up and up and up. And the reason is because somebody, on the manipulated price can, sell their assets there and then buy them on the external price, and they can keep doing this and keep making profit over and over again until the prices sync together. The problem with this is that if the external market is very shallow, then it may actually be just as easy to manipulate the price on your price feed and the entire market, right? And so this is bad. We still have the problem is you can move the price, you can create the infinite money attack. So and then also, what if there's no external price? Your source of liquidity is the only source of liquidity, and so by changing that, it's very easy to then do the infinite money attack. So what we came up with to solve this is, on one hand, we don't think about price as a single number. We think about it as a range. So we have some confidence that the price is in this range, and that's defined by a few different lengths, time-weighted average price mechanisms. So this is a well-known DeFi thing. Uniswap has a time-weighted average price, or TWAP, and you can use a few different of these at different lengths to create an interval that you think the price is within that interval, right? And then one side of the price moves very quickly, and the other side doesn't when you change the price, because the longer interval is very sticky, it's hard to move, whereas the shorter interval moves fast enough to allow for liquidations when you need them. And then additionally, one way to make these manipulations more expensive is to just say, hey, I think this is an allowable, reasonable amount that we can allow the price to move per block. And if somebody is moving the price more than that per block, we can say, oh, that's probably not good. We'll just ignore that, right? So we actually take the price every block and we say, oh, if it's within this range, then great, that's the price. And if it's not, we're going to ignore that and just, record this like max allowed price for that block and just keep on moving. And then now all of a sudden, if somebody is trying to manipulate the price, it is much more expensive because they can only get the price to be recorded every block a little bit higher every time with respect to, if they want to do 30x, it will take a lot of blocks to get to a 30x, as we saw in the bonk attack. Some other things, and this has been used in Morpho, is instead of having a many-to-many relationship for lending, where one asset of the many could be manipulated, and then you take the rest of the many in the infinite money attack, then instead a better way is to do it one-to-one, right? And if you just have this one-to-one, then say you have a shit token or somebody rugs some coin and it goes infinitely from some number to 0, this is bad. This will be bad for that pool, but it doesn't affect the entire protocol. It just affects the liquidity providers that felt like they should trust this shit coin to not be worthless, and they were wrong. Additionally, another concept that we came up with is right now all swap fees are linear, and so they get bigger the bigger the swap. You take some percentage of the swap and you call it the fee. And so one interesting thing that you could do instead of having a linear fee is have a quadratic fee. And so what that means is on small swaps that don't have a huge impact on the price, you can charge a really minor fee, because you actually want that volume. That's probably uninformed trading volume. That volume is not going to wreck your LPs. Now, when the trades get much bigger and they are wrecking your LPs, they're resulting in permanent loss. Everyone's talking about loss versus rebalancing, and everyone's wrecked, right? You could actually increase the fees for those swaps. And so we do this by looking at the effect of a swap to the price, and the bigger the effect of the swap to the price, the bigger the fee, but that growth is quadratic instead of linear. And so if you wanted to 4x the pool, you might pay a 40% fee, and then all of a sudden this infinite money attack gets much more expensive. So a few other things, these are all out of order, but we actually look at each position when we open it and we say how much slippage would get created if this was liquidated. And so why don't we just take that number, take that increase, and add it onto the debt. So maybe they wanted to borrow $1 million, but the slippage would be like 20%. So we're saying, oh, actually, you know what? You're borrowing $1.2 million before we calculate loan to value. And what this does is that bigger positions require a lot more collateral, and smaller positions don't. And this just helps to protect against the more risky loans. One interesting thing that you might ask, and we also had to solve this question, is, okay, maybe I can't do this really big loan, but what if I did 100 or 1,000 small loans that adds up to the big loan? How do you protect against that? That slippage is smaller. So we also had to do a lot of research into that I won't get into, but it involved trees and figuring out how to do things that should take constant time and linear time, and it was a lot of brain damage, and we're really excited that we figured it out. But anyway, the last thing that I will say is that we're really excited about trying to push the boundaries and make a permissionless lending protocol that allows lending on any asset. And I'm really excited to bring this thing to market. We will be launching in probably end of March or beginning of April. And excited. Anyone who is here, I think the real thing is that if you know what I'm talking about after all of this conversation and you want to ride go-karts tomorrow, you should come talk to me, because we have a great event. should come, ride go-karts. It'll be a lot of fun. So feel free to ask me any questions about this after the talk. And that's all I got. So thank you.
Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not a compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like runs dial up found. Age, old to speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, detox time. Oh, detox time. Oh, detox time. Oh, detox time. We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen fiddlers stack in stacks. For we biddy let this city on sports and chains. We biddy let this city with regen brains. We biddy let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pity let the city on sports and chains. We pity let the city with regen brains. We pity let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The Etherverse will leave you heated. We don't need your legacy, 'cause regen memes are proof of brain. Big let the city on sports and chains. We big let the city with regen brains. We big let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Alliance architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Do 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 with a do do.